pull request, we run a number of checks, really just to make sure that all the code that gets contributed into the package is all working as intended, and that it's easily maintainable. You know, for example, we run a code style check to make sure that the style follows the recommended Python Pip8 style guide. We also run changelog checks to make sure that a changelog has been included within the pull request so that can be rendered in the next release. We have a number of unit tests which test behavior of lots of the functions within SunPy. We run these unit tests across a number of different jobs with different environments. So we run these across Linux, Mac OS, and Windows, as well as all of the Python versions that SunPy supports. We have an additional job that runs these unit tests with the oldest versions of our dependencies to ensure that the code still works as we intend with the older releases of our packages that we rely on. And we then, of course, we test our documentation. We have tests that run to pick up issues such as if we reference a particular item, a particular function within our documentation to make sure we've named it correctly, that the links will all work. We do checks on our gallery to make sure that the gallery can build without any errors. And then our hosting provider, Read the Docs, also run a check on that to make sure it just is able to build on their system. So we have some online tests. These are similar to the unit tests. We just have some additional unit tests which rely on remote data. These are quite slower in comparison to the unit tests, and unfortunately they are quite flaky due to the issues with communicating with remote servers from time to time. We have figure tests. So these basically mean whenever we run our plotting functions, we want to be sure that we are producing consistent plots, that if we change something in the code that it doesn't make some line move by a centimeter somewhere, because that sort of thing can be tricky to work out unless you're actually comparing the actual figures themselves. So we're able to achieve this by comparing the figures generated by a test function with some baseline images that are stored in a separate repository. We run these figure tests on the current stable versions of key dependencies such as SunPy and matplotlib. And we also run these tests on the latest development versions of these key dependencies so we can pick up any issues before they become problems for our users. We have test coverage. So anytime someone contributes new code or makes a change to existing code, we want to be sure that this new code is being tested and the tests affecting older code are also being remained. So basically this just means that we can see which lines are being tested and we know with greater confidence that our unit tests are performing as we expect. So those are all tests that would run inside a PR. Now, outside a pull request, we run some additional checks. So these checks will run as well when you merge a pull request into a particular branch, as well as tests which run on a daily schedule. So examples of these tests are build tests. So anytime we merge a pull request, we will test that the SunPy repository is able to be built into a package suitable for publication and suitable to be then installed directly via something like pip. So that way we can always be ready to create a new bug release whenever needs be. We have scheduled tests. These run every day at 7 a.m. These include some additional stuff that doesn't really need to be run in pull requests, such as making sure that SunPy works when you only have the base dependencies installed, and also making sure that SunPy works on the very latest development versions of key dependencies such as SunPy, matplotlib, Power 5, and some other things as well. Okay, so now for the current services that we're using. So most of our unit tests and documentation tests, they're all run inside GitHub Actions. So GitHub Actions provides the sort of server sort of infrastructure, and within those servers, we're running Tox, which is able to let us really tell it which particular versions of packages we want to be running within this test environment. The tests themselves are run using PyTest. PyTest is able to go through your code, collect all of your unit tests, and then run them, and then report back with the results from those tests. For our figure tests, instead of using GitHub Actions, we're actually using CircleCI. This is because CircleCI has very good facilities for hosting HTML artifacts, which makes it very useful for hosting our HTML summary of our figure test results, so we can actually see the figures. And our code style checks are run inside pre-commit CI. Pre-commit CI provides a very fast environment for running these types of tests. And for some of our code style checks, within a pull request, we can just type in a comment to this particular app, and it is able to then automatically commit the changes necessary to fix any code style issues. For our coverage, we're using CodeCov. Our unit test upload to this service, and it reports back with the results. It can report back from multiple different environments at once and merge them all together. We are using Read the Docs for documentation hosting, which is great for maintaining multiple versions and keeping everything automated. And for our changelog monitor, we are using Stuart's server, which is running the Baldric app from Open Astronomy, or a modification of that, possibly. So then we're also using this thing called Me6box for backports. So basically, anytime we have a pull request, it's going to be targeted to the main branch, which is always going to be for either the next major release or the next minor release if we're currently on a something.0 release. So basically, with the backports, it allows us to quickly backport something so it can make it into a bug fix release. So that makes it so much easier because we don't have to duplicate our efforts, because the bot will duplicate the pull request to a different branch automatically for us. So we're also still using Azure pipelines. This has been used by some of the affiliated packages as well, although SunPy core isn't using this currently. So that brings us on to the recent updates, where we do have this migration to Azure pipelines to GitHub Actions that we did for the core SunPy repository, as well as some additional of the affiliated and sponsored packages as well. This was sort of, we did this basically because there was some issues getting Azure pipelines to run. We had issues where the runners was being reduced to 0 runners, so we weren't able to run any tests for periods of time, and we had to contact Azure, and they were able to restore it, but it went down a few times. So basically, we just decided that it would be best to migrate to GitHub Actions. However, this has worked quite well. We've been able to set up a new repository of workflows. These workflows have been used by other packages, AstroPy as well. So there's less duplication of effort, and it provides a nice environment. So GitHub Actions, I find, it integrates quite well with GitHub, so it makes it quite nice for both people contributing to the package as well as people maintaining to see how the tests are running within the code. We have 3 main workflows that are part of the Open Astronomy workflows repository. So we have a testing workflow, which you're able to supply a list of Tox environments, and it runs those tests as separate jobs. And we also have 2 workflows for publishing packages. So these workflows are able to build the Python package and then publish it to something like to the Python package repository PYPA, or yeah, and also they can publish to Conda as well. So one of them is for publishing packages with compiled code, and one is for publishing packages without compiled code. Yes, so then we also have new HTML dashboard for viewing our figure tests, as you can see on the right here. This sort of provides a nice environment for seeing how our figure tests are performing. They're all sorted so that all of the worst tests that are like failing the most should appear higher up, and the tests that are fine should appear near the bottom. You're able to search through all of the tests. So, if you know the particular name of a test you want to see, you can type in the name in the search box and it'll just automatically just search through. And then you can also sort and filter the test results based on, the status of the test. Does it have a matching image, a differing hash? What's the name of the test? What's the error in the images? Things like that. And then when you click on a particular image, you can see there that it's overlaid with the difference if there is an image difference. But when you click on that, you can then see the three images separated. So you've got the baseline image that we store in a repository where we say, this is what ideally the image should look like. And then over on the right, we have the image that the test produced. Now, looking at those two, they look basically identical. You couldn't tell the difference, but when you subtract them together, you can see that there's all these bands that appear due to the grid lines on just being moved slightly. So this is sort of the benefit of these figure tests. We're able to see what happens, and particularly with these reports, they're able to show us exactly what's wrong, which makes it much easier to diagnose any problems within particular test functions. And this, of course, is both desktop and mobile optimized. Okay, so this brings us on just to some future updates. So currently, there's plans to improve the benchmarking. I think Albert's going to take a look at that on Friday. I think I saw something in the list of plans for the hack day. These use airspeed velocity package, and we store the test results in a separate repository. They run on a particular schedule. The challenge with these is that it can take quite long to run at times because it has to check all of the past commits or past versions, something like that, to sort of see when something changes. But the benefit of this is we can really pinpoint which commit caused a decrease in performance. And yeah, David has sort of integrated a way to sort of mock the HTTP requests that our online tests make. So this way we are able to, instead of going directly to the remote servers to request data, we can just go to something that's stored in a GitHub repository, a separate GitHub repository that SunPy maintains. This should improve the speed and reliability of these online tests. And of course, then on, say, a weekly schedule, we will update these HTTP requests from the remote servers. So that should reduce load on both the remote servers and reduce the flakiness of our online tests. So something to think about. I think we plan to expand this to data files, but currently it's set up to just use text files. We should look into data files so that we can really have a coverage of everything, really, because I feel like then that would really reduce the flakiness of the tests. Yeah,
do we know,
maybe we should.
I was just going to say, do we know, has anybody tried to use that with VSO yet? VSO is a bit of a special case because it's SOAP, not REST, but I think it will still work. I'm just curious whether anybody's tried.
Like, it's all HTTP requests, so
I think. Give me a couple of minutes and I'll have a look and see if I have here.
Yeah, it uses SOAP, doesn't it, I think?
Yeah, I think it should still work, but I don't know.
Yeah, I think it should. Like, I would assume as long as it's using standard HTTP, it should just be able to record that and play it back as though it's talking to the real server.
Yeah, I think Zeep uses requests underneath, so I'm pretty sure it will, but we'll find out.
Yep, it does. I've just looked on the cassettes repository that and yeah, I'll stick a link to one of the files.
Okay, cool.
In the chat if you want to have a look, but it does work.
Brilliant. Yeah. Yeah, and then just some other things where we're currently still using Azure pipelines for some of the sponsored packages. This is basically because it just started working again and it wasn't causing any issues. So should we bother migrating them all and just leave it until something breaks?
It was only core that they were taking offense to.
Okay, yeah.
I think my plan is, as part of the Ostoffel Waffle grant, to do work on standardizing all that infrastructure. It's kind of what the next session is talking about a bit as well.
Yeah.
Some of it.
Yeah, and then Stuart, you were saying I think that you want to do a dashboard for all of the CI across all of the SunPy projects, really just to get like this overview of everything, see how everything's running, so that you don't have to go into individual projects to check what's broken, so that we can more quickly fix any issues. And yeah, that's everything I have here. So yeah, if you have any more points of discussion or anything.
Something we were talking about as we were walking in this morning was whether it would be worth setting up our own replacement for the artifact support on Circle CI, so we could move the figure tests off. So we only have one thing. I don't know, there's a trade-off in complexity of managing our own GitHub pages at action artifact setup versus maintaining the current Circle CI thing, which is definitely the gnarliest bit of our CI config.
I had a brief look in to see if there's any services that you could say have a GitHub action that's able to push a directory to some remote artifact hosting service. And yeah, I couldn't find anything. I might have been able to find like one thing, but it was very expensive. But yeah, because really we need something that's able to host HTML artifacts. Yeah, like there is some services out there for say hosting like small prototype websites and stuff, but yeah, they were quite expensive. Yeah, we basically want ideally some like GitHub action that's able to just push a directory and give us a URL that's available at, I guess.
Yeah, we could use GitHub pages. So we could have yet another repo that our CI automatically pushes to and run GitHub pages on it. But like
they would have to manage versions and delete old stuff as well.
Yeah, we would have to. We could probably do it. I don't know where. It's not so much that we couldn't do it. Is it worth it? Right? Like, what's the trade-off between maintaining our current Circle CI config versus setting up?
I mean, I would argue that there isn't much work to be done changing the Circle CI config. But we have to change the convenience images. That's going to be great.
I thought I did that already.
Well, no, we do it.
Did I just do it on different repos?
We have to do it on the rest of the repos.
Okay, yeah.
But I personally would argue that there isn't much work to be done maintaining the Circle CI config. So
probably not worth it.
Yeah, I would argue if there's time to work on the CI, there's more interest. There's more important things, especially if Albert wants to PR benchmarks. AXB working would be better.
Yeah, that's fair.
Circle CI, replacing Circle CI. Sorry.
Yeah, I think unless there's any clear benefits, just if it works, just leave it. I think until it breaks. Yeah.
Yeah, I guess a quick update on the VCR high stuff where we're trying to mock the online test. So I think it's going to end up being a fairly complicated setup. But I think given how long our online tests take and how flaky they are, as you said, I think it will be worth it. So yeah, maybe that's something we should add to maybe it's too small for the roadmap, but yeah, as we've gone through this week, I think what I find really useful to get out is like a list of projects that's distinct from the issue tracker. And maybe that is the roadmap, and maybe it isn't. But an example would be like doing the SunPy stuff.
I think that might be useful just to add to a project on the repository for SunPy boards, and we can worry about where that goes later on.
Yeah.
Just so we,
Yeah.
just so we remember.
If it's like org-wide, the SunPy project repo
Yeah.
is probably the place to track that kind of stuff.
And that's where projects live by default now on GitHub anyway.
Yeah, I'll go for that.
So, yeah.
Oh yeah, I meant if you want, like there is the SunPy dash project repo for coordinating project stuff.
Why aren't we just using projects for projects?
But it's like the SunPy project repo is an issue tracker for the org,
Yeah.
as opposed
Oh, well,
to
okay, all right, so it's different. Yeah. There's scope for both.
It has nothing, no, it's an issue tracker, sorry.
yeah, no, it's a good idea. Anyone else have anything on CI? I want to say thank you again for your work on the CI, Connor.
Yeah, no problem.
Especially making GitHub Actions do all of the things that it did in the speak not of base 64 encoding Python script.
Oh yeah. Oh, that yeah, that's such a workaround to get that all working. Yeah, because basically GitHub Actions doesn't let you do for loops, and we want to be able to like loop through a list of Tox environments. So we just found this really like hacky way of doing it, where we like have a Python script that's able to parse a string, which is actually YAML, and it's able to parse that and then give back a JSON matrix of jobs, which then GitHub is able to parse. But this whole Python script for doing that is encoded as a base 64 string within the workflow file, because it can't refer to a remote file. Yeah, it works.
Okay, shall we move on?
Yeah.
Yeah.
So the next thing is standards and code formatting, or standards and formatting.
Well, I didn't prepare any slides. I don't know you.
So
Shall we start with the least controversial stuff, which is the org?
well, so I just want to say like why I wanted to bring this up, right? Part of the NASA funding is to make it easier for us to maintain the collection of repos we now have, right? We're now very much a multi-repository project, as we've discussed repeatedly so far this week. And part of the NASA funding is to make it easy to maintain, make it easier to maintain that, and to because like there may be people that end up with more repos or whatever. And one of the things that I want to do is make sure that all of the sponsored packages, all of the packages under the SunPy org, are the same. They have the same style checks in them. They have the same contribution workflow. Like both from a contributor perspective and a technical perspective, is as uniform with them as possible, right? Like if somebody knows how to contribute to core and they know their expectations on style checks and whatever in core, they should feel perfectly at home contributing in all the other repos. So there's some technical things I want to talk about here, like code formatting and CI stuff, but also I want to move this discussion into like how we review changes, like what the workflow is on all of the repos. And basically, if we do it on core, we should be doing it on all the rest of the sponsored packages as well, so that like expectations are the same over all of them. I guess the first thing to say is, does anybody object to this? Because it's just
It's a philosophy of making it easier for people to.
Well, it's not necessary.
Yes,
Yeah,
I like it.
yeah, but it also it's not necessarily making it easier for like Nabil to continue to do updates on all of the packages and stuff. Like if we're like,
So just
please PR everything Nabil because or whatever, right? Like,
just to be clear, this is for sponsored. It's for sponsored packages, not
Anything under
affiliated
the
packages.
anything under the SunPy GitHub organization.
yeah, sponsored. So the key difference between sponsored and affiliated, right, is that we're the ones maintaining them. So we should, if we're maintaining them, we should be maintaining them the same. And also, it's really upsetting me that Laura's put her NDQ sticker the wrong way up on her laptop.
Shame.
It's the right way up when it's closed and you're seeing it from Laura's point of view.
That's true.
Yeah, and then everything else is upsetting.
Yeah.
Whatever mood I'm in, I'm like, oh.
We're going to have to discuss this in a bit.
Oh my god.
But also for packages that want to follow the template, it would be good to make it easier for them to have similar stuff as well.
Yeah. So from a technical perspective, one of the things I want to get running is ultimately this is going to be a few stage process, but ultimately what I want is we have the SunPy package template, which is a package template for all of the sponsored packages and any affiliated packages that choose to opt in. And if we want to change the CI config for like pre-commit or something, we would modify it in the package template, and then a bot would PR those changes to all of the repos. Obviously, I think the actual contents of like the GitHub Actions CI config file with like the TOX jobs that are run are probably going to end up being unique to repos because different repos have different test jobs and stuff. But
there are parts of that.
There are
parts of that TOX config which are the same across.
Yeah, exactly. And as much of it as possible, we can unify the better, I think.
Yeah, so I don't know how if you want to describe our long-term goals for that workflow, and we agree on what we want to do. So I mean,
yeah, I'm going to have to load my tracking issue
so
that I
people who
remember
aren't
what's on it.
too familiar with the package template, it's a cookie cutter. A cookie cutter is how to describe it, a package creator library.
It's a thing that runs Ginger on a folder. Like
it's like if you want to make a website, but your website is actually a repository of code. It's kind of weird.
It's a template, and you can give it variables like package name, and then it inserts your package name into the template in all the places that need package name. And you can like choose to turn things on and off. So you can be like, do I want to use GitHub Actions? Yes. So it will generate you a GitHub Actions CI file. Or you could say, do I want to use GitHub Actions? No, and it just won't generate it.
And so the good thing about this is that those questions can be saved to a file, which you can store in the repository. So you can update you can read it, and in certain places update the files that are in the repository, which becomes a problem if you have. There are some problems with that current workflow, which I guess Stuart will address.
Steve found a link cookie cutter that does incremental updates the other day, which is called Craft. And I've just thrown it in the element room, and I'm so happy that I don't have to write that because somebody already did. So.
Also like your logo.
Yeah. I'm not sure whether there's much else other than like that workflow of all infrastructure changes happen in the package.
The other thing I would like to see org-wide would be, so we don't have a consistent labeling system across our repositories.
Oh yes.
So for example, in core, we have tried to add, package novice labels, good first issue labels, Hacktoberfest, labels, those kind of things. And they are not synced across repositories. So if you want to add, let's say you want to add them to NDQ, but they haven't been added to NDQ, you have to do it manually. If you want them to look the same as the ones in SunPy, I guess it's kind of weird if they look different, they have different text, the tag might actually be different itself, even though it's different words. There's no way to sync these across like a fixed set of useful tags that would be used. But the useful set of tags will be useful for all useful repositories.
Are you one other org that I work with that does that, and all the repos have only that set of
so we
issues?
can't-
Are we
we
talking
can't-
about having
I'm talking
the
about
ability for
extras.
extra ones as well?
Yeah, so I'm talking about a fixed set of, say, the package knowledge system, good first label, good first issue, a set of core labels that we apply to all of the repositories, and then if then repositories themselves want to add new ones for example, we can't add a map.
There would be no
label.
point having a map label in ND.
Yeah. Okay. That'd be kind of weird to have.
Right.
And so I'm not suggesting we force all the SunPy onto the rest, because that would be silly. But yeah, a fixed set of tags that are used the same across that are universal would be.
Just going to put this issue in the chat. So a lot of the kind of brainstorming for this discussion, or like the features we want to see across the org, in this issue I just posted in the chat on the SunPy project repo. I guess I can share my screen for a second. At some point, I probably need to like refactor this issue out into a project or something a bit more interesting than a markdown to-do list, but I haven't got around to that yet.
If only there was some way to easily convert it to an issue.
Yeah, if only GitHub had added a feature where you can click a button and it goes into an issue. I love GitHub sometimes.
Yeah, so I think my view, and I assume Stuart said, is that we want to ensure that if we keep spawning more repositories, we have the ability to maintain them and to update them without having some to manually sit down and okay, we get our CI. For example, we haven't moved to actions in all our repositories. That isn't a problem because Azure still works. I still prefer Azure on some of my workflows.
Because you don't base 64 encoded Python script.
But it's kind of weird that we now use different CI servers across a bunch of repositories depending on our mood for our CI. Right. And it's not, it wouldn't take too long to update them, but there is work someone has to sit down and do instead of something more useful.
And the word long depends on the expertise of the person, right? I mean, if it ends up being like, to be able to all work for everybody, then per package that's less work, but less.
I mean, the bill is more interesting than converting all the repos to GitHub Actions.
Right.
So,
right, exactly.
So I don't know if anyone has any other thoughts on what they would like to see for like repo-wide, so organization-wide management. If there's something they've had, like in science, like, oh, this would be really nice to roll out to. I don't want to have to maintain this. This seems like it should be like organizationally managed instead of individually managed.
Right. No, that makes sense.
I don't know if you have any ideas or any thoughts or something in the future to. No. If you have an idea, there's an issue there. It's just a. Add to. Is there anything else you want to talk about for this before we get on to the more controversial stuff?
Do you want to say something about it?
Yes, sure. I can do that. So we have.
So okay, before Stuart says that, I want to back up a level. So the original package template, or not the original, the open 21's changed substantially since that package template existed. So yeah, we're trying to maintain a package template which details how someone should lay out a Python package. It has extensive documentation as well as a cookie cutter layout that you can apply. Whereas the SunPy, which is very useful, very good, it's where I point people who haven't created a Python package before and they have no idea where to start.
The idea with the Open Astronomy one is that it's actually primarily documentation on how to build a Python that follows.
It's primarily documentation first, second, and that makes it give to people who are new to Python Python packaging. Not saying. And so the plans, I think the plans originally for the SunPy to take this repository, apply a bit of SunPy on top that would then be used in a similar vein.
Yeah.
However, I don't think that's kind of worked out that way, because
Well, both the SunPy package template in particular, but also to some extent the Open Astronomy package have been a bit neglected for the last few years, just due to lack of time. But my idea now is basically that the SunPy package template should be for sponsored packages and affiliated packages who want to get into what we were just discussing about standardizing stuff across the org. So if you're writing an affiliated package like, say, AIPy, where you don't want to opt into all our development workflow, then you would use the Open Astronomy package template as a starting point. But if you were spinning up a new package in a SunPy org, or you wanted to like pretend you were, I guess, then you would use the SunPy package template, which would get you like our pre-commit config, our actions config, all our issue labels, like all of that kind of stuff would come along. It would like opt you into all our bots, which will come along and reformat your repo for you, like that kind of stuff.
So you wanted that, but you still wanted to keep control. You know, wanted to be in SunPy work, but you wanted it to work well with everyone.
Yeah, I think how it will end up working because of practicalities of GitHub is if you use the SunPy package template, you would have all the configuration files to opt into our bots, even in you're under like a different namespace other than the SunPy org. And then if you, our bot will come for you.
I guess is this, I think when we're, I realize this is slightly out of scope for this session, but you know, when instrument teams come to us or anyone writing an affiliated package, I think especially instrument teams and say, okay, how should I structure my Python package to be more like SunPy or whatever? What is this the right thing to point them towards?
I think we will have to explain like basically what I just described. Like when would you choose the Open Astronomy packaging template and when would you choose the SunPy one and why would you choose that? Is like do you want to be ruled by our bots? Yes or no?
Yeah.
Yeah.
Yeah, I'm just I guess worried about handing something off or suggesting something that's like super opinionated.
yeah, I would say if say someone came to me for a page, I would point them towards the Open Astronomy one.
Yeah. You should be, because the SunPy one will be based on the Open Astronomy one. If you start with the Open Astronomy one and you decide later on that you want to opt in to all the other stuff that's in the SunPy one, it should be easy. That should be a trivial upgrade.
Is part of your like vision for this to also then improve? All right.
I mean, I think with the Open Astronomy one, there's bits missing that haven't been documented yet, and there's a few little things that could be added and tidied up. Like there's no CI stuff in here at the moment, so I might probably add a basic GitHub Actions workflow to that and stuff.
Does that piece of cake change not
I thought I got rid of that too, but I could change it to recommending craft anyway.
Yeah.
So like there's work to be done on the Open Astronomy guide, but I think what's there is good.
Okay.
There is more stuff that could be added, but I think what's there is solid.
Okay.
Okay, does anyone else have any comments on what we've said so far before we start arguing technicalities?
Cool. No, that sounds reasonable.
Okay.
Should we start with the least controversial?
I feel like we need a list of things we need to standardize. What is currently different over the different orgs, other than?
Okay, what you mean? What is SunPy not doing that everything else is doing, except NDQ? That's
Yeah, and vice versa. To
no,
some extent.
No.
Well, there's some stuff in core that aren't in the other packages, not just like stuff that exists in pre-commit.config.
Well, most other repositories are still using Azure, but that's not really. What else? So across outside of the pre-commit, I'm not sure what else I can think of.
I think it's some workflow stuff. We don't tend to be as,
By workflow, you mean Git flow?
we don't tend to be as rigorous with review and changes on the other
Right.
packages than we do as core.
Yeah, okay.
Yeah.
Yeah, there was.
Okay.
Normally when people submit pull requests to the other Pocket packages, I am the one that reviews them by myself and will eventually merge, which isn't sustainable long term. But I'm not sure how we fix that with it.
So one thing, for instance, is do we turn on the one required review thing that we have on core on all the repos?
Okay.
Like as a concrete example of a setting that we have turned on core that we don't have turned on most of the other repos.
As long as I can bypass that, yes.
I mean, that's the thing. It's like, yeah, that would be
Why
great.
do you need to bypass it?
Because who is going to review a block pull requests for me?
I might be okay exempting a blog from this entire discussion.
Who's going to review a block proposal? Who's going to review Sunkit image pull requests? Who's going to review?
I'll review something.
So somebody
On
should.
yeah, but on the timescale that is less. Okay, also, specifically reviews on timescales that are not 3 years. I've done pull requests to other repositories where I have not seen a review for 3 years. I need them merged in that is on a timescale that is not maybe 6 months.
I think one of the interesting things, I think like an interesting question is like, why are some of those other repos don't get the same?
Yeah, I think that's the deeper
Right,
problem.
right.
That is the.
Have people just have less people got notifications turned on for all our sponsored packages in core, right? Like,
The main problem is why am I the only one doing this? Right? That's the actual problem.
Yeah,
Well, I think
we shouldn't be trying to hack around that with workflow. We should.
I think part of the reason is because you're always doing it, right?
Yeah, that is.
I mean, not to be like, I think, and then people tend to rely on you to do it, and then it's like, well, it's already done. So I think we need to be.
But I would, this is the thing, I would bring up the point where we got the Suvi code pull requested. Who here would have sat down, gone through that properly that I'd spent time on? We got that, that got merged in, I think, within 3 months.
Yeah.
It took me a long time, but went through it. And the question is that if I need, well, in that case,
So then you were the single approver.
Yep.
So that wasn't an issue.
No, but I actually opened the pull request originally. There was a whole thing with Gitflow that needed, there was a problem with the original PR and the history. And so there was a whole bunch of repositories that I am primarily single maintainer. If there's a Pi FLCT change, I will be the one who will open the pull request, well, I can't approve my own code, but I will open the pull request, check the code, wait for the CI to pass, and then launch. That is that workflow, and I am the one in all stages.
But I think like
who is going?
I think for a sponsored package, I think part of being a sponsored package is that there should be more oversight than that.
Oh yeah, no, 100%. I agree. I just if we're going to say there's more oversight, I actually need someone else to be there to provide the oversight.
Yeah, well, I don't think it has to be one person. I think if we start building up a review queue on all of those repos, then somebody's going to have to start looking at it. Like, I think.
Yeah.
Maybe.
I would say I haven't been reviewing stuff like this because I don't know it's there. Personally.
So
how could we fix that?
Well, I personally watch every repository I have my access to.
Yeah, I mean, I think I do too. But.
And so I get
my GitHub notifications page is a godforsaken hellscape. So,
but if you had it that if you had to have another person to review it, it might force people and like ping people and just be annoying. Like
I can be annoying.
But like if you force them, you'll do it, and then it will have to be done, right?
Have you ever pinged Element to ask for a review?
I could, but people, are people actually? If I pinged someone on a repository that had a 5-file 1,000-line changes, is someone here going to right?
I think
this is the pull request that someone submits to us, and I go, well. I can review this, but other people are going to want half this change committed 5 different times.
Yeah.
I think there's a different conversation in the
Yeah,
case
there
of
is a- yeah,
Sous Vide PR about like when the first time someone's opened a pull request and like
But say,
should we be more lenient?
Yeah,
and less
I don't think the Sous Vide PR is a good
no, but
example. for
say,
this discussion.
because Kevin is planning to PR code to SunPy image once for funding, right? And that potentially is an algorithm that is one pull request, 1,000 lines or whatever, or 2,000 lines, no matter how complicated the algorithm is, with examples and whatever else. Right? We're going to go, right, to first commit, so it's your first time contributing, is the workflow, well, we don't have the time to review all of this in one go, so please just pull request half the algorithm, just the algorithm level tests. Like, what is...
I mean, what would we do if that was core? Like, what is different about this discussion because it's not core?
I think people are more willing to put time into core pull requests because core is okay. The other point is that core is important for everyone in this room, and then everything else outside of core, right? It's like, you know, there's the three repositories people care about. Oh, sorry, sharing their radio spectrum, right? There's the four repositories people care about, and then there's everything else.
I think like the other repos tend to have a smaller group of very active developers on it. But I think if we're going to continue to break up the project into multiple repos, I think I don't know how we do this, but I think we need to set expectations of like you're maintaining all of them. So actually, here's an interesting point. Going back to our standardizing stuff, at the moment, different people have commit access to different sponsored packages. Should we just have one set of people with commit access, and now you get commit access to all the sponsored packages? And you know, congratulations, you're on the hook for a lot of them now. Like,
yeah, I think that's a good point about the organization of teams and whether or not we need 45 teams.
I mean, we definitely don't.
I think that's a good idea, and I think actually part of the reason I don't review stuff is because I see myself at the moment as a SunPy core maintainer and not a SunKit image maintainer, and therefore I don't think it's currently my place to review SunKit image. But
should we talk about? So if you go to GitHub.org, there's a Teams.
I'm sharing my screen. I can.
No, that is.
Just can we just clarify? We keep saying like all our other affiliated packages, but in my head it's SunKit instrument, SunKit image, radio spectra,
IFLCT, instruments, ND Cube.
So yeah, core NDQ.
SunExpect.
SunExpect isn't sponsored.
No, that is not the right list, as previously discussed earlier this week. We desperately need to update that page.
Having said that about SunExpect, it is not.
I should think by definition this is the right list.
I mean, well, no, because it's actually what's more important for this discussion is what are the repos under the org that we're all on the hook for maintaining. Like whether they're sponsored, pre-sponsored, early development.
I'm just going to go down the list on GitHub.
You can delete X-ray vision. Just delete it. It's fine.
No, don't you want it under your?
I'll transfer it back to you.
Yeah, transfer it. So
Done. One less.
we have a couple of repositories which are just uploaded by bots, so we don't have to
just operate it.
Just operate by bots. They source information that don't have to.
The machines have taken
them. I'm not there. It doesn't mean you can pick on me, okay?
So we've got the website repository, we have SunPy, we have the theme, we have PyFLCT, we have SunRaster, SunKit image, a blog, DRMS, SunKit PyVista, NDQ, the set repo, but that's just a thing that just gets updated whenever. SunPy still, which I think we've agreed to PR into SunPy eventually, so that's.
But for the moment, it's on the list.
SunExpect, which will be an affiliate package, sponsored, I think.
Yeah, I think when it's a little bit further developed, it's definitely.
Whilst we're going there, why is SunExpect in the SunPy org if it's not being reviewed and affiliated?
I think it hasn't been even released yet.
Historical reasons, it's existed for a long time. There is also I think there is value in
developing a package that is.
Not all sponsored packages have to start off life in someone else's org.
I disagree. I think just because like
If it makes you feel happy, it just set off in mind.
no, but I think
Done.
I think packages that just happen to be started by the inner circle of SunPy maintainers shouldn't live under the SunPy org without a package review.
I strongly disagree because there is a category of things that are like on our roadmap, like take some spectral data, for instance, where maybe one day want it to end up in core, or we otherwise like NDQ, where we otherwise have identified a need that SunPy needs to provide. The SunPy developers, as the collective, are going to do that development work. It is a SunPy project from like conception through to release, and sure, at some point it should end up on the website and being advertised to people, but it's still a SunPy project from the beginning.
And to clarify, my statement was that it's not a sponsored package. Not like I was thinking.
Sorry, I'm saying
It's
will be applied to be a sponsored package.
Exactly. It's just a matter of time and development to get it there. It's clearly
It's
on
not sponsored
rails.
right now. Sorry, I'm not saying it's sponsored.
Well, we could say it's affiliated.
Yeah.
I mean, it's like it's trying to follow all the rules and standards of
Hasn't gone
SunPy.
through
It's not
review.
affiliated, and it's not. I mean, and then by definition, it is sponsored because it's under the org. So we're all on the hook for maintaining it, even though in practice that's not what's happening.
Yeah.
Like
Yeah.
you guys are the ones working on it, but like
Well, no,
everyone.
I don't have right access to it, so it's not our jurisdiction.
But like, I think there's value in like, with SunXpex, for example, there were several of us working on it at once. And if it's like just under Danny's repo, if you're trying to get community gain, you're like, oh, push it to Danny's repo, it's Danny's code. But I know I don't think like that, but other people can see it like that. Where if you
Yeah,
see
and it
this
was to
project
start
from-
with.
Yeah, and it was. But I think if you're trying to grow a community around something that everyone's going to develop, it should be on some kind of.
But it
Over.
wasn't
like a vote amongst like the voting members.
I'm unconvinced by that.
But what stops
Like,
you from? I mean, I'm being like playing devil's advocate, I guess. But like, what stops you from just like adding in like a bunch of repositories because you think it's a good idea to keep these things under the SunPy repo? And then now we have 20 more repos. I'm not,
from a pure governance perspective, literally nothing. I'm allowed to do it. I'm the lead developer. Like from our like. I'm not saying it's a good idea, but like if we're going to get into legalese here, literally nothing.
yeah, that's my point. Like-
But yeah, okay.
Also, to throw myself under the bus, like the SunKit DEM stuff, I just created a repo under the SunPy org at PyAstro like 3 years ago, and it sat there to rot, right? And now it's just
Can we
taking
delete
up
that right
space.
now? Well, no, you've just said, okay, there's.
X-ray vision's gone because it's now in.
I mean,
It's now in my name.
Can you archive the survey repo and delete the condescent?
I mean, we don't have to do this right now, but yes.
Yeah.
Okay. Like, and I was allowed to do that without really like consulting anyone. I think I told Stuart and he was like mildly annoyed that I'd done that, right? Which, and to be fair, yeah, like, I don't know. I just think that there should be some formalization around what gets added.
Well, yeah, but I agree with.
Yeah, but I feel like that could be, we discussed it at a community meeting.
Yeah.
Or there was an issue opened on the project.
I felt, yeah, it's the kind of thing that I think on a Wednesday call, we want to add a repository under the org so people can collaborate on a prototype library. Is probably enough. That's my view.
Yes.
Is there-
Yeah.
sorry, go ahead.
I was just gonna make it like, because it can seem again this kind of club situation. Like if you're in the club, you can make a SunPy repo, but having it on the website, being like, oh, if you want an incubator SunPy thing, this is how you go about it. You come to the Wednesday meeting or you open an issue. I think is just make it kind of transparent, I guess.
Yeah, I mean, I suppose if it's not like labeled affiliated or sponsored, it's like kind of by default, it's like incubator, right?
I think
Otherwise, you want to
something where-
explicitly say everything has to have a label, and we've just created a third label.
Yeah, that was, yeah.
You know,
Yeah.
You
It'd
were
also be
talking
like-
before about how you wanted to have write access be uniform across the sponsored packages. I think you got to be wary if you're saying someone wants to come in here and say, I want this to be a SunPy affiliated package. And as the penalty of that is, no, do they then write access to SunPy core? Commit access to SunPy core? If you want that to be an affiliated
They
package
wouldn't have
and it's
to.
theirs.
but it's affiliated, not sponsored.
Oh, sorry, sponsored.
It's under the org.
Right. Okay.
the only distinction between sponsored and not sponsored is we all maintain it. Like the nebulous entity, the SunPy developers maintain it. Like,
so then is the suggestion then, so take SunX specs, SunKit specs. In that case, we want to, for community, for branding, for getting momentum, so that it isn't just Laura, Shane, and myself, like Ian and Chris, and hopefully other people. If we want to sort of create the sense of a community effort, it might not specifically be the entire SunPy community, but a subgroup of that. So we create a new GitHub, like community entirely separate from SunPy, which is like SunX specs, or or do they, well, this is a subset of like the SunPy community. It's clearly identified as maybe the package, the code itself is not worthy to be a sponsored package yet, but like the concept and the functionality that it is trying to maintain is certainly solid physics community value. What's the step between it being on my branch and it being sponsored by default? Because
can I get a clarification as well? Is that
SunPy/SunX.
Are sponsored packages supposed to be like finished deals? Is there a problem with having something that's like heavily under development being a sponsored package?
it would be listed on the affiliated package page as provisional once it had gone through review.
Because I suppose, like, even at the level of SunX specs, it is still the Wild West in the sense of like.
I think we're getting slightly crossed on the sponsored thing here. It's kind of got two subtly different meanings, right? An affiliated package that is listed on the website as sponsored is like done, reviewed, but it also sponsored packages can easily be referring to anything as SunPy, right? And a very early prototype package isn't getting it into the affiliated packages website page, basically until it's to get on the affiliated packages website, you at minimum need a release. People have to be able to download the thing. But there is this like early sponsored packages thing in that the SunPy developers are building it, and therefore it's under the org.
But my understanding was that sponsored packages were that they were somewhat mature because you could just sort of look at how many repos are under the SunPy project, whereas to me, sponsored is a declaration of guarantee to the community that this works to a certain degree, and that SunPy is responsible.
Yeah, but I think I agree with Stuart that to me means it's on the website and listed as sponsors.
And not provisional.
Whereas,
well, then we should be clear with our language, and like just because it's SunPy/SunX specs doesn't mean it's sponsored.
Yes, there is
maybe you could like call the repository SunX specs -incubator or something like that. Put something in the repository name.
I think we don't need like the actual list of sponsored packages on the affiliated package page is like the way we tell users, here you go, these are the projects that the SunPy project is maintaining that are released and up for use. Here you go, here's the list. We don't have to on the GitHub repo. Like we have loads of GitHub repos that are in various states of taken over by the machines through to SunPy core, right? I don't think just because it's under the GitHub org doesn't mean that it's finished and done. It's like people.
But I say it doesn't mean it's sponsored either. Sponsored is a specific label.
Yes,
okay, define a certain degree of competence.
It does mean that it's our full responsibility, main responsibility. It does mean that like it's SunPy's responsibility. We are.
It means that we're
it as a community.
Yeah, but it also is like we are not promising users anything. We're saying, oh, this is a package that SunPy has, but we're not promising anything to users whatsoever. Whereas when you say it's sponsored, we are declaring that this is usable to a certain degree of reliability.
Yeah.
So the fact that SunX specs is there and not sponsored means that yes, it's SunPy repo, but we don't promise users anything.
Yeah. But like that's great for us to know. But how do you know that as a user? Like, should we have a tag on the repos to be like like, oh, like,
Package description?
Yeah,
maybe?
Who's?
I mean, there's
like-
also that. I don't know who's looking at our repository list, but maybe something to clarify at the top of the,
Like in the README or something.
yeah, so the project, well, I think it just now has a readme, which we can add.
yeah, then maybe you could
add,
link.
and we can then, yeah, we can link it and then,
You
Put it
hit
on
the screen.
Actual,
it's not touch.
like Sun expects as README, because, I don't know, I wouldn't mind go trolling through all your packages and your GitHub repos, and I wouldn't
No.
necessarily go back and look at the
Yeah,
project site.
But would you, just because it's under the SunPy org, assume that it's like done?
I don't know if I would assume it's done, but I would assume that there's a certain quality to it, I think.
yeah. And also you run into the issue that like you see SunPy packages and then you look at Sun specs, you're like, oh, well, I don't actually trust any of these SunPy packages. They're all.
Yeah, that's a.
Yeah, and then it
problem
goes the other
with-
way, and then you're like, SunPy Institute, oh, that's still being developed. I won't use that. I don't trust it.
Well, I mean, I guess in that case, we can make sure these packages have in the description what they're for and their status.
Put in something like under development or something in
Yeah.
just in the about section.
Yeah, that would be sufficient.
Yeah. So what would you, Margaret, like, from your experience, what would be helpful? Would it just be in the README or like, or on the GitHub page of each package itself have a little description of like a warning or a
Yeah, I
status?
think if you add it to the description, it shows up under here. So
Okay, yeah.
I think that's a good idea, the
Yeah.
description, or you could put, I mean, more on the README if you wanted.
probably
Because then it could point back to the website for the
Yeah,
whole list, and then you're advertising your other.
that's true,
packages
yeah.
too.
To learn more about different things, yeah. Yeah,
But I do agree with the concept that there is a place for repositories under the org that shouldn't be, I don't think some of it should be developed under Danny's.
It's gone beyond. It started off as that, and then there are more people who have write access and who are like, it's not mine anymore.
Yeah, I
It's,
think,
you know,
gaps that we've identified and we've decided are part of our roadmap, which is what we were chatting about a couple of days ago.
it seems like we're moving to consensus.
Yeah.
Otherwise, there's no need for a sponsored package label. It's just, if it's SunPy / whatever, then it's sponsored. So we don't need any of this language, you know, unless there's a
To be
category.
clear, when I have been using, this is kind of on me, but to be clear, when I've been using like sponsored packages for like this session this morning, as in we're going to have shared infrastructure over all the sponsored packages, I meant any package the SunPy developers are developing. So I'm including Sun specs and everything else
We need a new word.
under there.
We need a new
Right.
phrase then.
SunPy maintained packages, whatever you want to call it, things that
Yeah.
if it's a
SunPy
Python
package.
package, if it's a Python package and it's under the org, with the potential exception of A-blog, I'm throwing it in to like this discussion.
I would argue they are SunPy packages.
Sure.
I think, well,
That's sponsored, affiliated, you know, not described.
No, but I'm specifically excluding affiliated packages that aren't maintained by SunPy.
Oh, right, sorry. Yeah, beg your pardon. Yeah, there's sponsored and other and not. Sorry, you're right.
So I think we came to a decision there.
Okay.
Okay, so after Sun specs, there's the .github.
We decided on some nouns. Excellent use of 20 minutes. Let's go.
So we have the .github, which is just a place to store config that is global for all repositories. So the issue templates. If you open an issue on SunPy and now any other repository under the SunPy org, there's a fixed list of templates you can choose from to pick from. MPO animators, which is the old visualization code from NDQ. Was it NDQ or SunPy?
It was in core.
Is it called?
Yeah.
That definitely falls under this list. Like, I don't think we're ever listing MPL animators as a sponsored package on our website because it's not solar physics specific. But it is a package
I
that
think that's a really good example of something that shouldn't live in a SunPy repository, actually. Just
can't disagree. It's our code, it's our fault.
I would
Like, we
say-
moved it into its own package, not because it shouldn't live under the SunPy org. We moved it into its own package because NDQ needed to use it and not depend on SunPy core.
Should live in the map folder proposal.
Look, I've spoken to Caswell about this and he doesn't want it, so it's not happening.
But it's not solar physics. Anyway,
Well, no, but that means A block is moved out, and A block is not being moved out.
Not as NDQ. So NDQ shouldn't be. We should kick NDQ back.
Yeah, I mean, we develop things that aren't necessarily solar specific, but they are useful to solar physics. So we maintain them. We built a
A
thing
block,
because we
solar
need it.
physicists to tell other solar physicists to do solar physics.
Exactly. Yeah.
yeah, fair enough.
We've got the figure test repo, which is another bot thing. We've got SunKit dem, which we're deleting right now.
You can move it to me.
Okay, we're deleting right now.
And delete. Do you have a SunKit dem for?
The old sample
Yeah,
data
so
repository.
rename it or delete it, please, because I can't move it to you otherwise.
Wait. Okay. Oh, yeah. All right. We'll do this.
I didn't even know price.
You have the copy to the copy. Otherwise it's-
Okay, look, we're running out of time. We haven't got onto the fun part of this discussion yet. We
Okay,
need to
shall we
focus.
just-
Why are we going down this
I
list?
don't know. Okay, I forget. We have a lot of repositories with some codes. It's fine, right? Okay. What do we want to talk about next? We will talk about the interesting things. It's time, Stuart, or is there something else we want to?
I don't know. Does other people have other thoughts on this more from an infrastructure point of view? I'm happy to say that if we're going to make a new repo under the SunPy org, we're going to make an issue on SunPy-project first. Like,
Yeah.
I think that's, I don't know where we document that.
I think we agreed that we remove half the teams and everyone just has, if you have right access to the SunPy core, you have right access to.
Is the inverse true? As I think it was Alex said before. I think if you have right access to core, you have right access to everything. I'm on board with. I am not sure that the inverse needs to be true.
Yeah.
You have right access to something, you have right access to core. Okay, right.
Yeah, if someone came to us and they wanted to, eventually to prototype a package under the org, doesn't mean they should get SunPy right access to everything else.
Like necessarily straight away.
Yeah, but they can ask for it, right? Yeah, I think that's fair.
Okay. Cool.
Presumably, once we do the governance research, it'll be more of a process of asking for commit rights to the core, and therefore the whole.
Potentially, not necessarily. That will probably still sit with the executive, whatever that looks like.
But there'll be a documented something. Anyway, yeah.
We could have that now. We don't have to do the governance restructure, but the way it's currently, as far as the governance documents are concerned, I think that's always just going to be like,
But I do think we need to make it, I know it's clear in the documentation, but I don't know how we spread the word a bit better of what the difference is between all the packages and how you go about doing these things. Right.
I mean, I think our sponsored / affiliated package page kind of does that already.
But I think it needs to be like pointed to more in the docs. For example, well, you're nodding to that, and I guess should be as well. If for people that aren't maybe aware of those things, did you know about affiliated packages or sponsored packages? No.
I mean, there's on the affiliated package page, it says what they are, but it doesn't say like anything about a process. Yeah.
I also don't think we do a particularly good job of the affiliated package page is hidden in like a couple of clicks under.
That's a lot of text.
Yeah.
So I think
you're talking about redoing the front page anyway with those categories in the documentation. You could always put down like SunPy is also associated with, some kind of tertiary packages that do specific tasks that aren't within kind of SunPy's remit. These are here.
Yeah, or like if you want to become there should be a button close to the top of like, how do you become an affiliated package? Or do you know what I mean? Or it's discoverable.
You gotta join the super cool club.
Yeah.
we have cookies. Okay. How long have we got? When's the session supposed to finish?
15 minutes.
15 minutes.
Sweet. Right.
Very quick. Everything else we're going to discuss is.
So we've gone through review process. We're going to turn on one approval for everything. We've gone through commit rights, package process. So I think that's all of the kind of high level management stuff. Anybody got anything else they want to talk about before we get into like tech? Sweet. Pre-commit and code style is the big thing that varies across our packages at the moment.
I was going to say before that, including typing under. Yes. Okay.
So this is both things that are enforced by pre-commit and general style of how we do development, like what tools we use. So things I'm including in here for discussion are Black. Lots of our sponsored packages, maintained packages use Black as code formatting. Part of this effort means that if they're all going to be the same, either they all need to use it or none of them need to use it, and we need to decide which one. The bill has opinions. We need to think about a policy for using type hints. I am of the opinion that the ecosystem, specifically Afropy, isn't there yet, but when it is, we should do it. So we need to, like, are we going to turn on MyPy on core now, like, or on all the repos? Like, if we're not checking type hints, what's the point in having them? So do you have an actual? Should we write some bullet points and just go through these one by one? What do we have that we need to agree on here?
Well, it's just code style and it's just Black and types, isn't it? I don't think what else. We ISO everything. I kind of would like to use doc formatter, but it's a bit flaky on certain. I use it on a lot of things only because I want to.
Can you say what doc
So
is?
So all it does is keep the documentation strings in functions and classes to be about 80 characters long. Just reformats the text.
Oh, that's not what I thought it was. Okay.
But the problem with this is that if it is above 80 characters, for example, if you have a URL in the first line, it will break the URL incorrectly. It will break, which is why I don't like it. Which is they are fixing that. I don't know when they're going to actually fix that, but I use it just to maintain the documents.
Okay. I think the most controversial and to some extent important thing to decide here is what are people's opinions on applying Black to the core package?
Well, I would rather start on typing.
So we can't even agree on where we're going to start.
Fine, type hinting. Let's do type hinting. Go on then.
We should type hint the packages. I mean, the question is how do we apply MyPy onto core? Whether or not we add it, but have it exclude everything, and then we integrate whether or not we apply incremental. What is Remain words? Like, incrementally add files and checks as we implement. We can't sit there because the choice about doing it when Astropy eventually have support is that we do what we had to do from 2 to 3, which is a horrible set of large pull requests to add typing to it, because then we are adding MyPy wholesale when Astropy have it.
Not necessarily, but okay. So I think
a
decision here is: do we want to work towards having more typing, like
yes,
extensive type hinting on all the maintained?
I don't know if people are familiar with type hinting and Python.
Not very.
I mean,
So go on.
I was just gonna say, I think, like the whole thing with MyPy and type hinting is that it doesn't have to be all or nothing. You can start like type hinting a lot of your internal hidden private APIs, and then leave the external stuff so users don't see it. So you get the benefit of it inside, but it isn't exposed to, our end users essentially.
But at the moment, we're nothing. Kind of like by conscious choice, right? Like type hinting has a readability cost in the code base. It has a maintenance cost on the code base. It is a choice we need to make. I've resisted small type hints being added to core because we haven't made the choice, and that's what this discussion is, right? Are the trade-offs for type hinting worth it? You say yes.
Can you say like
my core argument is that every other package that we depend on, eventually as Astropy, are adding type hinting.
I don't think it's a foregone conclusion that Astropy is going to add type hinting. They're thinking about it.
NumPy, X-Ray, Astropy are thinking about it because of this units and whatever else. And we already have type hinting. It's called quantities.
It's not that is one of the major problems. We use function annotations, but they are not type hints, and Astropy does not support making them type hints at this point.
Can we just take a step back and can someone just say what that
So when you do u dot quantity input and you do, if you find it, but when you do u quantity input and put a
quick example.
I think we're looking for it. That's a function annotation, right? You're annotating that argument to the function with, in that case, a unit.
Yeah.
Those function annotations and similar bits of language were added to facilitate like type hinting, as in you could say that argument is a float or that argument is an integer, and it's not enforced at runtime, but it's metadata for checks or edit linters or whatever.
Okay.
Right.
I
So
put a link to an example. I don't know if it's the best example, but I wasn't going to show my screen, so they want to join.
so that's like
Okay.
what we're saying is eventually every function parameter will have a type.
And so what this,
in
So
the
it's
code.
like type, so you're telling it type hinting, you're telling it what the type of the thing is.
Yeah.
Okay,
and so there are ways to check that this is enforced. MyPy is a static type checker that you run. Analyze the code, it prints out a whole bunch of errors or warnings. You can either ignore them, fix them, or tell it which files specifically to check for types. Because obviously, adding all of this to a code base that is very large, doing it in one go is possible, but unwieldy. So you have to do it. You have to do this.
Click on my screen, Stuart, and I will just. Okay, so if you have a simple add function, so if I wanted to type this, I would do, let's say this just accepts integers, I would do :int.
Yeah, I think this is the bit we're going to.
:int, and then so that tells me what the valid types of the input is, and then to type in the output, you do this arrow and then the output type.
Okay.
And then so these types are not, so you can run this code and it doesn't check the type at all, but there's a library called MyPy, which is a static type checker. So you would run MyPy on this file and it would check that your code adheres to what you've typed in. So it basically checks for mistakes in the input and output types that you promised.
Yeah, so if you had a
And
library,
tests that you run on it?
Yeah,
Okay.
so you would add it as a pre-commit step. As to check
yeah, so if you had like under this, you called adds, but you put say strings in, MyPy would see that and go, you are passing strings into this function. It only takes integers, and it will error. I think it will actually error on that.
Okay.
So it's comments for computers.
Yes.
Right.
Hints, when we say.
It's hints, but
Was then comments.
No,
like,
no, yeah.
No, you're right.
What-
of course.
the part of the good thing about it is ensuring that you are putting the right types and getting out the right types. But what that means that if you're a developer, when you start, so VS Code and they type check in real time. So if you open this function, it will then go, okay, this is the type, you should pass it. And if it's wrong, it will highlight. So in my VS Code, it will highlight that this is actually the wrong type.
So
And for developing code, developing libraries, which is what we are essentially, this is not necessarily a user-facing change, but a development change for ensuring that as we make changes to our code base, we are not doing this incorrectly.
So we do already, to a greater or lesser extent, have this information in our code base. It lives in the dot strings, right? You can make Sphinx pass the types out of the function signature instead of putting them in the dot string. So you don't have to duplicate the
Yeah,
information.
so there is also things, there is a Sphinx plugin, which is in a,
It works most.
it works most of the time. It needs some love. If it's going to be adopted wider, it needs to actually make it. But you can type it, and instead of doing the types in doc strings, Sphinx will just see that and straight to the doc when you render them. You don't have
So
to.
my concern with type hints in a package like ours, and this applies to SunPy as well, is a lot of our API is very flexible. Using type hints in like building a HTTP API, fantastic, really useful. Writing type hints for the valid input to Skype award is a absolute nightmare because it takes everything and it's so flexible depending on the other keyword arguments. You basically can't accurately type in the constructor of Skype award.
So I think
Yeah,
that
but
is
you can type in the output, which is useful.
So I'm just like that.
Yeah,
that's
no,
my main
there-
concern is
no,
like
there is-
how far down this rabbit hole do we go? Are we going to be like, no, we must type it,
No,
even if it's
can't-
like really
We
ugly.
can't enforce typing in core at least, because if you depend on SunPy, which doesn't have full type hinting support.
But let's assume that you could type in a lot.
Okay,
like
well then
quantity.
they would have type hinted
I don't think they're ever typing into the constructor recycle.
Well, then we,
They already have it in the documentation string, presumably.
Yeah, there's a difference between describing it in a few sentences and all the different options
yeah, but in
versus
that case, you would just return
union
any-
this, that, like, you know, type in that's as long as your arm and is completely unreadable.
Well, one of the points you can specify custom types at the top of the firewall somewhere which will have this application.
Yeah, so specifically, I tried to do this for 8.14. There's a closed PR on SunPy where I tried to type in 8.14. I actually wanted to use it for like compatibility checks, like does your implementation of 8.14 comply to the API by documenting the types of the type. It was not something I would want anybody to have to read. Like, I got close to it being right, and it made the readability of that file 100 times worse,
Right.
because there was just so much in it now.
Well,
But the flip side of that is being forced to write the type-ins makes you realize that you've made this crazy function that's really hard to understand and encourages you to simplify the API.
Yeah, I mean, the 8.14 API was designed very deliberately, and it is what it is for good reason.
I mean, in that case, if the typing is 15 lines of types because you have the craziest function in the world, you just type any, just accept that. Look, there is a get out clause for typing, and there is an any type, which is like, we'll take in anything and we'll output anything, and you're on your own. And so there might be a case where functions do not return, might return 1,500 different types. We will have no control of that, for example, Stanford, and we will have to accept that we have any, and we have to document that the return type of this function is going to be so many things that we cannot possibly enumerate. And that's potentially a compromise we're going to have to make on some cases.
Okay, so in terms of making a concrete decision right now, I think, does anybody want to argue against starting to add type hints to core?
I just don't know what problem this is solving, like practically. Like we're talking about this in a vacuum, and you're saying like, okay, other packages are doing it, we should be doing it. But I've not heard like what
you find
what
bugs
problem.
in your code a lot quicker. Like the whole point is that like when you run it, it'll tell you about a mistake that you wouldn't know until you hit this really rare edge case in the future, where if it's type checked, you'll find that straight away, because it'll be like, oh, this function can call this thing with a string when it should be an int. Fix it now, rather than waiting 2 years when someone finally finds that edge case and you've now forgotten what you've written and why. Would be the benefit I would see.
The other advantage I've come, or actually I didn't actually know the code type hinting, I've come across this in Anycube. Stuart sort of added this in a few places, maybe in the SCP. It actually, I found once I very quickly copped onto what it was saying, it made the code actually more readable.
The type of thing makes the code more readable.
For a developer, yeah, because like if you go into your doc strings and you read what the variable is, and then you sort of, so that information is scattered through that anyway, but then when you look at, okay, what are the variables go into the function call or the method call, like it tells you all that in the one place. You don't have to say, okay, it's like A, what's that? And you sort of go through, not only you see the description, but then you see the type. So, you know, I found once I very, very quickly figured out what it was telling me, it helped me read the code more easily.
And that the type hint in function signature was more useful than just reading the downstream.
It meant that, not that it was more useful, that I got the same information quicker with lower effort. So I could.
I guess that's,
Yeah,
that's what I
type is a problem to fix for developers. It's not a user, primarily a user. Users will generally not care about types. They're coding like Python. I don't think they will ever, but the developers who are writing library code.
Well, I'm not sure I agree with that. Because
Well, just like types.
well, no, but when it like notebook autocompletes or Python, and like your REPL shows you the function signature, like output of help, it shows you the function signature, includes the types, right? And that is a double-edged sword, because it shows you the types, cool, now you know what types to type in, but it's made the function signature line 20 times longer, which means sometimes you don't actually see what the arguments to the function are anymore because it's rolled off the end of the script.
I thought that's a Python.
I think
No, I mean, there's just more stuff to pass, like there's just more text there. That's my Python problem.
Yeah, my view on type hints is that it is a developer focused tool to edit the libraries right and record. We are passing in the correct arguments and outputting the correct arguments.
Are we making it, if we start requiring it in our packages, are we making it harder for people to contribute to core?
I think so.
Certainly.
I think absolutely. If you have like a user to a developer or trying to get to
But
contribute.
this is a problem that NumPy don't seem to have, SciPy don't seem to have, XRA don't seem to have, Pandas don't seem to have. We are talking about, for some reason, developers, users who contribute code, apparently are so useless, they could not contribute to any other Python.
Those packages have decided, no, those packages have decided that the trade-off is worth it for them. What I'm asking is the trade-off worth it for us?
I think so, yes.
I know you think so.
Oh, I thought me arguing.
Hang on, Laura, would you elaborate on what because I know you kind of disagree with that.
No, I understand, like, I understand the value in it, right? But I'm just saying from somebody, even like from including myself, if I went to a package and I saw type-ins, and now I know what they are, I'm like, oh, I probably couldn't contribute to this. I don't have the development skills to do this. But like, maybe it's just, again, like, people do go down to GitHub repos and read the doc strings. And I'm not against it, I'm just saying that could be an issue of people being.
I agree with you, and I think the way we transition to type-ins is going to be quite good. If we are going to do the way we transition core specifically, because it's so complicated, to type-ins, it's going to have to be managed. We're not going to have to. We're not going to have to enforce type-hitting for, I think, a time. We're going to have to start adding them to core in bits, and say maybe in 3 years, 4 years, we then enforce pull requests to have type-hitting when the core package is in a state.
Yeah.
If someone were to PR a pull request now, if we had this change, I would not enforce type-hitting for a long time because the rest of the core has no type-hitting. So why we would have to migrate very slowly, like we did with 2 to 3.
But you're still ending up in a situation where eventually we're going to require people to understand it. It's another thing.
Yeah, and I think in 3 to 4 years, when we probably will end up on that timescale, is when I think we would enforce it on core. I think the sponsored packages, I think the other packages we have are substantially simpler where this would not be a problem.
Well, no,
well, maybe
again, you're still.
I think we already require people to understand the concept of typing because we require them to write doc strings. It's just a different syntax. But doing that would be my argument.
This is why I never went out, because I can't formulate.
But I mean, I'm not.
You're not more passionate though.
I don't know.
Well, it doesn't count for anything. No one understands it.
I'm not tired yet.
Is it becoming more popular? Is it a thing that we're going to see more and more in Python?
Yeah.
Okay, well then that's okay.
But you cannot contribute to NumPy, SciPy, XRA, Pandas without having to type in your code.
Okay.
I would say PlasmaPy,
Just,
there's also large portions of PlasmaPy that are type-hinted, and they have quite an active, I'm now arguing against myself. They have quite an active developer.
So
Connor online had.
Yes, so I was just going to say, because I feel like getting stuck in the reads a little bit here, is that you're not planning to enforce it now, and enforcing it is the discussion for 4 years from now. Like the trade-offs of enforcing, like the only negative about getting people writing their own pull requests is if it is enforced.
Yeah.
And you're not talking about enforcing it today.
Not necessarily if somebody wants to modify some code that's already been type-hinted. They still have to understand. Like if we start adding type-hints to the library, people have to read type-hints.
Should we not use generators?
What?
In core? Because, lots of people don't know what a generator is and don't understand it.
I'm not,
decorator.
to be clear, I'm not particularly anti this. I'm just making sure that I want to make these decisions.
I think this decision properly. I think you could, for example, add type-int into some image or instrument very easily and enforce that. There's less code. It's much simpler. That could be. Core is a separate problem.
I worry that we can't really start adding type-ins to a lot of stuff at the moment because you can't correctly type in quantity. And MyPy is just.
You can start doing it incrementally.
But you can't run MyPy because as soon as you know, but like if you
have to ignore
but then you're adding a bunch of type into a file.
It's not on a per file basis. Yeah. It does it on a per function basis. So if you if you have a file with a type-hinted function and another non-type-hinted function, you can configure MyPy just to run on the type.
But it will detect.
But then you can, I think you then.
But
you can filter out.
Okay, all right. We need to think. We don't need to do this now. I'm concerned that this is a bad idea until you can do quantity type as a generic. But that's a technical argument. We don't have to have it now.
Yeah,
I don't know
it
what
does
to say
seem.
about
It does seem that it would be difficult until AstroPy do it, but that doesn't mean that you shouldn't start where you can do it. Like there are lots of SunPy functions that don't touch quantities or any AstroPy objects, that they just use Python objects, and in those cases, you might as well start doing it.
Okay. I mean, does anybody else want to say?
The AstroPy docs seem to say you can do it with quantities. Whether that works with MyPy, though, I don't know. They just say you do quantity and then u dot whatever.
So that's the.
I don't know if that works with
function.
the automatic stuff though. But...
Yeah. I think that's subtly different from type hinting. That's using function annotations for a different thing.
Oh yeah, I think you're right. Sorry.
Cool. Okay, just as long as we're all understanding the same thing. Okay, we're merrily driving through the coffee break at this point. So, does anybody are we in agreement that we will a good idea to write an SEP to start introducing type hints to the project?
Why an SCP?
Because major changes like that get SEPs, like units got an SEP. And we need a forum for wider discussion. Like we need to get big changes like this discussions should be had by async media.
Yeah, I think sure.
Yeah, okay. You want to do that, Swackins?
Sure.
Cool.
Garfield?
Instead of discussing that, why don't we just open an SE? Why don't we just open an SCP for that?
Yeah, do that.
Yeah.
Well, that was fun. Coffee time. You didn't actually make a decision on the thing I wanted to make a decision on, but yeah, never mind.
What's the point of having a 45-minute discussion if we're going to open a set?
Yeah, well, I mean, I guess the point was that
it makes the set review significantly easier.
Yeah, I don't want a set to then be immediately rejected.
Okay, yeah, fair enough.
Yeah.
We'll be back at 10 past.
No, my set will be one line. AstroPy are going to do it.
They're not. That decision has not been made.
And I feel
Sure.
yeah, yeah.
They've been discussing for 3 years. That hasn't.
Yes, it's been fine.
your pixels here on some sort of square.
On the right, sorry, annoying.
Is it from the monitor?
The only
Oh,
adapter.
So very triggering.
Oh, yeah, it's
Not
fine.
to issues
No
with
worries, no worries.
Especially when you rotate them. So Shane, before you start, I noticed that Ed is on, which is a heroic endeavor since he is in DC, I believe at this time. Ed, do you want to just introduce yourself briefly and talk about like your solar orbiter connection?
Yes, it's actually. Oh, the sun is actually up here. The sun has come up. I'm up early in DC. I don't look very good. That's not how my camera is on. I'm Ed Bain. I'm a software developer. I'm Ed Bain. I'm a software developer. I'm working for Terry Kuchera at NASA at the Goddard Space Flight Center supporting SPICE on the solar orbiter. So this session seemed relevant, so that's why I tuned in. I'm just going to be here for this.
Awesome. Thanks for coming in.
Sure.
All right. Let me see here. Share this. My laptop has decided to be incredibly slow today. Oh. Can you only share the screen that you're like? Okay.
I think that's up to Mac OS, so no comment.
Are you on Firefox?
No, it's grand. I'll just do this. This is fine.
You have to, what's it?
Okay, right. Where is? I have way too many things open here. Okay, right. Okay, so you can't see that. If we do this. Okay. Can you see that? Is that full screen? I have no idea. Okay, grand. So yeah, I think the title of this section was supporting solar orbiter data. And yeah, I was just throwing these slides together really quickly. Like I said, just to kind of focus everyone's thoughts. I'm sure everyone is aware, but I thought it might be just good to really quickly go over the solar orbiter mission. So a solar orbiter is a unique mission in a number of aspects. I guess the key one is that it's more of an encounter-based solar physics mission. So what I mean by that is, if you think of SOHO, stereo, SDO, they kind of sit and stare at the sun and give synoptic observations. They're always looking. All the instruments are more or less always on. But with solar orbiter, basically the in situ instruments are always on, but the remote sensing instruments are only on in 3 windows, 3 10 to 15 day windows per orbit. One at the kind of the most northern point of the orbit, one at perihelion, and one at the southern point of the orbit. So in terms of analyzing the data, it's not that you have it constantly. You're kind of looking for specific cases where X instrument was on and looking at a certain portion of the sun. I guess as well, not all of the instruments are full disk. So the high res telescope in the EUV has a very, very small field of view, and so that would actually be pointing at a certain area of the sun. It's got a unique orbit. We're going to go in quite close inside the orbit of Mercury, and as well, the final orbit will be highly inclined to the ecliptic plane, so we'll actually get remote sensing observations of the poles, and obviously in situ as well. And like one of the key drivers of the mission is really to try and combine these in situ and remote sensing observations, because up until Solar Orbiter, we had this problem where we'd see something on the sun, and then sometime later, days, hours, we might detect something in situ, and it was very hard to disentangle what we've seen in the in situ measurements to what actually happened on the sun, and was there propagation effects? Did things change as they moved, etc. So the key thing is here, because we're going to be so much closer, is to really try and tie down. We saw this in an image of the sun in some wavelength, and then we detected this physical thing in situ. So it's trying to link these two things together. And I guess another thing just to bear in mind about the mission is that, again, we don't really have real-time commanding of the spacecraft. So the instrument teams load up 2 weeks of observation plans at a time. They're then sent up to the spacecraft, and the spacecraft just executes them. So if something new happens, there's not really an opportunity to change what the observing plan is going to be. There's one very, very small exception in that if you're following an active region, you can do this thing called very short-term planning, where each day you can tell it to point to a slightly different place. But that's really it. And then the official Solar Orbiter Archive is the SOAR. We discussed this already. It will be where all of the data eventually goes, but at the moment it's still being populated. So it doesn't have, for example, STIX data yet. It only just recently got phi data. And I thought it might be useful to show. Yeah, so this is just a movie of the latter half of this year, basically showing the orbit of a number of spacecraft and then the various remote sensing checkout windows. So you see this blue bar, this red bar, and this orange bar. I don't know if you can see my mouse, but they're essentially the remote sensing checkout windows when all of the instruments on Solar Orbiter will be active, and then outside of these windows, the remote sensing instruments will be off, apart from STIX. STIX is a special case because we've got such low TM rates, we're always on. And I guess this just shows the complexity of trying to analyze data from Solar Orbiter /probe /stereo. They're all going to be in different places in the inner heliosphere with different viewpoints. So coordinate transforms and all these sort of things are going to be crucial to try and pull all this data together.
Different spacecraft velocities as well, if that's important, whatever you're observing.
Yeah, very true. Yeah, so a really complicated analysis problem, I guess, would be the way to summarize that. Blah blah blah. So some of this might be incorrect. I put this together very quickly, but I just wanted to try and summarize. So Solar Orbiter has 10, 4 in situ and 6 remote sensing. So we've got the Solar Wind Analyzer, which is an in situ instrument. Basically, it creates time series data, where n is supposed to represent the dimension of the data. It could be many like single time series or a time series with multi dimensions, essentially. So I think SWA is more or less a lot of single time series. MAG produces vectors, which, depending on the way you want to treat them, you could treat them as, the 3 components of the magnetic field as 3 independent time series. They're not really, but you could represent them that way. EPD produces kind of single value time series, but also 2D time series like spectrograms. RPW is the radio and plasma waves instrument that is kind of in both camps because it measures the in situ properties of the electric field and also the magnetic field to a certain extent, but it also measures radio waves which have propagated from a remote location. And then
Shane, can I just
go for it.
Just for clarification here, when we talk about time series and like n dimensions, are we talking about geometric dimensions, like a perpendicular, or are we talking like what some time series scientists say a dimension is, which is just another column in a table?
I just mean another column in a data array. Yeah, that's what I'm talking about.
So it's not so much a dimension as
No, it is.
right, but scientists like who deal with time series, if you have another column, they call those dimensions. They're not, in my opinion, but I just want to clarify that if you wanted to represent these time series, you'd use a 2D table, with n columns rather than an array with n dimensions. Is that?
Yeah.
So they're N1D arrays rather than 2D.
Or ND arrays, yeah.
Yeah,
N1,
some, I guess EPD has a spectrogram. I don't know whether.
Yeah.
Or,
No.
do, right?
No.
Sorry?
Well, so for example, for the solar wind analyzer, one of the data products is velocity distribution functions.
Okay. Yeah.
And so there you have a function that depends on time, but also 3 velocity dimensions.
Okay, and they're all independent.
Yes.
Right, okay, fine. So that is truly dimensional.
Yes.
Yeah.
Yeah.
And what about the others? Are they all like that when we say n dimensions, or do some of them do we mean just a column, like a different property measured also as a function of time?
It depends on the data product and instrument.
Okay.
So MAG, for example, is just like 3 columns, which are 3 components of a vector.
Okay.
I mean,
Right.
I think that SWA also does density, but density is obviously not a vector thing. It's just a number as a function of time. So I was trying to get with n is that it's not one number. It could be 1, 3, or 2, I guess, in different cases, and sometimes they're linked, and sometimes they're not.
And sometimes they're like perfect. Sometimes they're dimensions, and sometimes they're just different properties measured as a function of time. Okay.
I mean,
All right,
you can think of an AstroPy table with one time axis and then a bunch of different dimensional arrays as the columns. I mean, that's one way you could think about it.
Different dimensional arrays. Okay. All right. Actually, that clarifies it even more. Okay. Thanks. Yeah. I was certainly confused by that.
Yeah, and then you've got the more traditional remote sensing instruments. I'm not actually sure about SPICE in terms of exactly what you can get out of it. I guess you can get space, wave by time with like a raster scan, but most of these are typical map sources. So Phi will give you a space map, EY the same, Metis the same, Solo High. It's a bit of a weird map, but it's a map. And then Sticks and Spice are kind of special cases, I guess, that produce more complicated data. Yeah, I don't know if anyone else from the solar orbiter side wants to jump in and question or clarify anything there before we move on.
Yeah, move on.
Okay. Yeah, so then just in terms of the data that's in the solar orbiter archive, David can talk more about this because he wrote it, but this is a little Streamlit, I think, page that gives you a summary of all of the data that's currently available in the solar orbiter archive. And you can see here some nice information on the distance and the angle between the Earth and orbiter. And you'll see that it's not continuous, particularly for a lot of the in situ ones. So EUI, particularly, it operates in these little bursty windows. And again, depending on your science case, you're going to want to search and be able to pick out very specific things where maybe, there was a high-res EUI image. Phi was also doing something, and one of the in-situ instruments was doing something some hours before to answer your science case. I guess... Where's missing a slide? Sorry. Why did this happen? There we go. So yes, from the SunPy side of things, there's 2 things that we really want to support: getting data, so that's searching for it in the first place, and then an obvious follow-on step, but it is a separate step, will be then to download it. And then once you have it locally, then you want to interact with that data. We want to be able to open it and load it into a map structure, a time series structure, hopefully plot it. And then I guess analysis is maybe a step too far, but I guess ultimately we might like to support some basic analysis of this data. And then if we think about what the instruments make and the support in core. So what I tried to do here is basically, if it's got an orange, I guess we kind of support it in core. If it's got a green, we definitely support it in core. And then the notes here would be like the I guess SunPy object that would be used to represent the data. So I think for any of the imagers, if we have proper header information, they should all work in map. I have question marks because I'm not sure about if we've actually tested this with like phi data. I know that we've had some solo high data before, and EUI definitely works. So I think
just to clarify for peers who has just said they're all green because colorblind, the top 4 of those circles in the core column are orange.
Yeah.
And the one underneath that is green. Sorry about that.
Yeah.
No worries. Thanks so much.
That's my bad. Here, I'll just fix this live.
Is there Metis and solo HI data publicly available?
Metis, yes. Solo high, I don't know. I assume so, but I'm not.
Link me. Let's go.
It's not yet. I think you have to know someone who knows someone. They're just testing it, right? It's not.
But I mean,
it's not that they're like keeping it. It's just they're not sure. Yeah.
If you do know someone who knows someone, it would be interesting to make sure that we have a map support working, and then when it when they do publicly release it, it will be prepped and ready to go. So
well, I mean, I definitely think we, as in I or maybe Laura or Dan or something, one of us can take an action to reach out, and I'm sure we can get an example file or files from those guys. They do have data. They do not
technically get them by the end of the week. They have to submit their tutorials.
Yeah,
but
yeah, that's a good point.
Yeah.
Well, it would be good to make sure like we have working.
Yeah.
But it would be good for the SunPy tutorial or the workshop to be able to show the very least 3 map plots for all of the space-based instruments, right?
Yeah. So P and EUI work.
I'm just checking it.
Yeah.
Is the plan? Do you know if the plan is to distribute solo high through the SOAR, or is NRL going to do their own? Okay.
Yeah, but it seems to be each instrument's team is also distributing their data themselves as well.
Yeah,
right. So
definitely.
you can get UI data, you can get peak data, you can get things, but the finalized complete data should be on the SOAR. That's my understanding.
Why do something once when you can do it twice?
Or 10 times.
Yeah.
Or 10 times.
Well, but it's also because the SOAR archive has a bunch of limitations on what they'll support and what they'll take. Whereas if you have your own instrument archive, you can do what you want. So I think that's why a lot of teams have their own stuff as well.
Is Metis on the
David has a Metis update.
I have a Metis update. It doesn't. Their bit header is not correct.
Yeah. Make that. I suggest you make that question mark the angry devil emoji.
Well, I have this. Is that any of the imaging stuff should work with map if the headers are correct? If the headers aren't correct, then they should fix their headers, or we'll have to make a custom map source, I guess. But I think that data should be relatively easy to support. In terms of the in situ stuff, when we have simple 1D data, so example like solar wind density, I think that's probably going to be fine in time series. I don't know, David, do you want to maybe say more about the like that example you gave where we have the 3D velocity data? Like, I assume you can load it into a time series, but it's not going to behave as a vector quantity.
Yeah, Yeah, just to go back to the some of the data, the solar wind analyzer in particular produces. So you get what's called a velocity distribution function, and that's a function of time. So you measure that like every 30 seconds, say. But you also measure that as a function of three velocity components. So velocity x, velocity y, velocity z, and those are three velocity dimensions. So conceptually, it doesn't make sense to just represent that as a load of columns that are dependent on its time. It's data that is dependent on 4 different dimensions. And so time series is not a suitable data structure for that.
ND cube is that.
ND cube might be. But basically the data structure, as far as I know, there is no data structure available that is suitable for that data.
Inside SunPy.
Yeah, I mean, I guess ND cube might be a generic one, right?
You could probably persuade that data into ND cube. I'm not really suggesting.
But there are specific and very common data processing techniques that people run on that type of data that should be part of that data structure.
Something like X-ray.
Yeah, it's really
X-ray would be ideal.
Yeah.
So is there an instrument that's already like it, and what are they using, or what's been used so far with this?
So I think someone developed a package called HelioPy multidimensional, so HelioPy, just for a bit of context, was a library for like solar wind physics, and I basically archived that and moved a lot of the functionality into SunPy so we could support in situ and solar orbiter. Just the motivation. But someone spun out of HelioPy and never supported multidimensional, like HelioPy multidimensional package. So we should look at that as a first place for inspiration.
I guess that's a specific thing where you have truly vector data, like that's and like the mag data will be the same, I guess, is in that you get a magnetic field vector and the components are related somehow. It's not just an extra dimension or whatever.
It's not. It's still. So the magnetic field values only depend on one dimension, which is time. The fact that they're a vector is a separate thing to multi-dimensional data. So for mag data, it does make sense to store it as 3 columns. Whether you want to then, as you say, add another layer on top of that associates that vector with a coordinate system, say, then.
Yeah. Okay. Right. Yeah. I was just trying to get so we've got like 2 different use cases. Then you've got like. Yeah. Okay. Right. How would we call that? I wonder.
I guess a vector, one-dimensional vector data.
Okay.
Whereas a velocity distribution function is a 4-dimensional scalar.
So is there data similar to that on BSP?
Mm-hmm.
And if so, did they have tools to already analyze that?
Not in Python.
Not in Python. Okay, that's all I do.
Yeah. Okay. I don't even know what they have in IDEO.
Yeah. So this is interesting. Steve is probably interested in this because the Gateway mission is going to have Hermes on it, which has instruments similar to Soda Pro, and I think he's on the software. He's working on developing the software for this.
Okay.
So it'd be interesting to hear his. Cool. I think they probably talked about. I remember being in conversations about this a year and a half ago, and we're talking about what kind of data products would be out, and it's probably very similar to that. Yeah.
Yes, this is.
I was going to talk about that, I think, this afternoon.
Okay. Okay. Cool. Okay.
But yeah, this is a really common data product that a data type that lots of instruments use. It has usability way beyond solar orbiter.
Yeah.
So
it just has all this legacy code in IDL that people use. Or
I don't even think there's lots of legacy code in IDL.
Oh, okay.
Yeah, I think.
I don't. MATLAB probably use for this type of stuff.
I think people just have used their own code.
Okay.
Or so typically a lot of people don't interact directly with these four-dimensional things. They just use the density that you derive from it. So I'm trying to think what a remote sensing. I guess it's like having a black body spectrum, and in like a lot of people would just care about the temperature of that spectrum instead of the actual spectral data.
Okay.
Like deriving the moments of your distribution.
Yeah, that's exactly what it is. Yeah.
Okay.
If that is language that makes a bit more sense to remote people.
Tell us more of your ways.
Yeah. So yeah, I think we include that as part of the roadmap. This multi-dimensional data structure. Yeah, I'll stop talking now.
No, don't stop. That was super useful. I guess then, I mean, yeah, another type of data is like the spectrum. Well, it's kind of related, but yeah, spectrograms, which EPD certainly produce, OPW can produce. I guess that's a subclass of what we've just been talking about before. And then I guess the question is, how can we improve the support in SunPy for this kind of data, in terms of SunPy core, and then also I was thinking of, what sponsored, affiliated, and other packages already exist. I guess Danny, what's the story with Spice data and the spectrum object from IrisPy, or like the integration with that?
So I haven't looked at this for a while, but we have Ed online, right? Who's working with Terry on the Spice stuff. Ed, have you been using the SunRaster data object, or have you been working on other things?
I have used the SunRaster data object. There's a routine that you can load a Spice fits file, and it gives you an ND cube object, or rather an ND cube collection, one for each window. I believe SunRaster does not support Iris anymore. I think that was actually removed from SunRaster. Nabil could speak better to that. I'm not sure what the rationale behind that was.
So, well, quickly, the rationale was there's an Lockheed's Iris specific package, and it basically was sort of, well, it makes sense for the instrument team to kind of own that, but there's not a Spice specific package. So, you know, it's convenient to have that bit of Spice. Yeah, so I wrote that reader. And so instead of having a Spice package that has only a reader, you know, that's why that's in SunRaster. Okay, so like so kind of going back to Shane's question, what specifically were you asking that maybe between Ed and myself we can shed some light on?
Yeah, I guess will there be Spice support in SunRaster or somewhere else in the ecosystem that people can easily access in the future or now?
So, to my knowledge, last time I looked, there's Spice support in SunRaster to read Spice data into more generic SunRaster data objects. But since then, Ed, you've been working on other things. So maybe you could answer what's happened since then, if anything.
I don't think anything's happened since then. I haven't written any code. I fixed one little bug, but that was the extent of it. I've used the code, but I haven't contributed to it.
Have you discussed as to whether more Spice specific tools should be put into SunRaster or put into like another package that may import SunRaster?
I'm not sure. I don't think there's been any specific discussion, none that I've been a part of. I've only been doing this for a few months, so I'm not privy to everything that's going on and what all the plans are. But no, nothing that I know of.
Okay, that might answer your question, Shane, basically with a question mark.
Yeah, well, I mean, that's fine. Yeah, I mean, that's really all I slide-wise prepared. I guess the question is then, we go back to how can we improve this? What's the way forward? And like what's, I guess, feasible in the short term? Because we have an awful lot of plans for SunPy, the project in general, and we were all extremely busy. So what would be actionable short term to improve this now, and what's, I guess, longer term roadmap goals? Yeah.
So I guess we decided, just to be unhelpful, we decided to probably PR back in this, to PR the SunPy solar
Yes.
back into core, which would help with some of the download research. That doesn't include all of the solar data. Or will eventually.
It will, yeah.
Okay.
Yeah.
So I think that would cover downloading and searching permanently for SunPy core at least.
I think so, yeah.
It should in principle, yeah.
Okay. So that fixes that problem, I guess. Then the other problem is opening all the files.
I mean, Dan, you mentioned pulling out a spectrum object from, was it SunRaster or IrisPy, or where?
Pulling out, so you mean pulling out the core, do you mean?
No, just yesterday, I think you mentioned something about that there was a spectrogram object somewhere. That we
Yeah,
could
so there
think
is.
about.
Yeah, so in SunRaster, hang on, I'm just going to pull up the code so I can make sure that I'm saying stuff that's in date.
Yeah.
So give me a moment.
Yeah. No worries. Sorry, I don't mean to put you on the spot. It's just I was
No,
thinking
that's
that
fine.
we have radio spectra, which has a spectrogram object. It's not great, but maybe if we could look at the spectrogram object that you have, we could pull that up and then use it in radio spectra and also for other spectrogram-like data, like EPD,
Yeah, okay.
for example.
Sorry, just to remind me, Shane, I forget. Your spectrogram 2 object does not. What is its base type?
What is its base type? It might just be an object, or it might inherit from a ND array. I'd have to actually go and look. I don't remember. I mean, the plan has always been to.
Yeah, I just wanted to. I couldn't remember, so I thought you might remember. So I can look it up.
I mean, the plan was always to make it an ND cube because a spectrogram is essentially an ND cube type data.
So so to answer your question, Shane, in the Sun, I just realized I have a different laptop today and I haven't installed Chrome, so I probably won't be able to share. Yeah, like, you know what, I'll give it a quick try. Actually, no, I'm not even logged in yet. So yeah, no, if you go to, I'll put the link in the chat and maybe people can look at it, or if somebody in particular wants to share their screen, that's fine. So it's in the SunPy coordination meeting element chat. But yeah, so this module, it has a spectrogram ABC, which just tries to define the API. And then there's a spectrogram cube object, which inherits from NDQ, and then also the API defined in the ABC. And this is not specific to rastering or anything. It's just if you have a cube of spectrograms, it's an ND cube with all the stuff that comes with that, plus a few kind of more intuitive, mostly convenience methods. So what it does is it also defines instrument axes. So like ND cube, you have physical types on the different data arrays, but when you come to a spectrogram, the physical types, you have to, like, each axis corresponds to some kind of like instrumental configuration. So you have like space, time, spectral, and so it tries to define which data axes correspond to those.
Who's screen sharing?
I'm not.
Okay.
I am. Do you want me to stop?
It's just apparently it stopped working, but it's not actually Danny's screen who's being shared. So
yeah,
you might want to stop if you're not actively sharing something. Shane.
Well, no, I'm not actually logged in because I was hoping someone else might share that.
I was.
So I think
that's
what Shane was trying.
Obviously, it's not working. Stop.
Yeah. It hasn't worked on our end anyway. If anyone else wants to try, that's fine. And then as well as that, it just provides some slightly more customized slicing, and then provides sort of convenience methods to, if you want instead of having to go through like pixel to world or world to pixel or that sort of stuff, you can just do dot spectral axis and it gives you back a quantity or a spectral, hopefully in the future, like a spectral chord object. And same with time, exposure time, it gives you like celestial, so you can get back a sky chord of the different spatial coordinates for each pixel. And then as well as that, it allows you to apply an exposure time correction and to like undo that. So, it has exposure time set there, and that will basically just figure out, have you already done this based on the unit, and then it'll divide your data by that. And, if there are a couple keywords that allow you to then undo that if you want to. So that's basically what the spectrogram cube object does. And then there's also a spectrogram sequence object too, but if you have that spread over multiple WCSs. So that may well be something, that may well be the incubator or like the progenitor of a spectrogram object that could potentially be moved to core at some point. And that should be valid for SPICE and IRIS and any spectrogram, I think, at least in principle.
Okay, cool. Yeah, I definitely think there'd be some stuff that would have to be pulled out to get a radio spectrum in there. But I mean, that's not a problem. I think one of the interesting things that it would be really nice to be able to do is to like obviously for the maps we have reproject so that you can overplot images from different viewpoints. But for the time series stuff, it would be really nice to have similar context managers, where you could do something like with radial propagation something, and then you could plot two time series on top of each other where you've accounted for a radial propagation model or a Parker spiral propagation model or something like that, because a lot of times you need to overplot two time series from different places, accounting for the propagation time, I guess. And to make that easy would be super useful. Akin to how reproject works for maps. So I think we'd have to incorporate some sort of observer position information into any of these objects so that we could support that kind of use case.
Yeah.
Including the time series you want, presumably.
Time series or a radio spectra one, but whatever. I mean, with radio spectra, you'd want to do a light travel time correction, but it's the same sort of thing.
Mm-hmm. I mean, that's potentially true of any measurement, any type of measurement, right? That's based on photon.
Yeah, I guess so, yeah.
There is no such thing as light travel time. It's fine.
Good thing Albert's not awake.
It's more fun following Albert when he's not listening.
Do we want to keep discussing? Is there more to discuss on this? I had two other things I wanted to chat about at some point during the session.
I was curious to ask Ed about what SPICE work he was actually doing when it comes to software in Python, and just to clarify that.
Yeah, I can speak to that. I did a quick look viewer. I don't know if Terry shared that. I know she went to a conference in France a month or two ago, and she shared that. It's just a simple little GUI that you can open up a SPICE fits file, and you can take a look at stuff, and you can see the spectra at different points. It's, like I said, it's a quick look. The idea is that it's just a simple way of looking at fits files and getting a general gist of what's in them. Since then, I've been doing spectral fitting software. So that's what I've been working on for the last, about 2 months, is exploring fitting in the spectra and how that's done, being able to identify lines. So we're hoping to have some sort of a graphical user interface, possibly within GlueViz, which is something Nabil turned us on to a while ago. So that's what I've been working on in the few months that I've been here.
Okay, great. And where do you envisage those tools being available? Like through Sunraster, through a SpicePy, or one of the? Actually, I'm not going to use that phrase because that's going to loaded. But a spice specific Python package.
That is an excellent question, and I wish I had a good answer for you. That is something that needs to be determined, and that's something that's going to be a subject of discussion. And it's already been a subject of discussion just between Terry and myself about where to actually make this code available. That's something that we need to determine.
And then my final question on that then is how, at least first in principle, and then I suppose in practice, based on how you're actually coding it up, how specific to Spice are these fitting tools?
We're trying to make them we're trying to make them device agnostic. So we want them not to be specific to Spice. Obviously, we want to support Spice, and that's going to be our first priority. But we also want it to support Iris or other spectrographs that are out there.
What are you using? What are you building these fitting tools on top of?
I'm using the SunPy fitting.
Excellent. Stuart looks very happy.
That's the correct answer from Stuart's point of view.
Yeah.
With this, I mean, if/when you want to get to speeding up fitting many pixels at once, come talk to me.
Yeah.
Okay. Yeah, I'm happy to work with you on that. I can point you in the right direction and set up conversations with the AstroPy maintainers to make that happen, but it requires a chunk of work.
Yeah, that's what I've discovered. That was what I spent about the first month doing, was benchmarking different fitting technologies, because when you're going to be doing every pixel in a window, every millisecond counts.
Yeah.
Because it multiplies out real fast.
Actually, I think Terry had asked. So Nabil and I have been, and Nabil especially, have been meeting with Ed and Terry periodically for the past couple months. I think she had asked specifically if we could put her and Ed in touch with the AstroPy folks who would have a better handle on what needs to be done to make kind of vectorized spectral fitting possible. So that would be great.
I've done a bunch of work on this. Somebody tried to persuade me to take money to do it, and I ended up having to say no because I didn't have the time. But I've done a bunch of work on figuring out where to start, but never had the time to actually do any of it. So there's open issue on AstroPy that contains a bunch of that information, and I know who to talk to, and I know there's general feeling of we should work on this, but it requires, the first step is going to be getting consensus within the people who maintain AstroPy modeling as to what the correct way forward is. So it desperately needs doing, as no doubt you know, and if you've got the time and the motivation to do it, that would be absolutely fantastic.
That sounds great.
Yeah, so I know we're kind of focusing on this. Maybe this is a little less general, but one question and then one comment, and then I think I'm done. Is this fitting? I suppose it depends on the answer. This fitting infrastructure. Are you reading it into the Sun raster object and then using that to store the data, or is it like a totally fully custom little environment?
I'm not sure if I understand it. I'm not sure if I can understand the question.
Okay, so what object?
I can tell you what we're doing. We're using the Sun. Okay. We're using SunRaster to read the Spice files and then fitting the data that we're getting out of SunRaster. I don't know.
Okay, so the data is stored inside a SunRaster NDCube-like object, and you're accessing the data from that. Okay, good. That sort of helps me understand the link between what you're doing and the slightly more general SunRaster package, which is kind of under the SunPy umbrella. And then a comment which I'll throw out, but we probably shouldn't get too deeply in. But if this tool does end up being truly general, is something like this, if it was applicable to any solar spectrograms, is that something that Core might, in the long time future, would that be within scope? of core in the future, in principle. That's just a.
I can definitely envision that being in some masters for a long time. The idea that maybe that would be cool.
Or even Sun Raster, yeah. I mean, I suppose that's.
Okay, that's probably where we would start. Adding that to Sun Raster.
Yeah. Okay. All right. Great.
Well, that's what I want.
Yeah. You know, well, thanks so much for explaining that. It sounds like it's.
It's my pleasure.
Some really good work and with much wider applications than just Spice, which is exciting.
Are you in the coordination meeting element chat, Ed? Are you in here? Can I ping you things in here, right?
Yes. So if you want to send me anything over the text, feel free.
Oh, do you mean the Jitsi chat or the element chat, Ed?
Oh, I'm in the Jitsi chat.
Yeah.
Is there something else that I'm supposed to be in?
Not necessarily supposed to.
There we go.
But
I just saw the GitHub link, poll 10985.
Yep. Yeah, that was my last attempt at parallelizing nonlinear fitters in SunPy. It was always only ever going to be an experiment, but
okay.
It's triggered a discussion which we can pick up again if someone's got the time to work on it. So I'm very happy to. I'm very, very happy to facilitate that happening.
The parallelization.
Yeah.
Okay. Excellent.
Facilitating a keyword.
Not doing. Yeah.
So sort of leading on from this, I just wanted to ask what the status of our contact between instrument teams developing stuff like this and the project is, and I guess that's the instrumentation working group.
Yeah.
So what is the status of that?
You're missing the streams. That's later in the day.
We can skip that and talk about it later in the day.
I think it's one.
That's the status, right? Is so yeah. For context, for people who don't know, I give this instrument working group. I think Steve and Stuart and a few others kind of started out. Kevin around like end of 2019, so in before times. And the first
before the event.
Yeah, that will not be spoken of. The first kind of meeting of that was in I think December of 2019, and there's one meeting in early 2020, and the thread has not been picked up since then for reasons. And so what part of the funding, like I mentioned on Monday, with the Stoffel funding, part of my work is doing that, reaching out to instrument teams to start up that effort again, or at least that's the way I'm choosing to interpret it. And so what we are trying to do, at least as the purpose of the sessions this afternoon, are basically just to more or less redo that first meeting that we had in 2019.
But that's not specifically solar orbiter, right? That is a more general.
Yeah. That includes a lot of solar orbiter folks for sure, which I don't think it necessarily did in 2019. I think that sort of the instrument landscape has changed. Not that solar orbiter wasn't a thing in 2019, but that the instrument landscape has changed quite dramatically. Since, I think in our presence in the community of hot since then. I think that I foresee the primary purpose of the group, at least initially, is just like surveying people of like, what are you doing? Not even like Python, SunPy, just like what do your instrument, like what does your data look like, and what do your analysis tools look like, and how can we help?
So if ahead as a summary, run through the different SunPy instruments, how established a communication link do we have? Well, sticks very well, even if it's just informal, because at the very least, Laura, Jane, and myself, and I'm not sure who I'm forgetting who's online, are basically part of the sticks team. Like, you know, if we ran through, I assume the remote sensing instruments, not really so much. I mean, maybe David, I don't know if you have
Well, not anymore.
Not anymore.
It's pretty.
I don't, yeah, given I don't do soil physics research anymore.
Right, yeah. I mean, like through your sort of knowledge of SOAR, that's all I meant.
I mean,
I'm not in contact with any instrument team.
Okay, that's
I
fine.
think Jan, who's on, is probably been, I mean, I don't know, Jan, I guess maybe I'll let you speak that. I mean, I know you have more interaction with the kind of in situ side of things on Solar Orbiter.
Yes, hi everyone. Yeah, I'm in contact with the Solar Orbiter EPD instrument team, where I'm like a co-I, but I'm not so much involved with the other Solar Orbiter instruments.
Okay. Yeah, I mean, I think that's probably the most contact we've had with the in situ side of Solar Orbiter.
From my understanding, it's not even that they're talking to each other and then they're not talking to us, right? I don't think anybody's talking to anyone.
No.
Right, so that's another thing just to keep in mind, right?
And then going to like EUI, we certainly have personal relation. Like I have personal relations with people that are a base you. I don't know if it's like a formal or even a reliable open channel, but it shouldn't take much to form that, right?
I mean,
Yeah,
if you wanted to.
Yeah, no, I mean, I don't think we've had much contact with them in any other way.
But there's a clear, if we're going to decide to do that, and a few people here could contact people that they know well and both start that conversation.
Yeah.
But I'm not sure. There are certain other instruments where we don't really have a personal relationship or a formal one either.
I think it's finding the right person to talk to in an instrument team.
Right.
Right.
Yeah.
And I
So
think
know
that's the
that piece of
problem,
knowledge.
because when you say ask somebody like, oh, maybe talk to this person, and then they're like, well, that's not my problem. It's not my, it's like kind of hard to find it. But maybe like the Solar Orbiter meeting in Belfast would be a lot easier when it's in person rather than a random email you send and you're like, that seems like work on. And they're like, why? Yeah.
Maybe a good venue to sort of collect contact details for the different instruments.
Yeah.
Game changer.
Yeah. So even for example, like some of the sent the feed tutorial there, and they're using SunPy maps to load in B and like doing stuff with SunPy. So they're using SunPy, right? It's just there's not a contact there to do that.
I think like, I mean, as the person who's like sort of been doing the more instrument work group side of things, I'm also more removed from the Solar Orbiter like side of things just because of where I'm located. I'm more in touch with the NASA. So yeah, I mean, it would be great to be more involved in the Solar Orbiter side for those, at least for the just if nothing else, just for the game info. That's great.
Yeah.
Okay. So that basically sounds like we should think about, that's an area of improvement to basically have, if nothing else, have that contact information. And
but like, where would it be as well as that, like, talk to like Daniel Muller in the SOC and have it come from like management side of like, SunPy wants to do this, you should all like you expect that, so that it's like somewhat of a coordinated effort and not us just kind of edging in.
Well, yeah.
I think we talk to people and like Daniel, he's like, yeah, that'd be a great idea. But it's like, I think maybe we need to like realize an action plan rather than just reject. Yeah.
Perhaps even like getting someone from some of my project PI meetings, or
yeah.
I don't know what meetings they have in the structure, but having someone in the room when the PIs are discussing stuff.
Yeah.
I suspect that one should be fairly easy again, because
I
could basically just go along with Sam and like have the sticks, but also have a second hat with SunPy.
Yeah.
And I mean, that's true of you as well, right?
No, but I mean, like, not just
Daniel.
that you go with Sam to a random meeting, like maybe get it and organize, like, oh, Danny is going to be at this meeting as part of SunPy, not sticks, and do this.
Yeah. I mean, in all you, I mean, they can go.
Just so that it's like, it's coming from, like, it's an organized set thing in a meeting.
Yeah.
That's like, here, this is what we're trying to do, this is our effort. Not that you need to fit your code in with us, but what do you,
how can we help?
how can we help? I just wanted to think of that,
Okay.
That's later.
Yeah, I like that perspective. Okay.
Or even just like take stuff. What software is.
The other thing that has sprung to my mind as we're discussing is I feel like, especially personally, I'm throwing a lot of suggestions out there, but I'm kind of conscious that it all takes time and effort to do all this. And I think apart from the Stoffel funding, none of it is explicitly funded. So I think it maybe is useful once we finish the meeting to just go through the meeting notes and be like, this is all the stuff we would like to do, but if none of it's funded, and kind of produce a summary you could send to Daniel Muller and say, like, we would love to help you in all these ways, but we have no one is explicitly paid to do this, but maybe if you can go away.
No,
That's a
but
really
this
good
comes,
point, actually, yeah.
yeah, but it comes back to what you said as well. I mean, even if we're not paid on, or SunPy isn't paid or paid very, very little, if it's a case where ESA dictates but encourages people to contact us and to do things in a certain way, that actually they are doing stuff that fits in with like our ecosystem, and maybe we need to do a few changes here and there, but maybe we don't need the funding. Maybe they just need to, the instrument teams need to do stuff that's compatible with us.
For sure, but I also think I can imagine in a few years there's going to be some funding to coordinate ESA observations to do cool studies. And then if we had a formalized list of things that SunPy could do, that's something we could apply for and be like, look, give us time and we can make this easier for the whole community.
I think especially maybe we should, well, it's basically what you said, but capture this like buying into this whole ecosystem enables, and Shane's already said this, enables these like multi-instrument studies and will make this coordination down the line. If all of your data products are the same and your analysis tools are in the same ecosystem doing those types of studies, that it enables those types of studies and lowers the barrier dramatically to doing that.
What you're saying is we should have objects that inherit from time series and objects inherit from ND-cube, and everything has the same API, kind of what you're saying.
I will not be quoted the same.
Okay.
Yeah.
Right, okay.
I mean, on a related note, like, should we open issues to add support for this additional data on the issue tracker? Do we need a SEP for SunPy? Like internally, regardless of the funding aspect, how should we formalize the approach to try and improve the support for these extra data types within SunPy, the project, I guess?
The roadmap maybe is a good place for those kind of higher level big tasks.
Yeah.
I suppose having a list of, I mean, I know you sort of showed that table up there, maybe sort of something like that where it defines, well, what are the data types? Like what objects do we need to store data from each instrument? So you had that rightmost column, I think that said like time series, and it sounds like everything else would, or almost everything else would be compatible with some kind of ND-cube derived product. So maybe like having that, but then having like, the physical types for each data product, that would probably make that a lot clearer. And I'm sure there are a few data products for each instrument, so it's not like necessarily a tiny job, but I'd say that's a good start. For example, your spectrogram object.
Identifying the sources that are needed.
Yeah.
Right.
And not just the sources, but the data types.
Oh, sorry, I meant data types, yeah.
Yeah.
And then how much can ND-cube help with making all the APIs?
Like math, for example, time series exists, and then a spectrum cube object exists, although it's in finding out, do those three things, does that get us basically there? Sorry?
It's bad idea.
It's all just ND-cube.
Yes.
Okay. Let's just get rid of math. Yeah.
I think like there is a serious discussion to be had about type proliferation like that. Like, what functionality are you adding by subclassing that you couldn't add in other ways, which would mean that, right, like if you have a fitting routine that fits down a spectral axis, that should not be a method on a spectrogram class, which isn't in a spectrogram class, right? And I think we really need to move away from the immediate reaction of I've got some data, I'll write a class for it. I think that's an anti-pattern.
Sure. All right. So just to partly answer that, when with the sunraster object with the spectrogram cube, it's largely convenience methods, but instead of having to do like axis well coordinates, like in all that spectra, you just do dot spectral axis, and you'll get back, the wavelength or the energy or whatever it happens to be for that axis. And I wonder if, Ed, when you are accessing the data as part of your fitting, are you using those convenience methods at all? Like, so is that something that is maybe not technically essential, but incredibly handy? And something like that is, for example, something that should not live on a generic ND cube. So yeah, Ed, do you use those convenience methods? Dot spectral axis?
Sam says no audio.
I'm not sure. I'm not sure. I'm not as familiar with the code as maybe some of you are. I'm just using the world coordinate system information that comes along with in the ND cube object to get axial information about which axis is spectrum and which is X and Y and T. I don't know if that answers the question. And also, we're having a little bit of connection issues.
I think it does, yeah. So that's the okay.
Useful alias so people can interact with it because they might not be used to working with ND cubes. Yeah.
Yeah, I'm not saying that there's no potential upsides. Saying is we need to really think about it, because solar data comes in so many forms and so many shapes that if we write a whole bunch of really useful functionality for data which is space-based wavelength, and then you come along with data which is space-based wavelength time, you suddenly can't use it anymore. We've just absolutely shot ourselves up.
So what you're arguing is that we shouldn't have analysis methods, we should have analysis functions that basically like scan the input type
and rely and only work with the ND cube API.
Right. Yeah.
Right. Like if you want to write a spectrogram fitting function, it can take some future spectrogram class when I inevitably lose the argument that should exist. But if the fitting routine only depends on ND cube, it can take a spectrogram class, or it could take a DKIST dataset class, and it will work with both.
Yeah, I've always been more on your side when it comes to the analysis side of the functions taking the objects rather than like hard coding those methods on a specific class. I've always been a fan of that, but I know not everybody is for other reasons.
Just because, like, for instance, taking DKIST as an example, you could say that I've caused this problem to exist by my own work, but DKIST has an ND cube subclass, which is nothing to do with the physical type, the world type of the data. It's all about downloading the data. Like it gives you functionality for downloading bits of the data and managing the fact that the data is striped over many files. So if you were to convert that to a spectrogram class for the spectrogram instruments at the DKIST facility, you would suddenly lose all the ability to download parts of the data. And like there's a load of fun. So I think I've had this conversation at the SunPy coordination meeting in the before times and like various other points. I'm going to lose this argument, but I really don't think we should be writing a spectrogram class.
Do you think we should be deprecating map entirely?
Ultimately, maybe.
Okay. all right.
Like that, I think like that's a really high bar, and whether we'll actually ever do it or not is a different question.
But that's a logically consistent argument with
Yeah.
with what you're saying.
I mean, like rotate. It would be nice if rotate was a method that took an NDQ,
Function of NDQ.
a function that took an NDQ.
But you can abstract the functionality while still maintaining the map API for language and familiarity purposes.
You can, and that's almost certainly why I'm going to lose the argument. But the problem with doing that is if somebody's used to using a spectrogram class for iris data, and then they want to use the DKIS data with the DKIS class, it doesn't have those helper functions. Like, and
Helper methods.
Helper properties like a dot flux, which is like spectrum 1D, for instance,
Right,
or
right.
like whatever they've got, right? Those helper properties and things that exist on the classes specific to a set of world axes don't exist on all the classes.
Yeah.
And then, like, what happens if you make a space-time and a space-based wavelength as two separate classes, and you're used to using the time helpers on one and the wavelength helpers on the other, and then suddenly you have a DKIS cube which is space-based time Stokes, you've got none of the helpers.
Yeah, I agree.
So it's like it's both a technical and like teaching the users how to interact with the data problem. I think like giving people too many helpful APIs can be a bad thing.
I'm very excited because the whole thing about creating a POC of like NDQ with map became very, very easy all of a sudden.
Yeah, just import NDQ.
Yeah.
So you're saying that the recommendation is to have single data structure and then your functions target specific
sets of wave axes.
Directions along that. Cube.
I'm thinking like we could write a decorator or something that you could put on an analysis routine that took an NDQ and verified that it had a wavelength axis, and even maybe like it could make the wavelength axis the first axis, so that when you write your analysis, I'm not saying that's a good idea, but one could imagine a scenario where it like also, or maybe it just tells you what axis is the wavelength axis, right? Like it injects an extra argument to the function, which is like this axis is wavelength or whatever. But it helps you. It makes it easy for you to implement an analysis routine on any NDQ where you care about some physical axis, but you don't know where it is in the cube, right? Because one of the DKIS spectrogram is space wavelength in space.
The dog agrees.
Yeah. I knew I liked that.
Milo agrees enthusiastically.
Okay, so bringing it back to what we're actually talking about, the way that we support Solar Orbiter is don't create new classes, just create analysis function.
And
that's what I'm deriving from Stuart's input.
how do we get instrument teams on? How do you get instrument teams on board with that? Because instrument teams will want to write their own things in their own way.
Maybe how do we sell the interoperability story? But I guess, as an individual instrument team, do you necessarily care about prioritizing that? I mean, or is that something like you all were saying that the mission itself should kind of impose? Like we want the point of this whole thing that we have in situ data and remote sensing data all measured from the same place. We want to be able to use this together. That's the whole point. And if our analysis tools are all over the place, then we're not going to be able to do that.
It's one of the arguments like saying we already have a data structure for you. Like what you have to do is write a function that reads your file into this thing that already exists, and you don't have to. You can read the API, and you don't have to worry about implementing it. I mean, that's, I would say, someone says, great, I've got to write one function, or however many like products they have, and don't have to worry about the data structure.
And then your users only have to deal with a single data structure, and they just pass it around.
Right.
It all looks the same. The API is all the same.
Yeah, and then you can go back to a little bit of the SSW model where you have like a load of functions that take that data class. But the discoverability is the thing that's against that. But
No, sorry, you said.
I think I say on a higher level, I think instead of going to instrument teams and saying this is the way you should do it, we should be listening to them and advising them, but also using like what they want as their requirements to inform what we do.
so we need Belfast.
Yeah, because like the question is, like, I don't know whether some teams are purposely going out and writing their own instrument-specific software to give to you. But, I mean, we don't know, so it's hard to compare this. Or maybe there's just no Python tools that are going to be developed for certain instruments.
I think that's certainly the kind of knee-jerk reaction from any instrument team is like, oh, there's not a AIA cube, let's write an AIA cube class. Or there's not an ICE cube, let's write an ICE cube class.
I don't think that is limited to just instrument teams. I think
No, that's
I think
we all
that's-
like
you're not
Instrument teams, we're talking about instrument teams.
no, I know, but I'm saying people, lots of people, not just instrument teams, go. I have thing. I should write class for thing, right?
Yeah.
And that's a kind of a pretty common pattern in Python in general. And
Yeah.
there are
Yeah.
problems. All I'm really trying to say is there are problems with that approach. And
in this context.
Yeah.
You can take my iris map cube out of my cold dead hands.
Okay.
But yeah,
We will.
I'm just very wary of the go. Can we really want to avoid getting them saying you're doing this wrong?
Yeah.
Oh, yeah.
Oh, we
100%.
definitely shouldn't say that.
And yeah, I just be really careful about.
Because there's other
Oh,
stuff that
I
we're
think-
not thinking about, right? That they know about. They know their instrument.
Yeah.
I think like if Ed writes a fitting routine, right?
Yeah.
And we say, if you do this, you can use these tools that already exist.
Yeah.
That is a much,
Yeah.
that is a cell that has clear benefits, right?
Yeah.
Like, but I think we should document somewhere. There is the beginning of this run in the NDQ documentation. Like we should document somewhere and write the tools like the decorator or something, like to encourage people to at least write the analysis, like the functionality as a function, and then put it in a method, call it from a method if they want to. Like at least if we start building up a library of this functionality that all various different instruments need in a way that works across as much stuff as possible.
So this sounds like the NumPy compromise, right? You can do np dot give me an array or array dot whatever that functionality is.
It's not very Zen, and I don't like it, but it has advantages, has discoverability advantages amongst other things.
Well, so long as your method is just a wrapper call to function, it might not be pretty, but it's not really that big a deal.
Yeah.
Like not compared to what it otherwise would be.
Yeah.
I like this. This is really interesting. Yeah.
In this vein, I'm going to crowdsource one of my slides from later in the afternoon to everyone. So this has to deal with, David, your point about how we approach instrument teams.
So could you somehow make that bigger on the screens?
Can you minimize
Can you
the?
kill the chat?
If you like actually slide present, and I'll get rid of the chat as well, and then.
Great, thanks.
So this is the kind of like the approach that I want to pose to like the discussion for later this afternoon about like basically, ultimately the question is the last one, what can we do to help? But I want to approach this sort of like very much like not this is what you should do, but more like what are you doing and what are your needs? So the first thing is just like what does your data look like, right? And then what are you doing as far as developing the tools for doing things with that data? And I don't know, but this is just to say, does anyone have suggestions as far as like what are additional entry points to this discussion about offering help while also suggesting, a particular strategy that we have in mind? That's the thing I wanted to pose. And this is something we can also talk about over lunch because I realize we're getting too close to that.
I think that last question can go both ways. In this, we should and must ask, what can we? But we can also inform them. This is what we can do to help, and what of those things is if you can use Ed's fitting infrastructure because it's agnostic as long as it's an NDQ. You don't have to write the fitting infrastructure because Ed's already done it for you. So we can not tell people how to do it, but let people know that if they choose this route, this is what they get. So like telling people depending on their decisions and then asking them what they already know or believe that they need.
Okay. Yeah. I think what we can do to help will probably naturally follow from a lot of their like responses.
I mean, is this just a discussion questions to ask instrument teams? Or
like the first half is going to be kind of a lightning talk point. It's going to be similar to like what we did for tests. Like the first half is going to be kind of like lightning talk, show us what you're doing. So I guess actually probably some of these will already be answered going into this, but show us what you're doing. And then the second part is sort of like just like a forum or let's talk about this.
Yeah. Is that for this afternoon or are we talking about trying to do this in Belfast?
Well, we are in Dublin, so.
No, but I mean, because we had a solar orbiter workship in Belfast, all these instrument teams are going to be there.
So this is for this afternoon, but by all means, you should do this in for the solar orbiter meeting as well.
I think a pitch, a really good pitch, because like a lot of instruments maybe aren't already kind of like or kind of heard about. Maybe need a pitch of like, why would I put my thing in SunPy? Like, you know what I mean? Like we come up with like a really. I mean, we have lots of pitches, but like a short, quick one specific to solar orbiter. Which would be something to think about that we can.
The question isn't like, why should I put that in SunPy? It's like, why should I be compatible?
No, should you come to us? It's like what are we trying to do and what? Right. And
did you know if you do it this way, you get this nice benefit that has already been available to you, able to now make what we're doing cool with the that you have to make.
Maybe we should actually, I think the booking was perhaps. Maybe.
Oh, right.
The shame is
the audio is bad.
Do we know where we're going for lunch?
I'd also just like to thank Up, Ed and Jan. I can't see actually who else is still online. But thanks so much, because I think that really helps trigger some of this discussion.
It was my pleasure.
Yeah, sorry guys. The audio just there towards the end just kept dropping out for like 10 and 12 seconds at a go, so I don't know.
Yeah, we should restart the system.
Yeah. Do you guys know where you
where are we going for lunch?
You're going to Saba. I just meant like Laura, Dan. Do you know Saba on Baggett Street? Yeah.
Yep. We'll figure it out. Thanks so much. And it's under your name, right?
Yeah. It's just
Okay, perfect.
Oh God. Okay, I'll chat to you after.
Okay, it's just on the phone.
Yeah. I was thinking of Saba in green.
All right. That would be insane. Walk that far.
So do the coordinate conversions for that WCS.
Okay.
It's the part of the WCS stack that returns the high-level coordinate objects like sky coordinate time that isn't working. So if you do equal to world values, it gives you back.
Okay.
It gives you back stuff. So there is a far better.
Go from there, messages.
Okay.
If you do values, it gives you back.
Okay, yeah.
So,
No, we're on this.
which is good because that's if I had to go in and like fix something in like WCS level, C level, I would have cried. But that I can probably figure out.
So I thought someone was going to look at it.
I found out about this by just random people like
Very wary there.
I'll be back.
Yeah,
Yeah.
it's exactly.
Make sure that they have. Yeah.
They probably have the transaction.
The amount. They think we paid 8 times 19 euros there.
That's what they think.
So we'll
Yeah,
just
no, I have
pay
paid.
19 times.
The math doesn't quite make sense. It's
How
1914.
Yeah, the euro is not.
But yeah, but I thought it should be more than that.
Cool.
No, the euro is almost like.
But the bank charges. I thought it was slightly.
Cool. Let's just get yeah.
So
Can we not do that?
No, everyone knows, everyone on the call knows that we didn't. We tried to dine and dash.
SunPy promise.
Yeah.
SunPy, we will not buy your lunch.
Oh boy, here we are. Okay. Okay. Thank you everyone, especially online, who has dropped in for this session. So this is going to be the instrument working group session. The basic idea here is that we want to get sort of feedback from the a lot of the instrument teams who are in the process of developing user tools, and to just basically understand what we as the SunPy community can provide to instrument teams to basically facilitate the development of those analysis tools, and what we can provide to make it easier to develop those tools and make it easier for people to use the data from those instrument teams. So I think before actually we jump in, probably we should just start by going around and having everyone introduce themselves. I guess we could start in the room and then go online. Does that make sense? Do you want to go first?
Sure. I'm on the
I guess
camera
can everyone hear us?
Yeah.
Okay, I know we've had connection issues in the morning, but is the audio sound okay?
Seems okay to me.
Okay, great.
Give it another couple of hours and my laptop will start cooking itself again.
Stuart's
and I'll
laptop's
have more
cool.
trouble. But hi, I'm Stuart Mumford. As well as being the SunPy lead developer, I am also writing the DKIST user tools and heavily involved in definitions and generations of the DKIST level 1 data products. I guess is the hat that's also more relevant to this session.
Yeah, I'm Will Barnes. I'm a postdoc at American University and NASA Goddard. I'm the deputy lead developer of the SunPy project, but then I've also worked on the user tools for AIA, a little bit on the ICE user tools, and now as part of my job at Goddard, I'm working on some user tools and data pipelining tools for MOXIE, which is an instrument on the QubIX CubeSat.
I'm Neil Approach. I currently work at Lockheed Martin, working on the Iris user tools, and eventually probably into the news tools as well.
Hi, I'm David Stansby. I used to be a solar physics researcher, but now I'm a research software developer, so I don't do solar physics in my day job, but I'm the SunPy release manager, and I contribute to SunPy in my spare time.
Hi everyone, I'm Laura, postdoc at the European Space Agency at ESTEC. I work mainly with Solar Orbiter. I've been involved with SunPy a little while now, kind of work on the communications side.
Hi, I'm Marcus. I am a computer scientist at Southwest Research Institute, and I'm working on the Punch pipeline.
Hi, I'm Tiago. I'm an associate professor at the University of Oslo, and I work with the spectral data from SST, ARIS, and other instruments, and I'm on the SunPy board.
Now we're going to yell out people's names. Albert.
Hello, can you hear me?
Yep.
All right, Albert Shi, Goddard. I am the coordinates subpackage maintainer, and also I mess around with a lot of stuff with reprojection and WCS. I also have hands in a lot of different projects. So
Many hats. Eric.
Yes, hello. So I'm Eric Bichin. I'm a researcher at Institut d'Astronomique Spatiale close to Paris. I'm a scientific director of the MEDOC Data and Operations Center, and I'm the project scientist for SPICE, for Solar Orbiter SPICE operations.
Great.
Cool, thank you. Jan? I'm just going to go through more people.
I'm a postdoc at the University of Turku in Finland, and I'm mainly working with charged particle measurements like Solar Orbiter's EPD suite, but also with all the other spacecraft which are flying around there and measuring charged particles.
I skipped over Shane because I assumed he was in the room, but then remembered he isn't. Shane, do you want to?
Yeah, sure. Yeah, my name is Shane Maloney. I'm a postdoc at DIAS. I guess the relevant thing that I do for this part of the discussion is I work on the STIX data pipeline and also the STIX user tools.
Cool.
Uri?
Hi, I'm Uri. I'm a member of the ARIS team at Lockheed. So I work with Nabil. I'm not a developer like you guys. I have just been a very intensive user today, which is talking about this space, and that's it.
Micah?
Hello, I'm Micah Weberg from the Naval Research Laboratory in George Mason University. I primarily work on the ICE data user tools, as well as some internal tools that we use at the lab
now. Pierce?
Yeah, hi, I'm Pierce. Well, I need to align my camera. I'm Pierce. I'm a postdoc at Observatoire de Paris, and yeah, I'm an extensive user rather than developer, I'd say, working on Nenufar, the radio station operated here.
Terry?
Yeah, hi, I'm Terry Kuchera at NASA Goddard Space Flight Center, and I'm also on the SPICE team. I'm not a developer, but I'm working with a programmer at Bain who's working on spectral fitting tools for SPICE, but also hopefully general use.
Awesome. Alistair? Yep. You're unmuted. You were unmuted. Yeah.
Well,
yeah.
Sorry, I wasn't sure. I'd only just joined, so I wasn't sure what was happening.
Oh, sorry. Yeah, just wanted to quick intro. That's all we're doing.
So I'm Alistair. I'm a research fellow at DIAS. I develop Solar Monitor.
Awesome. And then CG.
Hello, I'm CGU. I'm from New Jersey Institute of Technology. I'm an intensive user of SunPy, and also we have some software package to process radio data from the expanded Owens Valley Solar Array. We have software called SunCasa and PyJS Feed, which intensively interaction with SunPy. So, yeah.
And then Shilpi.
Hello, everyone. I'm a PhD student at Dyers, and I use SunPy a lot to process AI data and radio data. And yeah, I just wanted to come in and just see how it works and everything. Yeah, thank you.
Awesome, thanks. I think we got everyone, I'm pretty sure, right? Okay. So the kind of motivation for, so I guess for some context, and we talked about this a little bit earlier, but I think not everyone was here. This kind of effort to have an instrument working group, this coordinate effort among different instrument teams started back in 2019 by several other people from the SunPy project. And unfortunately, because of lots of reasons, both because this started at the end of 2019 and sort of tapered off at the beginning of 2020, that this effort had sort of stalled. And so with our new kind of infusion of money from the Stoffel program that Albert talked about on Monday, what we wanted to do was sort of to restart this effort and to kind of bring people who are on instrument teams developing instrument data pipelines or user tools to kind of come together and sort of discuss and kind of coordinate what their plans for developing software were, to figure out, what are the kind of the common set of things that people are doing in their software, right? I mean, we in solar physics, we sort of have a few kind of core data types, and we kind of want to do variations on a couple of high-level things on those data types. And then the last thing we want to do is kind of encourage interoperability among these projects, so that you can use the kind of same set of core tools to analyze like AIA data that you would use to analyze XRT data, and then similarly that you can use the kind of same base data structures to analyze ICE data that you would use to analyze SPICE data. So just kind of encourage interoperability and make it easy for then the users of that data to do their research with the same set of tools and disparate data sources. So the sort of structure for this meeting is kind of for the first half or so, and again, this is all like very, very informal. So I have kind of a rough structure in mind, but we don't by any means need to sort of stick to that. And obviously, people should feel free to either jump in, especially online, jump in, or you can use like raise your hand button if you'd rather do that as well. And in the room, we'll sort of try to be very cognizant of the fact that we have an online contingent and an in-person contingent as well. So the first thing I would like to do is sort of, I've called them instrument lightning talks. I think even that is too formal. For the people that are representing particular instruments, it would be great to just hear like a quick spiel about what you're doing as far as like data products go or user tools go. If you're using SunPy or Python or whatever, like that's great to hear too. But just to kind of say just a quick pitch of like where you're at in terms of developing tools and data products for the wider community. So is anyone online who wants to kind of jump in to start off?
Well, I don't have any slides, but I could say something. This is Terry from SPICE.
Sure, yeah.
And Eric might want to be a better person to talk about our data products. but we're providing our data. And one thing we're working on, I think I already said what we're working on actually, is we're working on we've got some quick look tools, but we've also got working on a spectral fitting routine that Ed is working on. I don't think he's here right now. We're trying to make it general use and modular so that other similar scanning spectroscopy instruments can use it. I should say that in case SPICE is a sort of a rastering spectrograph, kind of like ICE or IRIS. And we are working with Nabil and talking to him about integrating what we're doing with what he's doing with IRIS to try and make it more general use. We do have a Python-based reader that's SunRaster that's based on NDCube. I'm not sure if I'm covering what I need to cover, but we're definitely interested in working with other groups and trying to base what we have on, trying to make our stuff general use and not have to reinvent the wheel.
Yeah, no, I mean, that's great. That's exactly what I had in mind. I think that your point about defining what SPICE is good. That's the other thing I was going to say. If as we go through this, if you could first describe the kind of instrument you work on very, very briefly, that would be great, because I think maybe we're all not super familiar necessarily with one instrument versus the other. And then actually Ed he was here for the kind of we had sort of a more solar orbiter focused session earlier, and he was there for that, and he gave a rundown of the kind of GUI tools that he was working on as well.
Excellent. I knew he came, but I wasn't sure what he talked to you about. Great. So that's basically what we're doing.
Okay, great.
Again, like I said, Eric might want to say something more.
Not really. Not really. I mean, perhaps I can just add that the SPICE team is pretty split between IDL people and Python people. So on the IDL side, they have already pretty good tools, I think. But we are also many Python people who want such tools to be developed.
Is there an IDL analysis suite for SPICE specifically?
It's an update of CFIT, which was developed for SOHO. But I mean that works for spectral fitting. Also, I should say that the team is planning a data product of already fit lines. So people can just get those sort of in image format, but that doesn't exist yet. And we think that people will want to be able to do their own fitting in many cases anyway.
Would that be a data product available via the SOAR?
Yes, it's level 3, yes.
Okay, great. I'm sure we'll probably circle back to SPICE at some point too, but is there anyone else online who wants to jump in?
I guess I can. Oh, sorry. Go ahead.
No. Okay. I'm probably poorly placed to say this because there's two parts of my postdoc. The second half is data provision and stuff for all the data products out of the radio observatory we have, but I haven't started any of that sort of stuff yet. So, but data does exist on this the virtual European solar and planetary access platform, Europlanet 2020. So the data exists somewhere, and I eventually will want to get stuff to more easily access, findable by FIDO and that sort of thing, but also running the risk of not being able to give people radio data that's 300 gigabytes for a 3-hour observation sort of stuff. So yeah, I don't know how useful that is.
Sorry, could I step in and ask people to introduce themselves because I can't tell who's talking.
Oh, sorry, apologies. I'm Pierce.
Great. Micah, I think you were starting to talk just before.
Yes, so I can show, actually I have a couple quick slides I could show about our ice package.
Yeah, that would be great. I will stop sharing.
Just a moment. All right, are you all able to see this?
Yeah. No.
Yes.
Okay. Why can we in the room?
I will refresh this page. Back in a sec.
I'm trying to just share the PDF I have.
Yeah, I think we had this problem before lunch as well, where I shared something and no one in the boardroom could see it. So I don't think it's you or what you're trying to do. It's just
There we go.
Great. All right, we can see. We fixed our.
All right, so just to cover briefly, so ICE is split spectrograph on Hinode spacecraft. It's been up taking observations since 2006. And the last couple of years, we worked on developing what we call IcePack, the IcePython analysis code, which is tools for analyzing ice data in Python. So I could go over a little bit what IcePack does, but fundamentally, there's kind of three components to it. We've got an archive of level 1 data that we've kind of pre-processed using the existing IDL tools. We kind of chose to do that rather than trying to port all of the lower level instrumental stuff to Python. We just kind of kept that infrastructure there and just developed an archive of their HEF5 files. We have a set of command line and GUI tools for searching for data and querying the catalog and downloading data, and then actually running some of the fits. And then we've also got a full Python package where you can do a bunch of spectral fits, compute measurements, then generate SunPy maps. So just to show a couple like example plots, we have a data reader that loads data into an ice cube, just a subclass ND cube. We have functions for doing spectral fitting using multi-Gaussian fits with a constant background. It's fully parallelized, so it uses as many processors as you have access to. And then at the moment, we're using mpfit.py, which is a Python port of mpfit to the fitting, and it's very fast and gives good results. And then lastly, we have tools for outputting the fit intensities, velocities, Doppler velocities, and the line widths to maps. So I'm showing here on the right. And obviously, there's more things we can add and improve, but the core API is kind of stable now. Is not likely to significantly change. I think that's about it.
With IcePack, do you see the primary use case, like from user's perspective, is just fitting the data, or do you like fitting the data and producing like the maps that you showed, or is it also to inspect the spectral data itself?
All of the above. So like the core things you want to do with ICE is, you get the data and you need to do some sort of spectral fit to get the intensities and the velocities. But then we want to have some tools there for analyzing the results, as well as outputting it to the SunPy maps, so you can do all the multi-spacecraft stuff. One of the common things people do with ICE is like computing temperatures and densities based on line ratios. And so those require doing some sort of spectral modeling. So we've been looking at having some optional interface with maybe Chianti Pi or some other, spectral code, but we haven't developed those tools yet. And obviously, the fit spectra function we have currently, it's developed for the uses of ICE, but it could be more generalized to use some of the other fitting packages and to just fit an ND cube of spectral data potentially.
So yeah, I just want to ask a quick question. So yeah, this is Dan Ryan. For those who don't know me, I was along with Stuart, kind of led a lot of the ND Cube development, but also written a couple of things for Spice and spectral stuff more generally. We were talking with Ed earlier on about the work he was doing with Terry for Spice. And one of the things they're doing is, developing sort of fitting tools. I wanted to ask what overlaps there might be. The impression I got from what Ed's working on is that they're trying to develop in a way that is not like specific to Spice. So yeah, the question is, how much overlap, either technical or philosophical, is between what you guys are doing here in IcePack and what Terry and Ed are trying to achieve for Spice?
Probably pretty significant overlap. Our first goal, of course, was getting something that works for ICE data and in a fast and repeatable way. We had a secondary goal of kind of a continuity of results. So all the existing ICE analysis had been done in IDL previously using MPFit. So then it was a natural choice for us to kind of use the MPFit on the Python side because it gives similar results. We looked into using some of the other fitting tools, but they either didn't have fixed parameters like we need, or was very slow, or gave actually worse fits that didn't really match the previous results.
Okay, so yeah, the follow-up then is, firstly, I'm very aware that there are other pressures and priorities when it comes to specific instruments. I guess I was just wondering if you guys in IcePack are aware of what's being done for Spice and vice versa. And I guess just the question is, might it be beneficial for you guys to sort of talk in the future, depending on like how your development goes? Is there ways which you can help each other out, and then maybe just be more sort of friendly for other people who are trying to do the same type of fitting, but maybe not specifically with ICE or Spice?
But yeah, certainly we'd love to collaborate with people.
Yeah, and we have talked to you guys in the past and gotten some ideas, but we basically were in a situation where we needed something that worked for Spice, and so we thought we'd go ahead.
Yeah,
but yes,
and
we
I
should
think
keep talking.
this is exactly what this group. So I will say too, and I think I had put this in the email that went out to everyone as an invitation to this meeting, but that I would like this sort of instrument working group for this to be the kind of first, and this was the original idea behind this, or the original instrument working group several years ago, is that that we would meet periodically. How regular that would be, we can decide, but that we would meet sort of periodically to take stock of overlapping needs like spectral fitting, to see, okay, where we're at, like, are we making progress on, or to what extent, what overlapping needs do we have, and how much progress are we making on sort of having sort of a common piece of code that we're all working from and sort of specializing for ICE, for Spice, and maybe there are cases where that's not the case. But that probably at the end of this meeting, I would like for us to kind of have an idea of what sort of cadence we wanted to meet, and maybe what's the next that we would want to cover.
Yeah, but also IcePack is not only about the fitting, it's also about the level 1 IceFiles archive. And this is something that is necessary for ICE, but not for Spice. So it's there are two things in IcePack. It seems to be quite specific to ICE.
Oh yeah, to be clear, my comment was not suggesting that ICE pack should be thrown away and only the Spice stuff should be used, or vice versa. It was simply suggesting maybe there are ways where things can be done more efficiently with less effort and less resources if things are pooled in that way. But I certainly appreciate that, especially at the beginning of projects and stuff. Often it is better to do things less efficiently or duplicate stuff in the interest of speed. Like I appreciate that. That is a real concern, and with real consequences in some cases.
I think also that what Michael was saying about working on interfaces with Chianti Pi and stuff, if that could be done in a general way, that could be pretty interesting for well, many kinds of instruments. But.
Yeah, certainly the need for atomic data is like spans many instruments, whether that's an interface to Chianti or other resources. Yeah.
Yeah, weren't you working on some sort of atomic database code, Will?
Yes. Yeah, and probably that's all I'll say about that right now for now. But yeah, and I actually do have a little bit of money to work on that. And it is similar to Chianti Pi in a lot of ways. With the idea that it's sort of more interoperable with like the AstroPi, SunPy ecosystem. So actually, yeah, we should. I didn't realize that. I guess you guys were thinking about this interface, so we should probably talk about that at some point as well. Okay.
Sorry, I just have a quick question. Is the search functionality of IcePack, is that like a FIDO-based thing, or is it your own specific search stuff?
So at the moment, it's a full GUI where you can search based on a ton of different parameters from the official ICE catalog of observations. Will did help us write. Well, Will wrote. I didn't do any work. Will did it. He wrote a FIDO client that's just based on the time periods that I still need to incorporate into the package. And I was just discussing with Will a couple weeks ago about how to write a more advanced FIDO client that actually has access to like the wavelength information from the catalog.
Okay, cool. Thanks.
Yeah. So yeah, Shane, for some context, like the ICE data is just in like a directory tree on the NRO website. So my quick like PR of an ICE pack client is just a scraper client. But there's a lot of, and the thing that Micah's GUI uses, it hits the ICE catalog, which is a SQLite store in SSW. And so the challenge is to figure out how to use all like the rich metadata that's in the ICE catalog to actually do those searches rather than just the time label, which is what's provided in the file tree.
Okay, cool. Thanks.
Yeah.
That sounds like something that could be interesting to Spice as well.
This is a question for both Terry and Eric. What is the primary source for the SPICE data? Is that the SOAR?
Yes.
Okay, so we, as part of it lives under the SunPy project right now, but there is a SunPy SOAR client, and there's been.
Yes.
Yeah.
I know that. Yes.
Yeah. Okay. So right now, if the data is on the SOAR, that FIDO interface should already be there. Like that should just work.
Okay, Eric, do you know how much, maybe we should talk about this offline, but how much information about our files is actually accessible that way?
You mean which metadata we can query?
That's right.
Either with the SOAR or with SunPy SOAR. I'm not sure because the SOAR form, the web form is quite limited. Then with the API, we can access to more metadata, but I'm not sure.
Okay, that's something we should look into.
Yeah. Maybe someone who has developed SunPy SOAR, David, knows about what kind of metadata can be queried on SOAR?
I think the answer is none at the moment. Basically on SOAR, all you can do is search for a certain data product, and then get the files that match that data product between a given time. I don't think you can search. I don't think there's
We need to check if it is what is available through the API. There are different tables.
Yeah, definitely should check. But at the moment, you can only search by dataset ID and time.
Okay. Yeah.
I think for definitely for the remote sensing instruments on Solar Orbiter, we're gonna want to do something so people can have some way of at least searching things by the observing program or the object being looked at. Because it's we're already running into problems with people trying to find particular kinds of data and not, and you know, you can't really figure out easily, like when we're looking at active regions and or something like that, or coronal holes.
Yeah, I think that the SOAR team have gotten this request for a bunch of people, so I think that they are looking at ways that they could expand what you can query, because you know that observation ID stuff and the target stuff is all in the FITS/CDF headers, which they index. So I think that is on their list of things to do.
So
yeah, and maybe hooking it up with some sort of event list would be helpful too.
This is a question for, I guess, all of the Solar Orbiter people, and maybe especially David. Is this a limitation of the TAP client, right? Not just the SunPy client.
I think this is a limitation of the
TAP API,
the server itself.
Okay.
TAP gives access to the tables, to some tables, but we have to see what columns are in these tables.
Can I ask another question regarding IcePack? I think in one of the slides it mentioned that the data was put into ND cubes. Is that like raw, like regular ND cubes, or is that an object that inherits ND cube and builds something like ice specific?
Yes, so it's an ice cube, which is a subclass of ND cube.
Okay.
We've got a couple ice-specific tools there, and I guess one of the most significant challenges we had was creating the FITS files on the backside, which requires us to do some extra tracking of the coordinate frame when the ND cube is sliced.
Really? What wasn't sufficient for the way that ND Cube natively does that? Actually, maybe this is actually too specific a conversation for here, but or is it okay?
I would probably consider that a bug in ND Cube from your description. Like,
yeah.
So I think actually it's part of it's the slicing of the WCS array. And depending on how you slice it, it loses some coordinate information. So you can't create a FITS header from the WCS array.
This definitely sounds, if that's...
So you mean you load a thing, slice it, and then want to save it back to FIT?
When you load it up, you slice it in certain ways. When you then try to save it to a FITS file, you're literally missing some of the coordinate information to create a valid FITS header.
Okay. Yeah. Saving an arbitrary ND cube back to FITS is not something that we've figured out all the way yet. So yeah, that's fine. Okay.
So yeah, last follow-up question. Does that mean you're re-engineering the slicing infrastructure, or is it more that you've engineered some method to save it back to a FITS?
So we've overridden the slicing using the example of the ND array. They had some examples on how to slice additional arrays and such. So it's just in there that we do some additional logic to keep track of the information we need. And then we're not actually saving the ND array to a file. It's later when we produce the 2D FITS files of the output parameters. That's when we save just that 2D array to a FITS file for loading into a SunPy map.
I see. So yeah, I unfortunately came into this discussion a little bit late, so I might have missed this. Is the IcePack code like publicly available on GitHub? Like I can take a look and.
we released it a year and a half ago. Finally got it up on pip, so you can just pip install IcePack. But there's
Right, but
there's a GitHub
if I go to
repo and
GitHub-
docs and everything.
Yeah. Perfect. Yeah, I'd love to take a look at that source code just to understand that a little bit better.
I apologize. It's very hacky, and we actually have backwards compatibility with NDCube 1.0, which we probably should remove. But we wrote it back before the 2.0 switch, so we had some users that were straddling the line.
Sure, I suppose that makes sense.
Congratulations on figuring out a way to support both at once.
Yeah.
That's no small technical achievement.
I'm shocked.
It's very hacky.
I'm not sure there isn't. I can't imagine a non-hacky way of doing it.
Yeah, I was going to say, I don't want to. God, yeah.
Okay, let's see. I guess, CG, did you want to say anything about like EOPSA, or I know you mentioned the like SunCasa pipeline?
I have a couple of slides.
Yeah, that'd be great.
My screen.
Well, that's happening. It's US Naval Research Laboratory / SunPy. Is that / IcePack? Yeah. Okay.
Yes, that is correct.
Great.
Can you see my screen?
Yep.
Yeah.
Okay, so yeah, I'm going to talk about some radio package. So the package is mainly for the user expanded opens value array. It is a sort of dedicated 13 elements radio interferometer. It provides broadband imaging spectroscopy in a frequency range from 1 to 18 gigahertz at 1 second cadence. It can provide a spatially and temporally soft microwave spectra when a flare is present. So it's a useful tool to study flares, and it is a pace founder for the next generation of radio telescope for the sun. So we developed some package called SunCasa to process the complex visibility data of radio interferometer from radio interferometer. They usually have 4-dimension polarizations. A baseline is a pair of antenna. So, for example, we have 13 antennas, so we will have more than 100 baselines. So for for array with 100 antenna elements, there will be more than 1,000. A few thousand. It will has around 1,000 baselines, and the frequencies. We have more than 1,000 frequency channels, and time. So it so radio interferometer create a large amount of data. Consider those 4 dimensions and a lot of frequencies and time integration. We have a product called DSpec to slice a dynamic spectrum from the original visibility data to reduce the data from to the frequency and time dimension. That part of we also have another package called KiloPlot, which to convert the visibility data into imaging results. So we can generate radio image for each of the frequency and for each of the time integration. So converted to frequency, time and space dimension. So here's a quick look, a summary plot from Quick Look showing a dynamic spectrum and the image, radio image and multiple frequencies from the time and frequency that from a specific time and frequency range. So the current status of this is many of the plotting of visualization code is based on SunPy, so we can nicely place image from different instruments into one plot. But currently we are relying on SunPy 2 because one of the main package that we are using is called Casa. It is based on Python 3.6. They only release a new package which based on Python 3.8, but it was very recent update. But now our code is based on 3.6 and SunPy. The SunPy works on 3.6 is I believe is SunPy 2. And if we upgrade to SunPy 4 or SunPy 3, I believe our code will broke. So we need to do some work on that. And the dispatch we also and the radio spectra team is also working on a class for user data called user spectrogram. So it is still in progress.
Just
and
out
we
of
have
curiosity, what like how much of Casa are you, like Casa itself, are you relying on?
Basically a lot, because to generate those image, we need Casa. We need a clean procedure to generate image, and also because the feasibility data itself is stored as Casa data format, so-called measurement sets.
So
to get
the Casa data thing was what I was going to get at, because within the last year, there's now a pure Python implementation of reading Casa data formats, including the full measurement sets into Dask tables and Dask arrays.
Oh, that's great.
Pure Python, no Casa required. I'll drop the link in the chat for you.
Yeah, thank you very much. Yeah, that's really a pain for us, because Casa package, they only have package available for Mac and Linux, but not for Windows. So sorry, Windows users. Yeah, if that's the case, we can.
What is the sticking point for not building for Windows? Is it
I don't know.
Okay.
I don't know.
Are you in the Element chat for the meeting? I've just put the link in there, but if you're not there, I can drop it in the Jitsi as well if you want.
Thank you very much. I can see the chat afterwards.
Okay, cool.
Okay. Next one is we are also developing some feeding code for gyro synchrotron emission from solar flare. So previously we have an IDL version, which is developed by Jello Nita and Gregory Frischman in NJIT. And yeah, we like to have a Python version of that. So we, because all our imaging pipeline are based on Python, so it is straightforward to just feed the imaging results to another Python code, to another Python package. So it is GUI-based interface. It can again use SunPy to make those plots, and it can interactively select the regions, extract the radio spectra, and feed the spectra with gyro synchrotron model. Yeah, we are still working on that. It is still in a very preliminary status. Okay, that's all I want to introduce about radio stuff from user.
Is the PyGS fit, is the fitting capability also accessible outside of the GUI, or is it all?
Yeah, it
sort
is
of
accessible outside the
Okay.
GUI. It is command line based, so whatever comes from those GUI is converted to a command, and then it is
I see, okay.
accessible outside. Yeah.
Okay, great.
Pierce?
Hey, sorry. That's really interesting stuff, CJ. How specific is? I know you said it's only for EALSA data, but like, how only for EALSA data? Like, if I just gave it a low fire measurement set or something, what happens? Do you know, or are there plans to make this more general for other radio interferometers?
Yeah. So I mentioned it was developed for user, but actually in the beginning we are working on the radio data from the very large array. So many of the mainstream radio telescope operated by United States is using the CASA as the processing software. So as long as the data format of the interferometry data is in the CASA format, presumably we are able to use it. But now the only solar dedicated array is in the US is the expanded Owens Valley array. So there's not too much data available. But I'm aware that the LoFa data, they are also perhaps stored in measurement set format.
They are, yeah.
So
Yeah.
yeah. So presumably it is able to process that. The code we wrote is pretty general. So we should have no restriction on instrument.
So I see one of your last bullet point is development of an EOXA spectrogram in radio spectra. I mean, could this be, how far away would this be from just being able to operate on a spectrogram class, whether that's an EOXA spectrogram or a LoFar spectrogram?
Yeah, I kind of lost track on this. I noticed user spectrogram is written in the document of radio spectra, but
Yeah.
because the spectra is pretty general, it's just a feeds file. I recall that the radio spectra can read user data.
Yeah, it can.
But yeah. But it would be nice to have an API or something to just fetch user data from our website just by providing a time. That would be great. But now I think it's only works on existed feeds file that has been downloaded in your local machine.
Yeah, maybe I'll just quickly comment there. Yeah, so there's a EOXA client, and there's also a FIDO client to search for the pre-made EOXA FITS files. I think that the only sticking issue was that there's just a particular bit of data missing in the FITS files for us, for me to figure out a way to make the plots look the exact same as what you guys have on your website. So I think it's just a really small technical issue to close that.
I see. Yeah. So if you need any help, I can help.
Yeah,
Please
I
do
look.
not hesitate to let me know.
I look at the issue again and maybe ping you on GitHub.
Yeah. Thank you.
I guess there's any more questions about the OPSA stuff. Marcus, did you want to say something about Punch?
Yeah, I have some slides.
All right, great.
And I should be able to share them, hopefully. Oh, I didn't mean to add a slide.
Well, it's happening. Micah, are you on the coordination, the element SunPy coordination meeting room?
I haven't joined it yet, but I can view it.
Are you on the regular? Do you have access to like the general SunPy element, or when you say joined it, you mean the room, or you haven't joined element?
I haven't joined an element. I'm sorry.
I see. Okay.
But I've been meaning to.
So if you post it there, that should be able to see.
Okay. Okay.
Okay, so I'm Marcus, and this is Punch. So the polarimeter unify the corona and heliosphere. It's going to be a constellation of 4 small little satellites. It's currently in development, and we have launch scheduled in, I don't remember the exact number, but like 950 days. So we've got a while to go.
Not that anyone's counting.
We actually have a counter in the office that like ticks down every minute. It's kind of mental. But Punch will produce images in white light, polarized white light, from 6 to 180 solar radii for solar wind studies. That's interesting. Okay, there it goes. I'll skip a lot of the details here, but this is an older version, an older image that shows the Punch pipeline. So to just simplify it, we start with raw camera frames. We have to do some instrument-specific calibration, despiking and destreaking and stray light subtraction. But we figure out the WCS and we align things. And then after that, we have a bunch of images and different polarizations for both the wide field imagers, which there are 3 of those, and 1 narrow field imager in all its polarizations. And so we have to do polarization resolution so that they're all in the same reference frame. We quality mark our frames. We build mosaics, so we take all these different frames and make them into a trefoil. And then we do the fun part of subtracting the F corona and the star field to create these beautiful background subtracted mosaics that will hopefully be used by lots of people. So these are our main level 3 products. There are full resolution images in B and PB brightness and polarized brightness and clear for each of the instruments every 4 minutes for NIFI. And then we make a clear mosaic and a PB and B mosaic every 4 minutes. And we also have these low noise mosaics and low noise NIFI images that are on a slightly longer cadence. And then there's this wind speed plot, which I'm not sure what we're doing about that yet, but we'll find out.
Can I ask, what are those strangely shaped white cutouts?
So they're kind of clear if you follow this, but there's some kind of quality marked section.
Okay. It's just like the warping of that section as it's reprojected. And
so even before reprojection, if there was a planet or something that we needed to quality mark as not good, and then they do get warped definitely in the reprojections.
Okay.
So this is the main idea, that we're building a pipeline called Punch Bowl that is managed using a workflow manager called Prefect. So the goal is that we'll have a pipeline that scientists can use that doesn't require any of the overhead for automation. And we keep that completely separate in a package called Punch Pipe, which is private. And I won't go through this figure, but it's a fun figure to look at since we don't have a ton of time. This is the main part that I wanted to get at. That SunPy is going to be really helpful to us, and AstroPy. And since we're in developer right now, we can change a lot of our designs, I think, and our implementations. But we're using IndieCube and the core data handler in maybe a less than desirable way. We'll find out. That polarization resolution from earlier is based on a paper that we published in the past year. And so we have code now for that does the polarization resolution, and it's universal, so it'll work for any mission, stereo, whatever you want, any future mission. So we'd like to publish that as a separate affiliated package for SunPy. And then the Punch Bowl would like to affiliate that at some point, if that's desirable. And And then there's some questions here. So, we do image mosaicing using AstroPy reproject, and some Swery people have contributed back to hopefully make that faster for us.
Yeah, one day we might merge those PRs.
Yeah.
That is actually just one of the things that I've been tottering along with today while I've been listening. Finally getting those merged.
So I think we wanted to develop a strong relationship with SunPy as we go to make things as easy and beneficial for the community as possible. So there are some questions here, like, would you like to see our headers before we finalize them? Because I know that's come up several times this week.
I will turn that question round. You may or may not like me to see your headers before you finalize them.
You might not like the answers, but it might be interesting to identify issues.
No,
you guys are thinking about.
A more serious answer is yes. It's a good idea.
And then some other logistics questions, which you probably already read while I was talking. And anything else that we can do.
Can I ask for, you're saying you're using reproject to put the images together. How are you handling the different observer locations for the 4 spacecraft?
Should have been at lunch, Albert.
We don't have everything worked out yet. But the idea is, I think we use the observer location and reproject all using that information to a common frame, which is used for all of the punch mosaics. And then those punch mosaics have an observer location of Earth, because we don't want to carry the metadata of all of the different satellites. Does that
right? We have a running problem or running challenge of what assumption do we use to reproject the surfaces onto. So there's this thing in SunPy for this spherical screen, but there's other things that people might want. I'm just wondering what your current conception is for how you actually resolve the 3D position of things that you're seeing in these mosaics.
You may want to make in the process of doing that is some. Thank you, live streaming lady. Is something that we might want, would be a good contribution to SunPy core, and working with Albert to get it in the coordinates stack and stuff.
Okay. Yeah.
Your fourth point about the affiliated package liaison, I think, is a good one.
Yeah, I'm not sure what we can do at the moment.
Volunteer to big. No, that's not right.
I mean, yeah, I think, I don't know. I don't have a clear answer to that.
I mean, well, no, I do. I do have an answer, right? In the absence of somebody in one of those roles, that role is by necessity taken by us as the lead developer.
Well, and
so
yeah, one could also argue in the instrument affiliate, the instrument case for the affiliated package liaison, like that is nominally what I am paid to do through the Ostoffel waffle, whatever we're calling it, funding. So maybe we should make that a bit more explicit on the website. Maybe I should just put my name on there. Maybe that would make it easier.
Well, my plan is to just come to your chats and your meetings and just annoy you until we get whatever we need to do.
This is the way.
That's great. Yes.
In practice, that will work almost all the time just as well.
Especially if you ask questions about coordinates and reprojection. Dan, do you have an answer to or opinions on this second to last one about an object containing a dictionary of indie cubes?
Where am I looking? Sorry, on the screen. Right,
I'm
right.
looking at my screen, yeah.
Yeah, you're looking at yours. Okay.
We were talking about this a little bit.
Yeah.
Maybe not sure it's the most elegant solution, and
no, it's a completely understandable solution. I don't think there's anything wrong with it. But maybe, so for those online who weren't with us yesterday, we started a discussion about a metadata object, which is, at least in the current conception, subclass from a dictionary. So again, it's not very far away from what you're talking about, but that can do a number of things and support a sort of more user-friendly or standardized metadata API or framework. So I think if you already have as a dictionary, having a slightly more powerful dictionary-like object, like a metadata object, presumably isn't too far away from like, you know, what you already have. I think then you get into this discussion we were having yesterday about it would be nice to standardize names of pieces of metadata that are common throughout solar physics, like the observatory, you know, these things that may or may not be called commonly in bits headers or other places. So, I mean, I have ideas, but you know, this is still something that we haven't agreed exactly on the API for yet. So, but I encourage you, if you're thinking about that and you're thinking about metadata, then to be part of that conversation and help us shape that. And that goes for anybody else on the call from any other instruments. If you're thinking about how we should store our metadata in an ND cube-like object, you know, be part of that conversation and help us sort of try and define what those metadata labels or names are in Python. Because users shouldn't have to only know what bits keys are. Like ideally, a typical user should be able to move away and do something. Yeah, Steve agrees we need a metadata object, yeah.
Well, like,
so we're working on that.
A dictionary of ND cube objects.
It's slightly different. We were talking about
both, yeah, but like a dictionary of ND cube objects is a thing that exists.
ND collection.
ND collection.
That's ND collection. Yeah, that exists.
Didn't use ND collection because of the aligned axes or something. We didn't.
You don't have to use aligned axes. It's totally optional to use aligned axes.
I think there's something we should talk about. The offline probably.
Yes.
A side effect that was not working for us or something.
I'd love to hear about that.
Yeah.
We love bugs.
Yeah. Well, we love not being ignorant. Yeah. So if you can give us a chance to be less ignorant, that's great. Okay. Sorry. Yeah, I misread that point.
Well, both were good points.
Yeah.
Any other comments about punch stuff? Steve, I saw you just got on. Would you like to talk about Hermes?
Can you guys hear me?
Yes.
Sure. Let's see, let me try to dig up some slides. That would be helpful as visual aids.
And when you say we need a metadata object, do you mean we SunPy or we Hermes?
Everyone does. We all do. The universe does.
Humanity needs a metadata object in Python.
Marcus, so I wrote some notes, but they're kind of all over the place. So you want to just have a look and make sure I didn't say anything really wrong.
Or missed something.
Or missed something, probably
Yeah.
more importantly. Yeah.
Just as important.
Yeah. There's no spell check, I think. So.
Also, Michael, while Steve is doing that, I don't know if you can see the coordination meeting room, but I left a question in there for you. I don't know how you can best answer it, but just to let you know.
Yes, I just saw that. Thank you.
Great.
Just
Great.
print.
Sounds like Steve disappeared.
Which is a NASA program to go back to the moon. And one component.
You dropped out in the middle there, Steve.
Can you start again?
Yeah.
Oh. All right. Am I cutting up or something? What's the problem?
Like, I don't know, as far as we can see, you disconnected from the call.
Really?
Yeah.
I'm at work and everything. Okay.
But we didn't hear you start off. Like we didn't hear Hermes is. We didn't even hear that.
Or you should not share your screen if you think you are.
Yeah.
Okay. Okay. So Hermes is a payload that's going to fly on the Lunar Gateway. Lunar Gateway is part of the Artemis program, which is the NASA program to return to the moon. You may have heard that Artemis 1 has a launch probably Monday. They'll be launching at SLS. And the Lunar Gateway, okay, let me share my screen, is kind of an ISS for the moon and the Artemis program. Where can I share my screen? Too many windows. Share the screen.
We can see that here at Dias now. Your screen, I mean.
You can see this?
Yes. Hermes Science Operations Center. What we did just a second ago.
Yeah.
Yep.
Here we go. Okay. Okay. So what you're looking at is the Lunar Gateway. It will have a number of different modules, just like the ISS. And the idea is that astronauts will go to the gateway first, will dock with it, and then they'll land. They'll go down to the moon from here. That's the current thinking anyway. As part of it, there are opportunities to fly instruments. Just like on the ISS, there are places where external payloads can be added. And so Hermes is, this is not really the best. Too much detail.
Too much data.
Too much data.
Too much. Oh, here we go. Yeah, this one should be better. Open. I apologize for being super prepared for this. Where's the? Here we go. Okay. Can you guys can see this?
Yeah.
Yep.
Okay. So same thing here. You can see the Lunar Gateway, though, with fewer of the modules. So basically, they're going to launch 2 of the modules together. There's place on the side of it for 2 science payloads, one of which is Hermes. There's another one from ESA that's going to be attached as well. And the point of this experiment is to basically measure particles and fields for kind of space weather and science. So you can sort of see where we are here. The launch this is kind of far in the future. The launch is, well, it was previously November 2024, but it's unlikely to be then. It probably has been pushed to spring of 2025. And then there's a 1-year coast phase to get to the moon. So this is really only going to be happening, producing data in 2026 or so. So we have quite a lot of time. This is a directed mission, standard 2 years, kind of nominal science mission. We're going to be examining the interplanetary medium, the solar wind, but also terrestrial magnetotail. We'll be flying through that every once in a while. It goes into this kind of interesting orbit near the moon, which I may have a slide about. And it's kind of a pathfinder for future kind of space weather payloads. So it's trying to be both science, but also kind of operational. Yeah, and then there are also these kind of IDS teams. So there's a whole other group of people associated with this mission. Yeah, so here's sort of where we'll be. Here are the science goals. This is all kind of probably more detail. Here's the kind of the orbit, the blue orbit that we'll be in. So we get quite far away from the actual moon. Yeah, so here are the 4 instruments that we have on this payload. Another electron-proton telescope that's looking at high energy electrons and protons. A magnetometer, which consists of actually a number of sensors, 1 flux gate and then 2 PNI sensors. So they're going to use the PNI sensors to remove the background. You can see the payload to the right there. There's a solar probe analyzer for ions. This is actually the SPAN-I, which is already flying on solar probe. And then we have electrostatic analyzer. So these are all, space physics instruments here. So you might wonder, what is the relationship to SunPy? And primarily the relationship is me. Well, I'm trying to use a lot of the all the development and stuff that is in SunPy, and so I started developing the Python packages for each of these instruments, starting with the SunPy affiliated package template. Now I know the original template is a bit out of date, so I took that and made a number of updates to it, and I'll show you that in a little bit. So I mean, the main thing is there are 4 instruments, so we have 4 packages, and we have 5 packages. And so managing all the packages is a task that takes time, and some help with that would be good. Let's see if I should just jump to, let me just jump to what we actually have. Oh, another thing that's relevant here is that we are running with the new heliophysics data management plan. So I don't know if this was discussed, but there was a big policy document that came out from NASA headquarters called SPD 41, which basically was all about open science, reproducible science, and created requirements that basically all software that is funded and developed for NASA missions become open source. And then, so that's a high level document, and then each of the science areas have to publish their own documents, kind of reacting to that and making it clear for how that's going to be implemented. So heliophysics put out a policy document for heliophysics specifically that kind of went through that. And one of the main things is that all of our processing code needs to be open source. So these Python packages are both going to include the data analysis tools, but also the calibration code. So we have to make public the code that lets you go from level 1 to higher levels of data. So we have to enable users to take the lower level data and calibrate it up to the higher level data. So what that means in practice is that essentially these Python packages are both being made public, but also that's what we are using to process the data. And we are going to be doing all our processing on the cloud, on AWS. So that brings to bear a few additional requirements to the packages such that we can run them Lambda functions on AWS. Yeah, I think that's all that's relevant to this discussion.
Steve, we kind of had a chat earlier about, data containers that would be similar across instruments, and some of the kind of in situ measurements that are on, say, the solar wind analyzer and solar orbiter or on PSP. Like, I could imagine there's probably a huge overlap here, and maybe we could talk about what kind of data products these would look like, and what kind of is already available within SunPy or needs to be developed.
Yes, that would be really great to talk about. Right now, a lot of these data sets are essentially time series. So if you go back, two of the instruments are fairly simple in terms of the data they provide. So Merit and Nemesis are basically just time series data. Nemesis is basically magnetic field in a specific coordinate system, X, Y, Z as a function of time. Merit is basically time series for these fluxes in different energy bands. So I forget the exact number of energy bands, but not very many. So, pretty simple time series. SpanI and EEA are a little bit more complicated. And that's where I think time series is not quite appropriate. And that's where we kind of get into the more difficult aspects of space physics data. So they produce, essentially spectra as a function of time. So multidimensional data. Well, even more, EEA produces spectra as a function of angle, as a function of time. All right, so let me go to GitHub and show you guys what's already up there. So we've been doing everything online on GitHub, so it's all open development. And that's on purpose. So you can follow along with what's there. So here's the Hermes sock page on GitHub. Is this too small? Is this good?
Yeah.
Okay. So just as an aside, we've been trying to put all kinds of other things out public. So we have the project data management plan on GitHub, as well as the PLRA, which is kind of the level 1 requirements, if anybody's interested in reading that stuff. And then you'll notice here that we have the individual packages as well as Hermes Core. So Hermes Core is the package that holds common functionality for the packages. So all of these depend on Hermes Core. And all of these use the package template, the affiliate package template, well, a modified version to it. So there isn't much in there. Yeah, is there a question?
Yeah, I was just going to ask, so I mean, outside of the affiliated package template, I don't know, maybe this is hard to say since you don't have data yet, but to what extent are you using SunPy or some the sponsored packages like NDCube?
So NDCube is unfortunately, well, okay, so we're still looking into data classes. And so for the more complex instruments, we're still kind of thinking about what we would use there. The problem with NDCube is space physics does not use WCS at all.
Yeah, if you don't have a WCS.
Yeah, I know you can create one.
Yeah, but doing that is not necessarily a good idea. It's not something I would recommend. If you only have tabular coordinate information, go use X-ray. NDCube is not the right tool for the job.
If we're talking about interoperability with sort of more in situ data or kind of heliophysics data sets who may not have a WCS, and all of our, well, I guess except for time series, and most of our data structures are based around the idea that you have a WCS. Like, does that present like any friction between like the tools that we have and the data that people want to bring together?
Yeah, unfortunately, I think it does.
Tomorrow's.
What are the issues with creating a WCS, the velocity distribution function?
I'm not saying you can't. I'm just questioning the value of doing so. What does WCS do?
Why are you question interoperability?
But you could go the other way equally, right?
Yeah, like
you could say we should like just have like various tables and arrays. Like we should just like get pixel to world for all pixels, put an array and then stick it in an X array. Why should people with who use X-ray come to ND cube and not the other way around?
Because WCS has support for tabular coordinates, but not for like.
Yeah, but the opposite
isn't true.
I guess that's fair. Jack?
Yeah.
Yeah, I've got a question for Stephen. Stephen, have you decided on a data format yet, like CDF, for example?
Yeah, we're required to use CDF.
Okay. So
yeah, that's like hard coded now in that document. I mean, I think it already was, but yeah, space physics data must use CDF, just like solar physics data must use FITS.
Lies.
Sorry. Why?
Maybe I'm just an optimist.
No, he said lies.
Oh, lies. Well, no, I'm not.
One day we will move these solar physicists away from their FITS files. One day.
So I'm actually pretty annoyed with that because being new to, I'm learning, right? My background is solar, and I must say that CDF files are quite old-fashioned. There's a lot of cruft in CDF that are caused by, old-fashioned limitations such as, space limitations of languages, and they've carried those along. FITS, you don't see that as much, fortunately.
So SPD 41 codifies like CDF and FITS as the de facto.
No, the heliophysics data management plan does.
Oh,
SPD 41 is too broad.
Okay, all right.
Yeah.
So Stephen, if you had your choice, what would you choose?
Maybe HDF.
Choices.
Well, we've got no WCS.
Yeah, it's a bad archive format though.
So we're actually a little bit past the coffee break now. I don't know how much more you had. If you had some stuff that when we come back, we could finish this, or if you just wanted to wrap up.
No, what I want to do is kind of show you guys what I did with the container. Sorry, not with the container, with the template, because I think these changes should be used for the new template. And I'd like to advocate that somebody maintain a set of templates that, including a template that does not necessarily depend on SunPy. We can argue that.
You mean SunPy core?
Yeah, SunPy core.
No,
sorry.
No, I mean none. Yeah, even the SunPy package template won't enforce a dependency on SunPy because we have packages that we maintain that don't use SunPy.
Yeah, but the template's bad, Steve. We told you.
Yeah. Well, okay. Why don't you guys take your coffee break and we can continue the conversation?
So those problems will be fixed with the template. You should form every problem you have, send it to Stuart, and he will fix it, guaranteed.
Yeah, it will. On that tasty grant money.
All right. Yeah, let's go ahead and break, and then we can come back and we can and see that.
How many more of these? How many more people do we have who have instruments or whatever they want to talk about?
So yeah, that's good. So is there anyone who is on that hasn't, or also in the room, I guess, that would like to talk about like their particular instrument that they're representing that who hasn't spoken yet? Stuart does.
I'd maybe say a word or two about sticks and ILOFAR.
Okay.
Do you want me to talk about SSD?
Sure. Yeah.
I just made your files work, so yeah.
Okay. Yeah. Let's maybe when we come back, let's do those, and then
what was the post coffee plan?
Because Steve was going to talk about the package.
Oh, the package template.
I don't follow talking about the package.
I was gonna say maybe the package template stuff fits better somewhere else. Like,
I think issues with the package template is not. It's something we need to provide, but it's not. It's something that is going to be fixed. I don't know.
Well, I think what I'd like to suggest is that there be an instrument-specific package template, because an instrument package has certain requirements that just a data analysis package does not.
Yeah.
I mean, I'm interested. I would be interested in a list of those requirements, both from you and other people on the call. That would be interesting. I mean,
could we come back to that maybe at the end, Steve? Like if in the last like 20-ish minutes, and I think we've been going to like 5:30 most days as well. So I mean, we can go a little bit later, unless you have a hard cutoff.
What time would that be, or how many hours from now?
12:30.
Your time.
I'll be in the SunPy dev meeting.
it's not in the calendar. It was cancelled.
Well.
Oh, okay. No, that's fine.
You could go ahead and log into sunpy.org.
That's fine though. I only have 30 minutes, so 12:30 to 1 is what I can do.
What about 12 to 12:30?
That's fine. I have from 12 to 1 open, so.
Oh, perfect. Gotcha. All right. So let's do that, and then when we come back, we'll go through. I guess what we say.
Decist, sticks.
Decist, Shane. Tiago. Okay.
Tiago as well. Okay.
Yeah. All right. We'll see you all in about 20-25 minutes.
Okay, great.
Folks in the room. No, this is a local organizing thing. So yeah, this is purely for the folks in the room.
11 Eastern.
Yeah, I can't make that time, unfortunately.
Okay. Shane, do you want to talk about sticks?
Sorry, there's someone making loads of noise, so maybe come back to me outside.
Yeah, sure.
Who is
Stuart.
Stuart, you want to talk about Decist?
Talk about Decist, okay. Let me actually drink any of my coffee. Okay, Decist is, for those who don't know, a 4-meter ground-based telescope on the top of Honolulu in Hawaii. It has 5 planned first light instruments. VBI, which is actually 2 different instruments, one in the red ring, one in the blue ring, which is a broadband imager. It has VISP, which is a scanning slit spectrograph that also does polarization, spectral perimetry. It has CryoNUSP, which is a similar slit scanning spectrograph, but in the near infrared. I think that one's primarily designed to look at the corona, and it has VTF, which will be a Fabry Pro, again doing spectral perimetry narrowband. and also a white band imager. At the current estimates are once all 5 instruments are up and running and the facility's fully operational, it'll be generating up to about 12 terabytes a day of data. I work for the data center in Boulder a large fraction of my time and focus on what happens to the data in the data center after it has been calibrated. I know a bit about the calibration code and more about what happens afterwards. All our calibration codes are publicly accessible on Bitbucket, written in Python. Almost all of the data center is written in Python. There are a couple of small background things that I think are in Java, although they're on the chopping block for a rewrite. One of the major challenges with the DKIST data is it's being taken, calibrated, and made available to users with what is probably simplestly described as 1 frame per FITS file of very large data sets. So for a large spectropyramic data set with lots of wavelength and spatial positions, you could end up with potentially hundreds of thousands of FITS files per data set. The user tools I've written based on NDCube, and in fact, have all of my work on NDCube 2.0 was done before the data center, like on their time. And so we're using Dask to provide a single array view into the data in lots of FITS files, and GWCS to attempt to represent the world coordinates of that reconstructed array. All of this is built on NDCube and will be, as well as the collection of FITS files, all that have complete and detailed FITS headers with WCS information. We'll also be shipping an ASDIF file, which stands for Advanced Scientific Data Format, which is a new ish format that's been developed by Space Telescope Science Instrument, primarily motivated by the needs of JWST. We'll be shipping all of the metadata for a data set in a single ASDIF file. So that includes how to stitch the data arrays in the FITS files together into a single Dask array, the GWCS object for the world coordinates for that whole thing, the computed like metadata inventory record that you can search against, and a table of all of the FITS files for all of the files that make up that data set. So you'll be able to download all of the metadata for a data set. In fact, even if the data set is in barcode, you'll be able to read all of the FITS headers. And then you can decide based on the metadata in that file if and what parts of that data set you actually want the data for and transfer it, like wherever you want to put it. There's many interesting questions. I won't ramble on too much about the technical fun parts of doing that. If you have questions, then I'm happy to answer them. But the ASDIF approach of having all of the metadata available in a single place has already come in very handy for us to do. Like we've test calibrated, I think maybe about 100,000 files total at this point. And in about 30 seconds, I got all of the ASDIF files, loaded every single one of those FITS headers, and determined that one particular column in all the tables was the same for everything. Like, it was just load all tables for all files. Oh yeah, every single file that sent us has this value in the FITS header. So it's definitely an interesting side. I'm also hopefully planning on working on like making use of the fact that we built a Dask array. For those of you who don't know, Dask is a I was going to say distributed computing, but that's not really right, is it? It's like parallel computing, or a library for bigger than memory, bigger than compute data. So that's like you need more CPU or more memory than your one laptop has, or you want to do things in parallel. Dask provides lots of really cool Python tools for dealing with big data in whatever form that may take. There's lots of interesting optimizations and improvements that can be done within the Astro and Solar Sphere for using Dask for that kind of data. And
that's not
I mean, some of that is going to be done with the Will's work on the SunPy grant, and I'm hoping to do some of it for DKIS and some of it for AstroPy. So I'm happy to talk about that with people as well, if that is of interest to anyone.
All that is.
Sorry.
Go ahead, Pierce.
It might be off topic, so by all means, just tell me to shut up. But on the Dask thing, I've always found anytime I go to Dask, I get completely lost in the first like 3 minutes, where it's like you need to boot up this server, and especially if you're trying to do it on different machines and stuff. Are the plans with DKIS and future plans for using Dask at SunPy, will that be like abstracted away so people don't have to worry about it, or?
So there's multiple layers to Dask. This is going to get into the weeds a little bit, but the core component of Dask is that it builds a DAG-directed acyclic graph of tasks that need to be worked on. So like if you take a Dask array and sum it, it will figure out, like you'll say, oh, I need to sum every chunk of this array, and then I need to like do a group by operation on those sums to make a final sum, and here's your end result. It breaks up your work into that. Dask can be used without any fancy setup, just straight on your local machine in a Python interpreter. It's only if you really want to get to like distributed and big scale parallel computing that it gets fun and gets into like, okay, now I need a supercomputer or a Kubernetes cluster where they all talks to each other and really scales out big time. Dask is definitely useful for larger than memory problems on one single machine.
I think it can be extremely complicated, and I think it's very reasonable to be confused about what Dask is because it has so many varying levels of complexity. But I think, yeah, at its core, it just is a way to express your computation in such a way that it can be spread out across multiple workers. Though all those workers could be the cores of your laptop, they could be 1,000 nodes on a supercomputer.
Yeah.
And I can't speak for like the DKIS side of things, but like on the SunPy side of things, I think this is how one should approach integrating Dask into like a scientific library, is that the way you integrate Dask into your package, you should not care like where the computation is being done. Like that's for the user to decide. Like the user sets up their cluster. That cluster by default could be your laptop, could be a supercomputer. You set up the cluster, then Dask creates the work. Where you send that work is up to you. That probably wasn't a less confusing explanation.
I think it helps, so thank you. Yeah.
My question was going to be all of these things that you said, like ASDIF.
My big buzzword bingo.
Yeah,
Yeah.
like all these things are things that, like, I think even like us in this room, like, don't have a great handle on like using in our day-to-day workflows necessarily, especially in the larger solar physics community. It's like, what is the approach from like, this is like from the data center perspective or from DKIS perspective? What is the approach to like community education when it comes to like allowing people to actually make use of this data with these tools?
The second I get a minute to breathe from desperately trying to fix all the bugs, I will be working on that. Yeah, I think I appreciate the clock is running somewhat, but I mean, make it work, tell people about it, make it work fast in that order. Jack.
Yeah, I have a question about your use of NDCube.
Mm-hmm.
So you're using NDCube in a production environment, is that correct?
Yes, sort of. With the ND, so we are using NDCube to write the ASDIF files, basically due to how ASDIF Python works. To save an ASDIF file with a DKISS dataset object in it, you construct the DKISS dataset object and hand it to ASDIF, and it serializes it. Therefore, when we're writing the ASDIF file in as like basically the final step that happens in the data center, we are using NDCube to do that out because we have to construct the object to save the object, if that makes any sense.
Yeah, but that's quite a significant job, right? Because the ASDIF files are the first thing that people are going to interact with for DKIST. Is that right?
Yeah.
So, okay, well, that's great. The next question is more to the room. Is anyone aware of the use of NDCube in any other operational environments?
Punch, it sounds like, right?
Okay, sorry. Yes, we're using NDCube. Punch.
Punch. Okay, yeah, I missed that. Came in at the tail end of the Punch talk, so thanks. Okay.
Jack, when you say operational environments, do you mean like data pipelines or calibration pipelines?
Yeah, that's what I mean. So it's kind of a different use case, and you're sort of really relying on the code is more battle tested, right? If you're in that kind of environment, because all sorts of things can come along.
So I should say from like the DKISS perspective, we don't well, is that actually true? Maybe, I don't know. If we do call methods on NDCube inside the DKISS pipeline, like the DKISS process data center, we don't call very many. It's not like we're making heavy use of NDCube inside our software. We are using it right at the end of our current pipeline, but only sort of instantiating it and then saving it. Like we're not using crop, right, as an example of one of the gnarlier bits of NDCube where there'd be dragons, you know, like.
I really thought it was fine until, like, you said that you came across.
If you write some code, I can find a WCS that will break it.
Yeah. I really thought I tried everyone I could possibly think of, but I guess that's unavoidable.
So if there was some DKISS data right now,
there is.
Some people were able to download it, and they get it in their laptops, their workstation. How do you expect them to visualize and work with this data?
So we haven't written a huge amount of code beyond get and load data for DKISS at this point, right? The data center team is very small. I have been the only person working on post-calibration data. Well, that's not strictly true. Post level 1 fits, I'm like the only person who's really been working on that at the data center for the last 5-6 years.
So if they have an image from VBI and the spectrum from WISP, how could they combine these two, for example? WCS and NDCube?
Yeah, WCS and NDCube, and like over WCS axes.
Would that scale if you have a time sequence of an hour?
Probably not.
I think that's the biggest issues that people will have with using the SunPy machinery. With the data processor not from space missions are much larger, and it's going to be a struggle to be able to, for example, watch a movie quickly, play through a movie, and then combine multiple images and different instruments at the same time.
That's especially true if you're interested in like plotting space from a spectrograph, for instance, right? Like if you want to.
But the spectrograph in space is quite small. The data volume is maybe a few gigabytes at most.
No. I mean, like if you want to take a VISP data set and plot the two spatial axes, right? Because it has to access a lot of data that is badly chunked on disk to do that. Like, yes, there are.
So you want to play a movie for at least 30 frames per second.
Really bad, yeah.
So that's something that's really important because people need to be able to do that.
Yeah. It's also really hard.
It is really hard. I know.
Yeah, and I mean, premature optimization is the root of all evil. We have not got there. But we haven't got what we have to MVP yet. Like the user tools are open source and on GitHub. Community contributions are welcome. Jack?
Yeah, I don't know if I might have missed this as well, but are all the user tools in Python? There's no vestigial IDL code around?
I believe Alistair is writing some IDL code to go in SolarSoft primarily to handle reading our rice compressed bit files.
Okay, but
apparently I am reliably informed that the default IDL fits reader does not handle rice compressed files, and read SDO does something fun to handle rice compressed fits files. So Alistair's working on some very minimal support in IDL to handle opening of fits files.
I thought it was possible to open rice compressed IDL.
You are asking the wrong guy.
So, Tiago, to your point, do you think is the big or this big image problem, is that something that's is that solved with other tools or with the IDL tools, like for doing SST analysis, or is this a problem? Is there something in SunPy that we're /IndieCube our ecosystem that's posing a specific problem?
I think of course, the IDL tools don't have all the machinery that we have, and don't have often WCS. But one thing that IDL does really well is basically displaying images very fast. It's very competitive. It's hard to compete. For example, Matplotlib will never reach that probably.
Especially not when you lay a WCS axis on top of it.
Even really 1K by 1K image, play that at 30 frames per second. In Matplotlib is impossible.
So
it's not what Matplotlib was.
No, it is not. And that's something that IDL does very well, and that's something that everybody's going to do when they look at the data. They just want to look at. They want to look at the time sequence. Okay, there's something interesting here. Then I can zoom in and combine different instruments.
Yeah, maybe we should add this to the roadmap.
Oh, like
as a bigger project.
I mean, part of the reason is that IDL just uses pixel. It's really just a dump array, and then just displays it very fast. If you have a WCS axis, then it's going to be painfully slow.
How important do you think it is to have coordinate support in that really performance-sensitive workload?
I think it's not very important. Maybe if you want to combine two things and watch a movie, like combine two filters on top of each other, maybe. But then maybe you can do some pre-transformation of the data. You can also do quick look movies, right? People have that. But sometimes you want to have a fine grain, you want to change the image contrast, you want to change the gamma, you want to look at features a bit more closely. So if you just have a quick look movie, just an MP4, then you can't do that. And you can't, for example, adjust the frame rate or skip or whatever. Blink, things like this.
Get a better video player, but yeah.
Do you think that there are other visualization libraries, even, let's forget coordinates for a minute, because I know that's always the roadblock when we talk about things not Matplotlib. But are there other visualization libraries in Python that people are using to do this at a not impossibly slow?
I've used PyQt for making this kind of fast movies.
Okay.
And that's probably the best one there is.
Have you seen Mpari?
No.
Mpari, yeah. It's span out of like the scikit image community. It's a very high performance image viewer.
Can you put a link into that, chat?
How do you spell it?
How do you spell that? That's a good question. I've just put it into my Firefox and I'm not spelling it right.
Napari. Napari.
This makes me wonder whether I could write a
or even stuff
coordinateless dekist player in Napari.
Like I know the Pangeo community has used HoloViews a lot, and that seems to be their kind of data visualization library of choice, and they use it on very large, very, very large data sets. Usually backed
high
by
dimension, right?
Yeah, high dimensional and extremely large, and usually backed by a Dask array. And it's, that might be, I know that library is used with like the X-ray Dask stack, so that might be another option.
I think another
thing will run at eventually is that when you have these Qt apps or something, I think that's kind of on the dying end, because the future is all visualization in the browser. If you have in the cloud, you want to visualize something, you don't want to copy everything to your laptop. So I'm a bit reluctant if it's really worth spending time developing a Qt tool.
Yeah.
It will be obsolete in a couple of years.
Yeah.
That's wildly optimistic.
Yeah. No, that's a really good point.
But nonetheless,
I like it, but that is wildly optimistic.
like nonetheless, though, I mean, David's point, I think, is a really good one. I mean, do we want to add this to the roadmap, like, you know, ability to visualize larger data fast, and with the sort of the premise that coordinate aware side is not that high a priority. It's probably something, if people are like not going to use Python for that reason, like that's kind of within SunPy's wheelhouse to like facilitate.
I think it's an interesting one, because so far almost all of the SunPy effort over the last 12 years, however long it is now, has been entirely focused on data with coordinates. Right, like if you take the coordinates away from your data,
so like,
you don't necessarily need SunPy anymore, right? If you just want to visualize fits files quickly, you can just use SunPy to load the array and plot them, in theory.
But
right, like in what? PyQt graph or whatever, right?
But there's nothing in the SunPy mission that says we only work with data with coordinates.
No. I'm not. This isn't me saying we shouldn't do it. This is me like asking where, like.
I think that's separate from a question of whether it should go in the roadmap.
So I was going to say, I was just about to say, I think Steve has opinions, and then it popped up saying Steve would like to speak.
I was just going to say. Oh, sorry.
Well,
I was just going to say this is a great topic for the learn modules, right? Where we can put in anything and be like, hey, you want to look at data instead of fits file? Let me show you how to do that. Right? It doesn't belong in the gallery, like you said, because it doesn't use SunPy, but it can live, I would say, in a learn module.
To be clear, when I said that, what I meant was it doesn't really fit in with what SunPy does at the moment, and it would be a kind of new area of stuff. So I think it's just, there isn't an obvious home for it, I guess, right? Like, where does that live?
But I would argue that we should consider it being within scope, because the point of SunPy is an access point to the Python ecosystem, and like one of the first things you want to do with data regarding access is like visualize, and if that just raise your hand again.
Yeah, I was just going to say, so in the roadmap document that I PR'd, I did say specifically that we would increase our support for new Python users and introduce them to the Python ecosystem, regardless of SunPy. So I think this falls exactly. I mean, we may disagree on whether that was something we agreed to during the roadmap, but I thought that was something we could do a better job with, because exactly what you guys are saying. If they fall, early on, because they're learning Python and they can't figure out how to do basic things, then they're not going to get the SunPy at all.
Yeah, I guess I was arguing to go slightly further, which was that, okay, it's not in SunPy now. Maybe it doesn't strictly have to be, but from an access point of view, we create something, rather than like in MPL animators but doesn't use matplotlib. I don't know, just an idea about where it might live.
I think
just something that people can read in data for using SunPy. Surely they should be able to look at it SunPy.
Sam, go ahead. You put your hand up before I talk.
Shane.
Sorry, Shane.
His username gets me every time.
I'm gonna have to change it, but I'm gonna change it. No, I was just gonna say, like, are we not already at the point, like, you can't make an AIA movie in real time and watch it in Python? Like, that's not feasible.
That's not true.
We don't have a gallery example showing.
Shows how to do it.
But not like.
Not at
oh,
30
there's
frames a second.
Of like, right, it's not.
No. I was taking umbrage with the phrase in Python. You can't do it in SunPy, and we don't tell people how to do it. Completely agree. But it's not a fundamental flaw of the Python programming language. It's the tools to do that do exist in the world. We wouldn't have to write it from scratch.
Yeah, I think regardless of implementation and where it lives in the SunPy project, I think this is a really important thing that people want to do for solar physics that they can't do, and therefore it belongs on the roadmap.
Somebody write that down.
Yeah. Say that again.
I can type it in the notes
Yeah.
if you'd like.
I'm sorry if I'm really badly paraphrasing.
Yeah, I think in more general, like tools for interactive data discoverability, like being able to make movies fast or being able to like pan around on images is not something we've done well or necessarily supported well.
Go ahead, Jack.
Yeah, the SunPy developer Matt Wenzel Long has been working on a few scripts and a notebook using I forget, not Matplotlib, some other type of visualization tool, and it does some really nice different things. Like, I don't believe it should live in SunPy, but it should definitely live in like learn.sunpy.org. So I think there's a real opportunity here.
I think there's a lot of consensus here, and I would suggest we move on to get all instruments discussed and have some time to come back to Steve. Shane has at least 2 instruments want to talk. Tiago, you also said you wanted to discuss?
Yeah, I could talk a little bit about the SSD.
Yeah, so that's what I would suggest, if that's okay with everybody.
Yeah, I agree. Yeah. Shane/Sam, good to go.
Okay, I'll be real quick because most people know this, but yeah, I just want to talk about sticks and how sticks will, I guess, interact with SunPy and the SunPy project. See if my screen sharing works. Can you see that this time?
Yeah, we can see us. We can see Gypsy.
Okay. Yeah. Okay, fine. Yeah, so I guess there's 2 aspects to this. There's a sticks core package, which is basically our pipeline that takes TM and puts it into FITS files, which are then usable by the community later on. That doesn't really integrate into SunPy because it doesn't really make sense to, but it's open source, and we use the SunPy package template and loads of stuff that comes from the SunPy project, but it's kind of its own thing, but it's open source and all the issues, and you can see all my many bad decisions in there.
Is it affiliated?
Could be in the future. It wouldn't be high on my list of things to do, but yeah.
Okay.
Could be. And so then on the user side, there's SticksPy, which is like a more interesting thing. This documentation is a bit old, but it integrates quite heavily into the SunPy ecosystem. So we've got a Fido search client. We use Fido to download data. You can use I implemented a time series client to look at some of our data that fits into a time series like data object. And in the future, we will also create SunPy maps when you make images from the sticks data. So we'll output a SunPy map with all the correct stuff in there at some stage in the future. The sticks data itself it actually lives in an AstroPy table because there's not really a good object for it to live in. At least I have one at the moment. So that was really it on the sticks front. So I think sticks will be highly integrated with the SunPy ecosystem /project. And that's really good. And then the other thing I just wanted to touch on is like iLowfire /Lowfire in general. Like, Lowfire is a radio telescope, a ground-based radio telescope. There's international stations, which iLowfire is one. and then there's the entire International LOFAR telescope. But they produce really nice radio data. Like here's a radio spectrum with a nice type 2 burst, I think, shown. And we have all this data, but at the moment it's not really easy to search or even to visualize because these files are quite big. I mean, these ones aren't, but we have much larger, higher time res files. And it would be really interesting to see how we could use Dask and other technologies to I guess, leverage these technologies to interact with these large files and just make it easy for users to get to this kind of data because it's sitting there and there's loads of interesting science in it, but it's all kind of locked away. And that's something that I think ILOFAR want to fix, but also other international LOFAR stations would be the same. And Radio Spectra is kind of doing some of this, but we could definitely do a lot more. Yeah, that's really all I had to say. So yeah, I'll stop blabbering on now. You guys can.
Shane, I had a question about the StixPy stuff.
Yeah.
Do you see like Stix time series and I guess then eventually Stix map as always living in StixPy, or is there interest in like upstreaming those to core?
I mean, I guess okay, well, so on the map side, what happens is that you get Stix data in and you combine the counts in a certain way and you make an image. So I don't really think there's like a need to have a map source because you actually make it.
Yeah. Okay.
And if we do ever make FITS files with images in them, I would really, really hope the metadata would be such that it would just work in a map. Without having a specific source. That would be my intention anyways.
Yeah, so this is pretty analogous to like the ice map that Micah was talking about earlier, where with IcePack you fit your spectral cube and then you produce a map. Like NRL doesn't distribute ice 2D ice maps, and then as such the ice map class lives in IcePack. Okay.
It also potentially goes against what might be the future direction with ND Cube in the sense of we end up with like generic map and maybe AIA meta or Stix meta. But as in like it's just the source is literally just the metadata reader, but the map itself is agnostic.
Yeah, okay. But then in that case, wouldn't Stix meta still live in StixPy?
I suppose that's the same question asked about a slightly different object. Yeah.
I certainly would have no strong opinions on where it goes. I mean, yeah.
Okay.
But like Stix is also spectrograms, right? I mean, the quick looks are light curves, but the base data is going to be a spectrogram.
Yeah.
Right. So you could have, I mean, it's just thinking about that as well. I guess if it had a spectrogram object within SunPy core, then maybe that could also live there too.
Is it? I mean. Sorry, I was just gonna say, is it unfair to say then that the map or meta sources that we have in core, and probably I guess maybe this is Albert will have opinions about this.
You just put that in.
Yeah, no, I saw it. Is it fair to say that the sources that we have in core are for the data products that are distributed by the data providers, not things that are derived from analysis packages?
Oh, okay.
I don't know if that's right. I'm just throwing that out. Maybe I'll let Albert have his opinions now.
I mean, you know what? I don't want that stuff in core. I mean, it basically just comes down to that. It's for me, it still continues to be weird that we are maintaining things for the instrument teams in core when they could live in their own packages.
So hard. We don't need to relitigate this over and over and over again.
Okay.
I would say if there was a spectrogram object in SunPy or an ND Cube object that we could use in that way, it would be useful for StixPy. Yeah, that would be my final.
Okay.
Thanks.
Final question on that.
is there something very specific as to why it couldn't just be an ND cube?
A spectrogram.
Yeah.
Again, this comes back to like the radio spectra thing. I've never tried to do it. Yeah.
So that would just require some more thought and testing, and exploration. Okay, that's completely fine.
It
Short
could be
answer.
another thing for Friday.
Yeah, maybe.
Yeah.
Yeah. Good point.
Tiago, do you want to talk?
Sure.
This is the team.
I've never shared my screen in
6 is great. 6 is great.
Oh, I need to reopen Chrome. Sorry.
While you're doing that, then I'm gonna take the opportunity to show a slide that I have quickly. So this is just a quick one of the, I guess, nominally instrument-y things that I work on and / represent is the Moxie instrument on Qubix. So Qubix is the I should be capitalized, I think, is a CubeSat. It's PI by Amir Caspi from SWIRI. Albert is the PI of one of the instruments on Qubix called Moxie. It's a multi-order X-ray spectral imager. So it's an overlapogram, soft X-ray overlapogram. I think it's nominally the bandpass is 1 to 60 angstroms. So this is a Moxie image, if you will, of what the overlapogram data will look like. So a few things here. We have a +1 spectral order in one direction, a -1 spectral order in the other direction, and then we also have the plus third order and plus minus order. So you're seeing that the 0th order image is the really bright sun in the middle, and then it gets dispersed in multiple ways in both directions across the detector. So right, the advantage is that it's a slitless spectrograph. So you get spectral information without having to raster. The price you pay is that your images look like this, right? And you have to work out, intelligent ways of saying, what does this mean? And there are various strategies for that I won't really talk about here because we're still working that out. But I just want to say that to do this, to do the modeling, I'm using SunPy, some aspects of AAPy, some parts of SunKit DEM, which is no longer an affiliated package, I guess. And then obviously in DCube. So basically what we do is we use a DEM to make a spectral cube, yada, yada, yada. You disperse that across the detector using AstroPy reproject by first constructing the WCS for the overlapogram, which we can talk more about later if you would like, much later. And then you get one of these things. So the advantage of then writing a WCS for this is you can say, okay, so if I have this little spot, this tiny little active region, actually, so this is actually, the sun is actually rotated here. So you'll notice that this HPC lawn, the grid is actually on the left. This is actually a little snippet that David sent me, coloring the axes such that you can put the axes labels and have them remain static, then the grids denote the color. So longitude is on the Y, latitude is on, oh, sorry, no, yes, one. It's flipped sideways. So if you want to, so if I want to see like where does this little active region denoted by the green X here, where does it show up at where does the 15 angstrom image of this active region shows up? You can use basically the WCS. Oh no, where did it go? You can use your WCS and your Pixel to World machinery to say, I know just based on the WCS that my 15 angstrom image should have been dispersed onto the detector at this spot now where this green X is. And you can see that my grid has also, my spatial grid is also shifted such that the location of the green X is the same relative to that shifted spatial grid. And again, this is all using just the WCS machinery. And then you can do the same thing for, okay, where does my 15 angstrom active region show up in third order? I don't know why I have an extra blank slide, but no, it's it's stretched all the way to this portion of the detector. So this whole WCS machinery allows you to see where the various contributions from your particular regions of the sun are being dispersed onto your detector. So we can talk more overlap programs later if you like. I basically just wanted to show these images in my very wacky WCS that I have.
And it's a great demonstration of so long as X-ray doesn't support WCS, ND-cube is important.
Yes, yes.
What is the size in pixels of the detector?
3.5 arc seconds per pixel. Is that right, Albert?
Yeah.
Yeah. So it's fairly low res, but it's full disk. Yeah.
So that is like 10,000 arc seconds or something? Divided by 3, so 3,000 pixels?
Yeah. Wait, sorry. Wait, what is 3,000?
No, I asked in pixels.
Oh, in pixel space. The detector is like 1,000 by 1,000 wide, like 700.
Okay.
Yeah.
Well, it's actually double that, right? So it's 2,000.
Oh yeah. Sorry, it's 1,000 in one direction. Yeah, so 2,000 by 700. Yeah.
And what is the typical cadence?
There are, I think we were saying 20 seconds, and for some mode, for like a burst mode, or 5 minutes for like a more steadier mode, for like active region type observation. So 20 seconds for flares, 5 minutes for active region observations. And talk about SSD stuff. Yeah.
I can share. So I just quickly made some slides. It's not there, but do you see it?
Yep. Oh, yeah.
So I am not a part of the SSD instrument team. I mean, the SSD is operated by Stockholm University. So I'm speaking more in the capacity of a user, and not even a very power user at this. So I cannot deal with all the parts of the processing, or I don't have experience in everything. But this is just a quick overview of the SSD. So SSD in La Palma is a big, or 1 meter, much smaller than biggest, but is a refractive telescope. So it has a huge lens. It doesn't have a mirror. And then it has this big vacuum tube, and then an optics lab in the basement. And I'm going to talk mostly about 2 instruments that are the most used nowadays. There's also a slit spectrograph called Triple that is not so used, and there's going to be a microlensing spectropolarimetry called HESP, but is not yet in full use. So most people that go to the SST today observe in these 2 instruments, which is CRISP and CHROMIS, and they're both Fabry-Perot interferometer. And that means that they gives you a small image on the sun. The field of view is about 60 by 60 arc seconds. And then it scans very quickly, in the order of a few seconds, through a spectral line. So it takes images of the same field in different wavelengths, and very small wavelength increments, because the spectral line is quite narrow. And they can do this for several spectral lines, and they can, the CHROMIS side, which is this bigger arm, can also do polarimetry. So there's these 2 liquid crystal things and 2 cameras that record different states, and they can reconstruct the full Stokes vector from that. CHROMIS at the moment does not have polarimetry. It'll probably be added at some point. And this has a collection of cameras, besides the calibration, adaptive optics, and so on. Usually in this current setup, we have a wideband camera for CRISP, which captures like a wide range of wavelengths, typically the solar surface, the photosphere. And then we have the narrowband cameras with 2 states. And in CHROMIS, we also have narrowband camera, we have a wideband camera, and we also have an additional camera used for phase diversity, which is one of the ways that we can reconstruct the data to kind of cancel out the seeing effects. So CRISP and CHROMIS are the 2 main instruments at the SST. This is just a quick illustration from the CHROMIS paper. It shows the effects of different reconstruction methods. So this is one of the simplest ways to reconstruct. This is already data with a taken in very good scene. And then when you apply this multi-frame blind deconvolution or multi-object multi-frame blind deconvolution, you get a much sharper image, which has to do with the way the observation is taken. You take like a burst of observations, and the atmospheric is smearing your observations, and you cannot have a model for this and try and cancel it out. It's extremely time-consuming to go from this to this. And then if you apply the state-of-the-art is to also apply the further phase diversity to that, and you get the sharpest image. And at the moment, DKIST is not doing this. It will probably not do this for a very long time, if ever. So they use a much simpler method called Speckle, which is much more computationally, it's cheaper, but it's not as good. The downside is that to be able to do this reconstruction, most end users will not be able to do. You need a cluster and you need a lot of specialized knowledge to go into that. In terms of throughput, so the SST is probably one of the highest throughput solar telescopes right now. Stuart said the DKIST is expected to do about 12 terabytes per day. At the SST, we already do, there's some days we already do more than 8 terabytes per day. And this is because SST has a good adaptive optics system, so you can observe for more hours of the day. And it also has the instruments currently are more complex than the typical instruments operating in DKIST right now. So just promise the cameras take images at about 80 frames per second, and the cameras are about 2K by 2K, or 1.5K by 1.5K, and exposure time is about 12 milliseconds. And this translates to about 1.5 terabytes per hour. Crisp is a little bit lower, so about 400 gigabytes per hour. The cadence here, the frames per second is a bit lower, 37 frames per second, and the size in pixels of the camera is also a bit lower. But in total, we have about almost 3 terabytes. Actually, it should be closer to 2. About 2 terabytes or 2.5 terabytes per hour. So if you observe for 4 hours, which is a very good day, then you have a lot. The existing pipeline is called SST Red. It's developed at Stockholm University. It's on GitHub. It's written in IDL. It's a huge piece of software. Again, the image reconstruction part is very demanding. Most people, there's very few groups that can actually do this. Maybe it's Oslo, Stockholm, and Belfast. So most end users will not do this, and they collaborate with some of these groups. And also in the good tradition of ground-based telescopes, all the data is proprietary. There's very few open data out there, even though that is starting to change, and there is a will to start putting this data out there and making it publicly available.
Is that because of just the observing plan? Like a person goes to do their observation, like it's not something that's taking data all the time?
That is part of the reason too, but also first, the data volume is huge.
Yeah.
So it used to be that people would go there with a suitcase with hard drives and bring it back. Nowadays, the internet link is quite fast, but I think it only works at least to Stockholm and Oslo. I'm not sure if it's possible to also do this for other places, but then you need huge amount of space. And also because of PI time, observing time, things like that. Now there's some SolarNet time, so maybe some of those observations can become public after a certain proprietary period, like in DKIST. So the end result of all this, there's different stages of the data processing. The end result is FITS files, which are produced by this SST Red. And I remember just to write a file, just to write the final files took about a day. And I think this is typical for one data set. These have a lot of metadata compliant to the SolarNet's recommendation document. And this uses WCS tab, which at least up to a couple of hours ago was not working properly with the WCS, but I think Stuart may have just fixed that. What else did I have?
So the whole WCS is WCS tab?
Yes.
Is that because
except Stokes.
Okay. Is that because of the distortion that has to be modeled?
That I don't know.
Okay.
The tab including the celestial axis.
Yeah, the spatial X and Y. Currently, yes.
Okay.
I don't think it has to be in X and Y. I don't know why they chose that. I think the distortion is very, very small for in those axes. It's certainly you need tab for the wavelength because it's not constant separation, and also for time because it can operate at different times. So normally one of these files the output files. One of these files is one data set, and it's 5 dimensions. So it's time, it's Stokes, is wavelength, and is X and Y. So typically they could be a few hundreds of gigabytes per file. And they are visualized with this piece of software called CRISPEX. And this is a screenshot of a version some years ago. And what you do here, you have an image viewer in the center. The main part is an image viewer. And then you have some controls here that you can use to play a movie, which is very good at doing that. It plays the movie very fast. And then you can play a movie of a fixed wavelength position. So here in this tiny window, it's hard to see there. This tiny window shows the 4 Stokes parameters, I, Q, and V, at a fixed wavelength. So you can, in this case, I think it's showing probably Stokes V or something. You can also show just intensity, and you can play fast movies. And you can also use CRISPEX to combine different data sets in the same formats that don't necessarily have to be from the same instrument. So one could be from Iris, another could be from SST. And then another cool feature is that you can use your mouse over it, and it will update this detailed spectra. And it also has a different panel, which is the temporal slice. So for a given mouse position, it shows you the spectra. So I think this is wavelength. This is a bit hard to see because this is not Stokes I, and this is time. So it shows for, say, for this pixel, or this red one here, in the penumbra, it will show you the a spectrogram of time versus wavelength. And to do that, to be able to do that quickly, the data has to be duplicated in disk. So there's 2 versions of the same data. One is just the transposed version of the other one. So if you have a file that's 100 gigabytes, then you need 200 gigabytes, because you transposed it for quick access. Yeah, so that's basically what I had to say about the CRISP and Chromis.
This is something that we tried, well, but I think first time I remember anyway, was a few years ago now, we tried to do something like this with glue. Because like Iris uses this or something very similar to this, right? Well, yeah.
Yeah, you can also use this for Iris.
Right. And it's a really, I think it's a really sort of powerful way of like looking at it. In this case, especially when it's huge, but even stuff like, because you can sort of point on one frame and like it gives you information like through the other dimensions of the other parts, right? So that's
usually also say here what is the coordinates and time.
Yeah. So I think something like this could be, and I think it has been done in certain cases with glue with Python. However, when it comes to the size of the data, that's a different thing. But yeah, no, it's a great tool.
I can show, maybe I have a terminal open to show it here. So I loaded a small data set in my computer.
What is a small data set?
It's like it only has 5 time steps.
Oh.
So
that's only 500 gigabytes.
Modest.
Yeah.
No, I think it's only 2 gigabytes. So I opened it with SunPy. Fits and has a bunch of very extensive header, which I'm not going to go over. Let's see if I make some plots. So this is an image. You see a sunspot. I'm just going to, oops, quickly. So this is one image at one time, one wavelength. I can put a different time.
And going back to what you said earlier, it's in pixel space. There's no attempt to combine.
No, there is a WCS here. It doesn't work right now with SunPy because of some bug in SunPy, but I think Stuart may have just fixed that.
Oh, this is the tab bug you're talking about.
Yeah.
Right, yeah, okay, right.
And you notice here I overplotted one on top of the other, just one different data set. You notice here that the image, they have the same number of pixels, but the padding is different. So, for example, you see there's like this thing here, which meant that one image is kind of shifted. There's 2 reasons for that. So one is that these images are not derotated like thickest. So as time goes by, the sun is going to rotate in the image plane. And the other thing is that the atmospheric seeing is going to like distort this in different ways. So even though this image is already aligned, that say this feature here is in the same position in both images, not all pixels will be kind of have a true data value in both.
Okay.
Sorry.
Yeah.
For example, here, in this very corner,
Yeah.
one of the images covers this corner, but the other does not.
Okay. Okay, so you can, it is aligned such that if I take a slice through.
Yeah, it should be correct, the
Okay.
slice.
Yeah, take a slice in wavelength.
But
and
sometimes some
say-
slices will have gaps.
Yeah, okay, yeah.
Near the edge.
Yes, right, yeah.
And I can also plot different wavelengths. So this one. And this is the same field of view, but taken near the line core. So you see the, well, here you basically see nothing, but if you look in my screen, you see these fibrils in the chromosphere.
Yeah, I can just about make them out.
Yeah, you can see a little bit.
Yeah. Great.
So when it does this from CRISPEX, is it just dynamically reading slices off of the cube?
It uses like a map thing.
Oh, yeah.
So this this array is 5-dimensional. The first dimension is time, which in this case it only has 5 time steps, and then this one does not have Stokes IQEV. So sorry, the polarimetry, so it only has 1. And then 48 is the number of wavelengths, and this number is not usually very large. It's rarely much more than 50. And then there's X and Y. So it quickly adds up. Especially if you save it as a, say, float 32 bits. Normally it's saved as a 8-bit integer to save space.
Is this something, assuming that fix of Stewart's does solve the problem, is this something you would consider or very much not want to use with NDCube and Dask?
I think it would be really nice to use NDCube and Dask. In fact, I hope I can load it one day. Right now it doesn't work, but
okay.
Maybe once this WCS thing is fixed. I think it's to do with it. AstroPy does not have so much support for WCS tab.
Right, right.
I mean, do you carry these around like on your laptop, or do these usually sit on like a computer?
Yeah, it usually sits on a network disk.
Okay, right.
I may sometimes, if I'm working on something, I might copy this 100 gigabytes to my laptop, or maybe 200 gigabytes max.
Okay.
Usually, you need a fixed workstation. You don't carry them around. You can put them on the external disk, but again, the read speed also matters.
Okay.
So you have to have a fast disk.
Is just to go back a couple of points. Is NDCube fully compatible with that?
Mm-hmm. Right, when you've used it in anger more than I have. If
Do you run your entire test suite with Dask arrays?
I do not. Well, I do not. We do not.
Yeah.
No, it's we don't test. I don't think we test with Dask at all.
SunPy we have some Dask tests, very minimal Dask tests, but NDCube.
I don't think we do. Yeah.
I mean, it works in the sense that like there, as far as I've seen, there's nothing in NDCube that like forces your array. Okay, so you can stick in an array plus a WCS. You can use a Dask array plus a WCS in the same way you do with NumPy array plus a WCS.
Yep.
And then when you do your all your slicing and stuff, it just gives you back like an indexed Dask array. Like it does not force it into memory.
You delay.
Yeah. Yeah. It just gives you a slice.
An exception to that might be the newer reproject 2.
Oh, certainly, yeah, reproject. Anything that touches reproject is going to force everything into memory.
Yes. Right.
Yeah.
Well, what happens if you're kind of playing a movie, and so Dask starts reading more and more? Does it get rid of the old stuff?
It'll just read one at a time. Yeah.
Okay.
Yeah. I'm pretty sure.
I'm not sure what memmap does. If you have like a very large array, and then you read a slice and then another slice, and then
well, because I think
it's setting up.
It's doing whatever. I think it would depend on whatever you're doing with matplotlib. If it's flushing the screen, then it's flush the array from memory. It shouldn't pile up.
Okay.
Yeah.
Thanks, Yoga. That's great.
Yeah.
Is there any like available data? So, like if I wanted to have a look at the data, is there some repository where you can get access, or do you just need to know someone with observations and ask kindly?
And the second one.
Okay. Yeah. But even like I thought that like data, maybe it's a SolarNet data, like after 6 months it has to be open source. But like again, is that just you have to know the person and made the observations? So.
I don't know if there's any data available right now. But it's true that they are trying to put it out there. Yeah, I don't know. But these data from the Kubernetes pipeline, at least, they're also relatively new. So there's not so much out there.
Since 5:30 has become our unofficial end time, do we want to see if Steve wants to revisit?
Yeah,
are we at the stage yet?
I was going to ask that, but maybe before that, if there's anyone else that's on especially online, that wanted to either say something regarding like SunPy support for instrument teams, or if you have like more sort of stuff you'd like to show.
Yeah, maybe some people have joined since.
Yeah. Not hearing anything. So yes, Steve, if we wanted to circle back to the stuff we were talking about before I sort of interrupted you.
If we're going to do that, if that is a break from instrument stuff, maybe we should, like, say people who aren't interested in that can sort of drop off. And is that fair, Steve? Is this kind of a tangent away from specific instrument stuff, or do you think that this is still instrument support related?
Yeah, I would say it's instrument support related. I mean, it's the template and the an instrument specific template and how we might support that.
Okay, so some people might actually be interested in this then. Okay.
Yeah. But by the way, I'm currently waiting on the phone, so I'll have to step away as soon as they get back to me.
Okay.
Okay, so let me go back. What I wanted to do was show what we did. So one thing you notice, like for 6Pi and others, right, is everybody's using the template. Ooh, this is way too big. But I can't. Oh, here we go. All right, can you guys see this?
We can, yes.
Okay.
Again,
yeah, everybody's using
if you could make the font a tiny bit bigger.
Bigger?
Tiny bit, if that's okay. Just our screen is small. It's a small big screen, yeah.
Small big screen, okay. All right, so yeah, I just want to go through, what I did to the template, which I guess is would be nice, for each of the instrument teams and other users of the template, not to have to manage the template itself. There are tools, as I mentioned to Stuart, to kind of keep templates up to date and rendered, and packages that use those templates, to update themselves. All right, so here's Hermes core. We talked about the dev container a bit. I'll just go over it quickly, but basically dev container is, since this is all going to be running in a Lambda function on the cloud, in addition to, people's laptops, we define the container that we're going to use on the cloud so that we all develop in that container. We then test on other systems as well, but we want to make sure that, any code we develop here will run in the container because that's what is processing our data. So it's very important for us to manage that container. Yeah.
Yeah, just to clarify for the room, when you say we, you're talking with the Hermes hat on, right?
Yes, I'm sorry. Yeah.
Yeah. So this, like, if you want to start a new package for the SunPy template, this isn't what you will get at this stage.
No, but we could. Yeah, that's right. So this is based on the template, but then we made a number of changes, and I'm just going through the changes that we went we added.
Right.
The other thing is we changed everything to use GitHub Actions as opposed to the old template was still using Circle CI. I noticed that SunPy is still using Circle CI as well. But I think SunPy Core doesn't. So I broke it up into three. We have code style, we build the documentation, and then the testing. Oh, sorry, I have to go because just 1 minute. I have to go because they just ended the call. It should just take a few minutes.
Okay. Someone put an elevator music in.
Yeah.
Hey, can I take this opportunity to ask about a different topic?
Sure. Yeah.
I don't know if it would. Yeah, no, it's something because both Dan and Nabil are here. So I just had a question about SunRaster.
Okay.
Dan, when you first designed SunRaster, my impression was you were working on something that in theory could be used to read any slit spectrograph eventually, that might be the goal.
Or at least represent any. I wasn't thinking like you'd have a reader function for every conceivable possible instrument, but certainly it could represent data from any such instrument once you got it
well,
in.
that might be the distinction I'm trying to understand, because I know that Nabil, for Iris, you guys were using it for a while and then you split it off into something Iris specific. So I was just curious about if there's any vision for how that would work if more slit spectrographs were introduced and could be read into Python, whether people could go to one routine to read them all, or whether each team would be perhaps doing something based on SunRaster and NDCube separately.
Nabil, do you want to take that first? About the Iris side?
So what has been split off from SunRaster was the reader, as in, because the FIT files have, Iris FIT files have certain requirements that need to be changed before they can be, before a WCS can be properly. As a result, I decided that that reader should be moved out into IrisPy, which I control and release, so I can make changes as required, independent of SunRaster. But when they read the data, that gets loaded into a SunRaster object. So the reading is under my control, but the object used is a SunRaster object.
Yes, you're saying it's not like Iris SunRaster.
Yeah. It's not like Iris SunRaster codes in IrisPy. It's just the fits reading part. It's in IrisPy.
Right. Because that's the source specific stuff.
Yeah. Whereas for Spice, there isn't, or there certainly wasn't when I was working on it, Terry. There wasn't a Spice instrument package, and so given that, it seemed fine to have an instrument submodule within SunRaster and have the Spice reader in there. So, so I don't think the SunRaster object or the SunRaster package was ever conceived to never have any gaps or holes in it, and say like any file from any instrument with any peculiarities and non-uniform conventions would somehow magically be read by one reader function, but that the SunRaster object could be used to represent data from any slit spectrograph object once you had defined like the mapping from the instrument file, into the object. Does that make sense?
So then we have an object that can be used by multiple slit spectrographs and then could be used in the same way, but they might be read with different software specific to the instruments.
Exactly.
Is that a good restatement? Okay.
That's exactly it. Yeah. I mean, and the software could likely simply not even be anything complicated in the sense of like a package. It could literally just be a single function, as it is with Spice, right? There's a Spice reader function, and that just takes a file, puts it into SunRaster objects or ND collection if you've got multiple windows.
Okay, so if we add something for Spice, though, like some sort of calculation for uncertainties, that could also be in SunRaster, but it might be separate.
Yeah, I mean, if it's
as part of like the reader function, where you're like you're making that calculation from stuff in the fits file and putting it in the dot uncertainty attribute, then yeah, that makes sense.
Okay.
If you're talking about like a separate like uncertainty suite in a whole other Iris specific submodule, that might be something we should talk about and understand a little bit more.
Okay. Thanks. Just wanted to be more clear on how all that was working together with different instruments.
Yeah, no problem. I hope that's helpful, and I hope it's not like a problem. If it is, we should talk and figure out what it is.
No, I just wanted to understand better how that was supposed to work together.
Okay, great. Am I right in saying Steve has come back? Is that his hand up?
His hand is raised, I believe.
Yeah, I'm back, and I had a specific comment about that. I mean, so again, this goes to the roadmap, which and the PR. As we integrate NDCube into SunPy, I think we should have a conversation about whether slit spectrograph data is supported in SunPy core, whether it's pulling an object from sunrest or whether once we're using NDCube in SunPy, should we just have that object there and the readers there as well? So a discussion to be had in the comments of the roadmap, or maybe detailed later.
Sorry, just to interrupt.
We don't need to have the discussion now.
No, we're not having a discussion. We've already decided that eventually. I think we've already decided that.
It's already on the roadmap.
Yeah, it's already on the roadmap that we want to. When SunRaster gets into a state we like, it will probably revert into core. The readers, we will have to have a separate discussion about.
I mean, we already provide readers, like MAP provides the readers. So
we don't have to have the discussion now.
Okay, yes, very good. Hey, he started.
Trying to get Albert on mute again if we do keep doing this.
All right. Okay, so yeah, I'm back. Right. So here testing, we have Ubuntu latest, Mac, and Windows. We're testing on Python 3.7. Blah blah blah. Okay. What else have we done? What's happening? Why can't I go back? Oops.
It's just like, so Steve, can I just ask a quick question? Oh my God.
Yes.
What's instrument specific about this package? Is there anything instrument specific?
Oh, so this is not an instrument package. This is Hermes Core, which sits above the instruments. So let me show you an instrument. So same thing. Maybe that's helpful. So we have a data directory. We haven't quite figured out how to manage the calibration files. At first we had thought, so that's something that an instrument specific template would be helpful in, because so remember, calibration files have to be called by the package, and they may change. So for a particular time, you might have two different versions of the calibration file, and you have to enable users, to use an old calibration file. Yeah.
So this specific question would depend on the size of the calibration files. For example, for
They're small. They're usually small. For example,
for AAPI, those calibration files live on a URL on a remote server, and using the data manager, you can download those files and you can have the versions. They don't have to be in the repository.
Yep.
For IrisPy, I keep them in the repository. Maybe I shouldn't, but I do keep them in the repository.
Yeah. So it would be nice to just provide, instrument teams can.
But I think that's a decision that the instrument team would have to make, whether or not they want to keep them in the repository or on a remote server and download them. I don't think we can offer them the choice of either, but I don't think that's a choice that the template. Because when I just said I kept them in the IrisPy, Stuart looked at me funny. So
Yeah, and I don't know how you would manage. So do you overwrite them? Do you use Git
No, I
to
just
version
version
control
them.
them?
I just version them.
In AIA we use the data manager, so it checks the hash. It expects a certain hash from like the SSW server that we pulled it from. It's different
Okay.
than it throws you an error. Yeah.
Okay, so I'm just saying, everybody is solving this problem on their own for themselves, and it would be nice to provide a provide one solution, which would probably be okay for most people. And if they want to diverge from that, that's fine. Right?
Okay, sure.
Okay. Yeah, that way we don't, each team doesn't have to rethink the wheel every single time. It's the same problem as everybody else. Let's see what else. The other important thing for an instrument, and this is a new requirement for instruments from the heliophysics data management plan, is documentation. So I have a documentation template that's built into here, which includes the CMAD, and this is this new requirement, and they provide, the heliophysics provides a template for this documentation. So that's all that is in here now.
But just to clarify, this is a NASA requirement.
This is a NASA requirement. Yes, that's right.
If you're an ESA instrument team, you probably would not want.
So
I don't know if they have their own equivalent.
Yeah.
Yeah, that's good. So, right.
Okay.
But it is just a smart thing because all it does, because the new NASA requirement is that you provide your processing data, your processing calibration algorithms, you have to describe them, right? You can't. You have to tell people how they work and what you're doing. And so this is what this required document for NASA missions includes. So your calibration plan, your measurement algorithm descriptions. Yeah, that's all. This is all just from the template.
Sure, but are these the only two instrument-specific things that you've come across so far, or is there other things? Just so I understand everything.
Oh, from an instrument
Oh,
specific.
instrument. Yeah. What's in my calibration data?
Yeah, those are the main ones, and then of course kind of the dev container thing, because again, instruments will be using these packages to process their data on a certain machine, right? And so they need to control and ensure that this code works on their processing machine and doesn't work, right? So there's a difference. There's like you have to think like this is production code.
Steve, are you talking about like this is an instrument package in which it only, well, not only, but it focuses on the pipeline and creating the data products rather than then doing analysis with that data, or does it merge the two together?
It's both.
Okay.
Yeah.
Yeah.
Yeah, I didn't think it was worthwhile to maintain two separate packages, because it's just a pain, and also like when you process the data, you also want the tools at your fingertips to like check the data and visualize it and stuff. So from an instrumenter's point of view, right, why would you separate the two?
Yeah, for sure. I just double checking. Thanks.
Yeah. I mean, the other thing also is it would be nice to kind of create an API or agree on kind of an API for these high-level API for these instrument packages, like a function called calibrate file, for example, right? And so you always know that what function you have to run on a data file to process it up. Now that's something the instrument teams need to get together and discuss. But again, it might be nice to have to provide in the package some sort of model, I guess, model API, which
Yeah, I definitely.
they can diverge. It's fine.
No, I definitely agree with that. As far as like wavelength response functions, I've written like multiple versions of like wavelength response classes and readers, and it feels like I'm doing the same exact thing over and over again, but with the slightest tweaks. And like, why isn't there like a base like channel class or like wave response class that we can just feed like, the transmittance and the efficiency into? Like, yeah, I very, very much agree with that.
Yeah. And then the rest of it, I mean, I didn't make very many changes. I do want to get rid of talks, even though it's still here, simply because I don't know. We're managing our containers over here and environments and stuff, and since we're running all the testing and stuff on with GitHub Actions, it didn't seem that valuable to have another wrapper.
Before we get in the weeds about talks, I was wondering if any other representatives of instrument teams online have any thoughts or reactions to this. Is it totally over people's heads? Do people think this could be useful? Do people strongly back up some of Steve's suggestions? Sorry, someone there.
Yeah, Micah.
Oh, Micah, yeah. Go ahead, Micah.
Yeah, so I guess really stupid question here. For a team that already has existing package, what is the benefit of adopting a template format?
Can I try to answer that, and then everybody else can?
No, sure, go for it.
So for me, for example, I mean, I don't want to have to maintain. Let's say, if you're using a template, like you start off with a template, but unfortunately, things change over time. And I don't think that the individual template users should each have to maintain the template separately. I think it would be much more helpful if a smaller group, like for example, if GitHub Actions, if we decided that in the template we're using GitHub Actions because, where our template is targeting GitHub, and then GitHub Actions, changes, right? You have to update this. Well, it would be easier if the template updated and then you just came in and updated your template with those changes.
My just to quickly jump in there, my vision for the SunPy setup for this is that a bot would open a PR to your package with, here you go, here's this week's template changes. Review.
Yeah, and you could add that. That could be automatically. That could be in your workflow. You could provide a template that has a workflow that maintains itself.
Right. Yeah, exactly.
Yeah, exactly.
To answer the question from a slightly different point of view, if you don't have a template at all in your pre-existing package, it's a way to like adjust your package structure to be like sort of consistent with SunPy and with other packages that have that template, and that has a lot of benefits. I mean, it's already been mentioned, the maintenance, but then also if you have issues, or problems, then you can sort of talk to the SunPy people, and maybe your issue is exactly the same as something that someone else has already solved because your package structure is exactly the same. It also then means that you're working with a package. If you want to then contribute to another package, like say NDCube, because you're using NDCube, if NDCube has the same package structure, you'll start working in that and you'll feel right at home. So the barrier to jumping back and forth between packages.
Yeah, I did not want to develop this package on my own, so I went straight to the SunPy package.
Does that answer the question, Micah, or do you still have other concerns?
I guess a bit. I'm still not really clear, like functionally, when you have an existing Python package that works, other than the GitHub search and standardization, I'm not really clear
Yeah, so I'm gonna actually push
what it
back.
functionally does.
Okay.
I think if you have one, if you plan to have like one project that you maintain, there probably isn't actually any benefit for. I think in Steve's case and SunPy case, we have so many repositories. If you're planning to spin out so many repositories, maintaining them becomes a burden. If you have one, and you're happy to tweak the layout of thing as things change, or people, as people point them out to you.
I think that's the key point, right? Is that if you've got one package, and I don't know, you're maintaining, instrument pi, and you can either choose to keep on top of tweaks to Python packaging, update versions of things like build systems and whatever else as it kind of goes on. Like these things don't tend to happen on very short timescales, but over like multi-year timescales, things tend to evolve a little bit in your package config files or whatever you need to like. And if you don't keep up, eventually it becomes a like big undertaking to like update stuff. So you can either choose to like just kind of keep abreast of that a little bit and as part of your regular maintenance, or if you wanted to, the idea would be you could like just rely on Open Astronomy to update your configs every month or like however long that takes.
To answer a slightly different question to the one that was asked, i.e. one that wasn't asked at all. If you are starting a package from scratch, presumably the benefit of going with a template is, like Steve said, he didn't want to develop it all on his own. And there are a lot of things that are kind of just done for you. And so it's a quicker way of getting started. But
oh yeah,
if you
absolutely.
already, yeah, okay.
Yeah, and your explanations there make a lot more sense now.
Okay, great.
Yeah, for example, Steve has had setup.py open. Setup.py is being removed on a...
I know, yes.
No, we have...
I don't want to do that. I don't want to do that myself.
No, but that's what I'm going to say, right? If you aren't aware of this fact that in 2 years setup.py is going to stop working and it's going to break everything.
That's right.
A template model allows you to not have to worry about this, and hopefully a bot updates it for you before it breaks. If you're willing to keep abreast of these changes, then you might not need that.
Yeah.
And that's a choice.
Yeah.
It's a choice you would have to make for your package.
Are there any other questions from other? Sorry, Steve.
I am still confused by what project pyproject.toml can be used for and what Pi be used for right now, because we're in this weird in-between zone.
Well, I mean, it's 5:45 in the evening. That is only a question that's.
It's a question. I'm happy to.
Yeah, but the answer is not short.
Yeah.
And
No, I don't want to know. I don't want to know.
I mean, I think you're making the case for that, right, Steve? Even if like you use the package template, at some point your package exists, you have these two files in your repo, and you're like, what do they do? I don't know, but my package is installed, so I don't care. But then and then for some reason, setup.py goes away entirely, then you want to have someone else to do that work for you. You don't have to understand.
Yep. Yeah, exactly.
So are there any other questions from other instrument team representatives on this? Anything that's not clear that we could help you by answering a question?
Or even someone not on an instrument team.
Well, yeah, anyone online, yeah.
No, only instrument.
Sorry, yeah. I guess not. All right, Steve, do you want to continue? And how much more do we have to discuss?
No, I think I'm mostly done. I mean, you guys can see that, we are already facing this issue because we have 5 packages that I have to maintain and keep them all, together. So even right now, like I found, an issue with the template in one of them. I have to do that, 4 other times. So I want to move to, cookie cutter. I was using the cookie cutter at first, but ran into some problems, and so kind of abandoned it. But yeah, having everything with cookie cutter and then with the that was it Cruft or whatever updates things. Like I want that now, not later.
The fact you found Craft is makes me very happy. I mean, I will not be drawn on timelines, but working on the SunPy and Open Astronomy packaging template is like the top priority thing that's on my to-do list for the SunPy grant we have. So.
Yeah. So I'd love to be part of this conversation because I think I'll be messing around with it as well.
Cool.
Yeah.
Okay.
All right. I think that's it. That's it for me on this subject.
Great. I would say because of the color of the CO2 monitor, I would ask, are there any other final comments or questions from people online, including but not limited to instrument teams? Okay.
Well, thanks everyone for dialing in, and also thanks Laura for taking like a gargantuan amount of notes.
Yeah, I'm
like,
sorry,
I
I don't, please don't judge me on that. Please go someone, like, if it's about your instrument, just make sure I'm.
No, I think that's like a very valuable record for what we talked about today, so thanks. All right.
Yeah, thank you everyone for joining online, and particularly the instrument teams, and giving us an insight into your needs and your practices.
Yeah,
it's very helpful.
And I think I will probably follow up with an email about a future meeting for this group, maybe on like kind of a month cadence at least to begin with. So.
Sounds good.
All right.
Yeah. All right. Pub.
Yeah.
Pub with more oxygen than we have in here.